After a long discussion with the development team, we agreed on the following architecture and technologies. First, we decided to go with a microservices architecture with Spring Boot 3 and Spring Cloud. And this is the diagram of our future application that we will implement for our client. Now click on Send. Alright, so here we see that we have 200 and we have the ID of the newly created order. So now let's open the browser and check the mail and see if we receive an email with the information that you specified and the template that you specified before. So I will open a new tab and open my localhost 1080, and here we have two emails. So the first one, we have an order confirmation. So we have order details for the customer John Doe, and this is the order reference, that the one that we created. We'll create a new one and we will change the customer also. And here we see the information or the list of the products, which is the product name with the quantity and the price, and we have here a total amount. And here we see another email, which is the payment successfully processed. So payment confirmation. Hey, what's going on guys, and welcome back to this new video. In today's video, I will guide you step by step to the implementation of an e-commerce application using the microservices architecture. So I know that you always have been waiting for so long for this video, and now it's the time. So in this application or in this video, I will guide you to the implementation, starting from the business requirement to designing the application, applying the DDD approach, and also we will see so many distributed patterns like configuration service to externalize the configuration of our applications or our different microservices, a discovery server where we can register the different microservices, and then API gateway that will connect and collect the different microservices from the discovery server and then route the application. And of course, we will see so many other things, like how we can establish a synchronous communication between our different microservices. And in this part, we will see two different ways. First, we will see how to use Feign, and then how to use the classic one, which is REST template. So you have more and more options to choose when it comes to real-world applications. So this is not yet the end. Also, we will implement an asynchronous communication between our different microservices using Kafka as a message broker. So I will show you how to set up Kafka, also how to configure all the requirements and do all the configurations in order to make Kafka communicate like in an advanced way between the different microservices. Also, our application supports email sending. So we will implement a notification service that will consume the topics from Kafka and send emails from there. We all know that in a microservices architecture, sometimes it's really hard to determine what was the flow or the path of executing one query from the API service or from the API gateway to the end service, or like what are the spans or the different services that has been executed. So for that, we will set up a distributed tracing using Zipkin. After that, we come to the most important part when we implement any type of application independently from the architecture. So here we talk about security, and for that, I will show you how to integrate Keycloak within a microservices architecture application. So for that, we will see how to set up Keycloak, how to configure a realm, how to create a client, and how to connect our Keycloak to our architecture in order to secure our ecosystem. So this is briefly the application that we will build together during this video. But here, let me tell you a little bit about the requirements for this video. So first, you need to know about Spring Boot. So if you are not familiar with Spring Boot, I would like to invite you to check the video that I will post in here in my YouTube channel, so you can learn and get all the knowledge that you need for a Spring Boot application. So how to work with Spring Boot, how to deal with the framework, how to learn or how to use the framework. Then we will use Kafka as mentioned. So for that also, I will attach the video for this one, so I recommend watching it before going or like completing this video, or you can just pause the video when it comes to the Kafka part and then like check Kafka, check the video, watch it, and then you can come back and continue this one. And of course, when it comes to the infrastructure and the tools that we need to implement our application, like the databases like MongoDB, PostgreSQL, Kafka, and so on and so forth. We'll use Docker, and I will show you how to set up Docker and what are the requirements and the necessary configurations in order to have a complete and up and working infrastructure for our microservices architecture. The source code of this application is available in the description of this video. And also you can check it directly on my GitHub account and just search for microservices and you will find the repo there. And of course, don't forget to follow me on GitHub to get all the news and all the repos and all the code that I will be pushing in the future. And also don't forget to start the repo and share it with your friends. Now, before we start, if you're new to my channel, just go ahead and hit the subscribe button, give me a thumbs up, and let me help share this video to more and more people, and let's spread the knowledge all together. And now, with no further ado, let's get started and let's start coding our microservices architecture application. So now, I wish you happy learning. First, let's start with a business requirement. Let's imagine and pretend that a client contacted us and he needs us to implement an e-commerce application. So first, let's go through the requirements. So our customer has a problem. So as a business owner in the e-commerce sector, I'm currently operating without the aid of any digital solution. So this means that our client is operating manually about everything. So let's have a look on the business requirements, or like what is the business of our client. So my product line consists of a variety of items, each identified by a unique code and accompanied by a detailed description. The customers interact with my business by placing orders from this list of products, and I identify my customers using their first name, last name, email, and address. Each customer transaction involves a specific payment method. And upon the completion of a successful payment transaction, I take the responsibility to inform the customer via an email confirming the success of their payment, or conversely notifying them of any payment failure. And in a bid of a streamline operations and promote growth within my business, I'm looking to invest in the development of a dedicated application. So the application will serve to simplify my business process and contribute significantly to the overall efficiency and scalability of my online venture. So this is the requirement that was sent by our client. And the next step is we need to translate and transform this small business requirement into an application. So let's go ahead and walk through how we will design this application. As always, the first step is to design the application starting from the business requirement provided by our client. So our client mentioned that he has customers interacting with his products to place orders and perform payments and so on and so forth. So here in the top part and the green one, we talk about a customer. So he mentioned that a customer is identified by a unique ID, first name, last name, and email. And each customer has an address. So that's why we have two entities or two classes or models presenting the customer information. So here we have a customer and we have an address. Then he mentioned that each customer, he needs to pass or to order some products. So that's why we come to the product part, where a product is identified by a name description. But for us as engineers, we need to come with extra solutions. So we need to discuss with the client and propose some functionalities and propose few things. So the customer did not mention anything about the available quantity or prices or something like that. So we need to discuss and ask questions. So that's why after discussion with the client, he mentioned and he approved that yes, we need to have an available quantity and a price. So then also we proposed that we need to classify the products by categories. So that's why we need an entity or a class category, and it will be displayed or organized by name and description. And since we talk about an e-commerce application, a customer and products, so each customer needs or can place or order many products. So now in order to organize and have a better organization of our orders, we came up with this order and order line. So the order is just to identify the order with an ID, for example, an order date to keep tracing, and also an order reference in order to have something well organized within the orders. And each customer can order multiple products. So this is where and when we can introduce this new entity, which is order line. And this order line will have an ID and a quantity. And of course, this will be the association entity between the order and the product, because when we talk about the direct link or the direct relationship between an order and products, we will have a many to many. So an order contains many products, and a product can figure out in many orders. So that's why we have, or we created, a new entity called order line. Then we talk about payment. So each order should have a payment, and the payment will be identified with an ID, a reference, amount, and a status. So since the client mentioned that the payment can be successful or failure, so that's why we need to have a status. So once the order is placed and the payment is successfully performed, we need to send a notification to our customer. So that's why we have here a notification entity. And the goal of this notification entity is to keep trace what we send to the customer. So here we will have an ID, we will have a sender. So the sender will be always our system or the client. And the recipient will be the customer here. And of course, we will have a content and a date when we send this notification. So this is the global design of our application. So this is how we transform the small business requirement sent by our client into a system design or a design of our future database or our future application. After several meetings with our client, we discussed few things. Among them, the changes or the small changes that we introduced into our class diagram. And then we tried to discuss more things. And the owner or the business owner, he mentioned few things that led us to the decision how we will design or how we will implement our future application. So he mentioned that he, as a business owner, he would like to that the application, he wants it to be resilient to failure. So ensuring that if one component goes down, it does not bring the entire system to a halt. So for example, if the customer part is not available, or if we are not able to create a new customer, so the whole system should not go down, and we should be also able to place orders for other customers. Then our client mentioned that he wants to run some marketing campaigns and bring new customers. And for that, he mentioned something about scalability. And he said that as a business owner, I want my application to be scalable to handle increasing traffic and workload demands. So this introduces us to something important, which is the scalability of the application. And then we spoke about the development and the time or the required time to implement the application. So he mentioned something about faster development or the speed of the development. So he said that as a business owner, I aim for rapid development and deployment of new features and updates to stay competitive in the market. Then he mentioned also something we discussed about something else, which is like enhanced monitoring and debugging. So he didn't know about debugging, so we had to explain what debugging is, and we explained things in a way that he can understand it, since he's not coming from a technical area. So he mentioned that as a business owner, I require comprehensive monitoring and debugging capabilities to ensure the scalability and performance of my application. So these were the first or the second discussions with our client about the future application. So from that, or from these discussions, we decided as a team or as a development team to go with one specific software architecture. So since our client mentioned that he wants his application to be resilient, to be scalable, he wants also a faster development, he wants also in the future a continuous deployment and enhanced monitoring and debugging. So for that, we decided to go with the microservices architecture for our application. And when we talk about microservices, the first thing that we need to discuss about, or the first thing that we need to put in place, is to apply the DDD, or the domain-driven design. This means what? This means that we need to identify the different domains of our application. So for our case, now let's go and see how we were able to identify or to split our design or application design into domains. So here in the top part of this diagram, we see that we have a customer domain. So we need to manage customers for our application. So now we talk about the global application, but we will break it down into small parts or small domains. So here, as mentioned, we have a customer domain. So a customer is identified by the customer entity and the address entity. So now let's not talk about these relationships between the domains. We will explain them in just a few moments. Then, after the customer, we have our product domain. So the product is identified by the product and the category. Then, a customer needs to place orders. So we have an order domain, or we came up with, or we decided to have an order domain containing the order and the order line. Then, of course, we have payment and we have notification domain. So the payment will take care of all the payment processing, and the notification domain will take care of notifying the users and the customers of our application about their order details, payment details, and so forth. So in this way, we were able to cut down or to split down our application into small domains. And as you can see here, we have 5 domains: customer domain, product domain, order domain, payment domain, and notification domain. So here, let me explain how we would take care or break down these relationships that we see between the different entities. So this will be more clear in the next diagram that we will discuss together, which is we need to ensure a communication between the customers. But before talking about the communication, so let's see it, or let's discuss about it from a database diagram perspective, or from database perspective. So here, when we have this relationship between the customer and the order, this means that in the order table, we will have an ID of the customer who placed the order. So all we need to do when we talk about microservices architecture and domain-driven design, all we need to do is we will not have this relationship right here. We will just have a customer ID in the order table. All right, so like we have exactly in a real world, or like in a single database. But the only thing that, for example, when we talk about Spring and Hibernate, we will not have a customer reference or a customer object in this order table, and in the other way, we will not have a list of orders in the customer table, but we will have just a reference. Not this reference, but we will just have the customer ID placed in the order, and in the customer we will have nothing about the orders. But if we want to fetch the list of orders by customer, all we need to do is to query this domain and to send an HTTP request or a synchronous request, depends on the decision or the technical decision that we will take later on. So all we need to do is to tell this domain to send us back all the orders where the customer ID is the customer that we sent as a parameter, for example. And this applies for all the other things. So for example, when we talk about order line and product, all we need to do is to have an order line, or we need to have a product ID in the order line table or the order line entity. From the product, in the same way, if we need to fetch all the orders or all the order lines by product, or for a specific product, all we need to do is to query this domain. This applies also in the same way for the payment domain, notification domain, and also along with the order domain. So this is how our future domain diagram or domain-driven design was applied in order to break down the application into smaller domains. So as I mentioned, we identify 5 domains. Just to remind you: customer domain, product domain, order domain, payment domain, and a notification domain. So now we identified the different domains. What we need to implement next is to set up or to draw an architecture diagram of our application. After a long discussion with the development team, we agreed on the following architecture and technologies. First, we decided to go with a microservices architecture with Spring Boot 3 and Spring Cloud. And this is the diagram of our future application that we will implement for our client. So here, first of all, we identify or we see that we have our 5 microservices or 5 domains that we saw previously. So here we have a customer, product, order, payment, and notification. So for the customer, we decided to go with a MongoDB and a NoSQL database. So going with MongoDB is not a technical choice. Just don't tell anyone. It's just for showcasing to see and to showcase that we can use different database systems when we work with microservices, since each microservice will have its own database. Then we will have our product microservice that will communicate with with a Postgres SQL database, and all the databases will be running on Docker. Then we have our order microservice, payment microservice, and then we have the notification microservice. All the microservices and all the ecosystem will be running in a private network, so no service will be exposed to the public. So after that, we identify that we need to set up or to use some distributed patterns. And for that, we decided that we need to externalize all the configurations for all the microservices. So that's why here we have our config server will be a microservice based on Spring Boot 3 and also Spring Cloud. So this will be our config server where we will store all the configurations for all the microservices that we see in here, like customer, products, payment, order, and notification. So also, we need to register all the microservices so they can be seen and accessible via our API gateway. And for that, we need to set up and configure a Eureka server or a discovery server. Then we need one single entry point for all our services. And here, as you can see, we will expose only 3 microservices. So here we have a customer. So for example, the user can register himself or create a customer, or even the owner and the admin user can create customers using our customer microservice. Then we need to create and adapt and update and adjust our products. So for that, we see here that we have the list of products or the microservice that will take care of the products. That's why we have our API gateway that will point or will allow us to communicate with the product microservice. And since our application is mainly about placing orders and an e-commerce application, so that's why we will also have a route from the API gateway to our order microservice. Then, when we talk about notification, we don't want to block the whole application and make it long and so heavy in order to process everything. So once the payment is processed and also the order is processed, we will send all the data asynchronously to a message broker. And for this case, we will use Kafka. And for Kafka, it will be an advanced usage. It's not a simple usage, just sending a string, a message and consuming it. But I will show you how we will implement Kafka, or how we can use Kafka in a bit advanced way. All right, so here, as I mentioned, the payment will send a payment confirmation to our broker, and then this payment confirmation will be consumed by our notification microservice, and then we will send an SMS. Well, not an SMS, but we will send an email, and we will store this notification into our MongoDB database. In the same way, once the order is processed, we will send an order confirmation. So when a user passes an order, we will process the order, request a payment, and once the order is processed, we will send an order confirmation, and then the payment will be also processed in a parallel way, and once the payment is successful or a failure, we will send also another payment confirmation or a payment failure to our message broker. And as I mentioned, all these messages will be consumed by our notification service. And of course, since we spoke about distributed tracing and monitoring, we will be using Zipkin for distributed tracing in order to see or to trace all the requests that have been sent or processed by our ecosystem. So in the future, we will also enhance this part, and we will be using an ELK stack, which is Elasticsearch, Logstash, and Kibana stack, in order to have better monitoring and better dashboard to monitor our full application. And here, as mentioned, and as you can see in this diagram, the application will be publicly available only via the API gateway, and in the future we will also implement the front-end part for this full application. So again, let's see the full flow of our application. So first, we have our different microservices, and all the microservices, they will pull the configuration from our config server. And when each microservice starts, he will register himself into our discovery service, which will be our Eureka server. And then the API gateway will contact and connect to our Eureka server in order to get all the services that are registered in here. And then in our API gateway, we will define routes to the public or like the publicly accessible microservices. And in this case, we decided that we will have only customers, products, and orders microservices that will be accessible via our API gateway. And here, for example, we don't need to expose or to have a specific route for the payment, since the payment will be only an internal microservice, will be only used by the order microservice. So now let's discuss how the flow of this full application will be. So here, let's imagine, for example, that a user wants to place an order. So let's start from the bottom side. So when a user places an order with the required information, like for example, the customer ID, the list of products, and so the quantity, the price, and so on and so forth. So what we will be doing? So the order microservice will first connect or contact the customer microservice in order to make sure that the customer ID that we received as a parameter already exists with all the required information. So for example, in the future, maybe we can decide that we want to disable a customer, that we want, for example, to block a customer, and so on and so forth. So we need to contact the customer microservice in order to make sure that the customer is eligible to place an order. Once we have, for example, a successful response from the customer microservice, we need then to contact and to query few data from the product. So we need also to make sure that the products that have been placed as an order already exist and have an available stock quantity in this system. So for example, if the user wants to order a product with an ID 1 and this product only has 2 pieces available in the system, and the user wants to place, for example, 4 pieces or 4 elements as a quantity, we need to block the request and send an error message to our user telling that no sufficient quantity for this product that you want to place. So this is the first process, and this is how the first part will be communicating together. Once everything is fine, so once we have the customer, also once we have all the products available with the required and the requested quantity, we will process the order. So we will save the order into our system, and then we will send an email confirmation or an order confirmation to our broker, and then we will start the payment process. So we will also send a request to our payment server or service in order to start processing the payment for this order. And then once the payment is successful, we will persist it and save it into the payment database, and then we will send an async payment confirmation to our broker. And then our notification system will consume two two topics, or we will consume two messages or two types of messages. We will see the details of the async communication later on. So the notification service, first, for example, when we receive the order confirmation, we will consume it, process it, send an email, and save the confirmation or save the email that has been sent into the database. The same way for the payment. So the user will receive mainly two emails. One email for confirming the order, and another email for the payment confirmation, or for the payment denial, for example, if the payment was not successful. So this is the global overview of our application. And of course, as mentioned before, all you see inside here will have a distributed tracing using Zipkin, and in the future we will upgrade this one to the ELK stack as mentioned before. So this is the global overview and the global diagram of our application. Now we can start and we can move to the implementation of our application. So first we will go and we will use, as always, the monorepo approach. So before, many of you asked me how to set up this monorepo approach, or how to set up our working space as a monorepo approach. So all you need to do is to choose a folder or a destination where you want to set up your working space. And then using IntelliJ, all you need to do is to do File and then Open, and then just select the folder and click on Open. And you will have in the beginning this exactly structure. So here you will have the folder name, and you will have this idea.idea folder, and that's it. So in the beginning, this is all we need to do. So now to start, first I will create few folders in order to organize my application. So the first thing, I will create something, a folder, I will call it diagrams, and in here I will place, or I will leave the diagram that we saw together in this folder. And then I will create another folder, and I will call it resources. And here I will leave, or I will place a few resources for you, like for example the PowerPoint that we saw together and all this stuff. And then I will create another folder, and I will call it services. So services will be the folder that will contain all the services and the microservices that we will implement together. So here, just make sure you have these three folders, or at least the services folder. So the diagrams and the resources are not mandatory. They are just for you in order to have all the resources that you need. Now we can go ahead and start creating the different services. But before that, we need to set up our infrastructure and create the required services and the required tools that we need to work on our application. So for example, I'm talking exactly and mainly about the Docker Compose file, where we will have our PostgreSQL, Postgres admin, MongoDB, MongoExpress, and also MailDev in order to start implementing our application step by step. So now let's move on to the next part and prepare our infrastructure file. Alright, now let's start creating our first file, which will be our docker-compose.yaml file. So only one dot. And here all we need to do is to set up or to create the services that we need for our application. So first, let's have our services, and then the first service will be Postgres. So Postgres. And now I will give my container a name, and I will call it ms for microservices _pg for PostgreSQL, and for Postgres, and then _SQL. And for the image, I will use the PostgreSQL, or like the Postgres. And now I need to set some environment variables as always. So here we have first our Postgres _user. And for this case, I will call it Alibu, for example. And then we have our Postgres password, and I will call it again, for example, also Alibu. So like here, you feel free to have a better username and password, but for my case, it should be also fine. And now we need to have our Postgres data. This is where we will map, or like we will set up our PostgreSQL data. So by default, PostgreSQL works under var/lib/PostgreSQL, and slash data. So this is the PG data. Now we are done with this part, or the environments. We can set up few volumes. So before setting up the volumes, I will scroll down to the bottom right here, and I will create all the volumes that we will need later on. So first I will create volumes, and the first one will be Postgres, and the second one I will create another one for Postgres admin. I need colon here, and finally we will create one for Mongo. Alright, so we are done with the volumes, and before moving forward I will also prepare my network. So here I will create networks, and I will call it microservices-net, like for network, and then I will use the driver bridge. Alright, so now we are done with the basic setup for our Docker Compose file. We can move on and continue the implementation or the setup of our different containers that we will use. So here let's specify volumes, and for the volumes I will use PostgreSQL for and this exactly same path. So it will be PostgreSQL or Postgres, which is this name right here, and then colon, and then which part we want it to be persistent. So which is this one where we have the data of our PostgreSQL. So now then we need to expose some ports. And as always, you know that PostgreSQL operates on 5432, and we will expose it over 5432. So this is the container port, and this is our external port that we will be using. So now let's assign this one to a network, and then for the network, let's say our microservices network. And I will add one final option, so which is the restart, and I wanted to restart unless stopped. So here unless stopped, so if this container is stopped, I want to perform an automatic restart. So this part, or like this, the next service, which will be our PG admin or Postgres admin. So this Postgres admin is mainly for the people who are not using or who do not have access to the IntelliJ Ultimate version, because this option right here, this database option right here, only available for the Ultimate version of IntelliJ. So otherwise you can use this PG admin, and I will show you how to use it once we finish the setup. So let's give our container a name, and again it will be MS for microservices PG admin, and then let's use the image, which is I think it's called the page slash PG admin 4. Yes, that's it. And then let's set up few environments, and here we have a PG admin _ default email. So like this is just to set up the default email. So we will use a value in this way. So PG admin and then default _ email. So default _ email colon, and then I will use dash PG admin. By the way, all this is available on Docker Hub. When you go for the PG admin container or image, you will find all these details already in the README file or in the description of this container. And here at pgadmin.org. Alright, so this is the first one. The second one, I will define a PG admin or Postgres admin default password. And then the value, it will be again in this way. So PG admin and then default _ password. So here, whether we use this one, admin, yes, and then colon, and here let's say admin as a default password. So I will add another environment variable, which is PG admin or Postgres admin config server mode, and I will set it to false. So let's set it here, and a false with a capital F. Alright, so this is the configuration of our Postgres admin. Now let's add some volumes. And for the volumes, I will add my pgadmin, and then I will do it over /var/lib/pgadmin. So just in order to have something or like a persistent volume for our container. Then we need to expose some ports, and by default pgadmin works exposes the port 80, but since the port 80 might be used, so I will be using the port 5050. Just you can choose any port. Like you do not need, or like you should not, or it's not a must to use the same configurations or the same values as I do. It's just, as I mentioned before, just for showcasing. Now let's assign this to our microservices network. So here network in this way, and we can remove also the colons. So like exactly in this way that we did it before. So once we have the network, also we can add the restart unless stopped. And now we are done with the setup of our Postgres SQL and Postgres admin. So the next one is to set up our MongoDB. So I will create another service, MongoDB, and I will give it a container name. And let's say, for example, Mongo_DB or MS, just to follow the same pattern, microservice MongoDB. And then I will have some ports. Before the ports, we need, of course, the image, which will be Mongo. And then we can expose the ports. By default, MongoDB operates over the 27017 port, so we can use also the 27017 port. All right, so now we need to add a volume. So the volume will be Mongo and then :/data. And finally, we need to set up some environment variables. So the first one will be Mongo init db _root _username. So this will be the username, and let's say Alibu, for example. And in the same way, we have the Mongo init db root and then password. And I will also set it as Alibu. So like both of them are fine. Also, by the way, here you see that we define the environment variables in this way, but also if you see something like this also correct. So like we can use it in this way. All right. So let me set it in a different way, so at least we learn new thing every time. So here Mongo init db root username and Mongo init db password. So this is the setup for our MongoDB container. Now we can move on to our Mongo-Express. So here you can call it anything you want, by the way. So first we need an image. So the image will be Mongo Express, and let's give it a container name, and let's call it ms_Mongo_Express as a container name. So here, let me just reverse them. And here we have the container name. So for example, let's say restart always. So I want my Mongo Express to be always restarted, like when it stopped, for example. And then let's expose some ports. So the port, we will expose the 8081 over the 8081. So Mongo Express operates on these ports. Now we need to set up few environment variables. And here we can use this same representation. And here the first one, it will be me -config or like _config MongoDB. So MongoDB _admin username equals, and let's use also Alibu. And here I will duplicate it, and here instead of admin username, it will be admin password. The final one, it will be me _config _MongoDB, and here instead of admin, it will be server. And for the server, we know that we want to use our MongoDB server, which is this one. So now we are done with the basic configuration. Since we want to implement a notification service with sending the emails, you also know that which tool or which service that we will set up next. So we will use our mail dev. All right, so this we can set it up in a later phase, but we can do it now. So the container name, I will call it ms_mail underscore dev. You can also use dashes, by the way, it's also fine. And the images, we will be using mail dev / mail dev. All right, so then we need to expose some ports, 1080 over 1080 for the UI, and the 1025 over 1025 for the SMTP server. So now we are done with the setup of our infrastructure. All we need to do is to run and start all the services and make sure that everything is working fine. And we need to check it or to see it also in the dashboard. So what I will be doing, I will just run the docker compose up -d for detached mode. And we need to make sure that all the containers are starting correctly. So this is the case. So like we created the volumes, the networks and everything. And here we have all the servers are all the containers are up and running and started. We can also make sure and ensure that everything is running fine using the Docker dashboard. So let's go ahead and check it. So here in our Docker dashboard, we see that we have this e-commerce app, and we see all the applications or all the containers up and running among MS Mongo Express, which is like you will see it sometimes flickering because it's always restarting. We can also add or like change this option. Here, if we go back here to our Mongo Express and we said restart always, and here we can say, for example, unless stopped. All right, so now let's bring down, or like let's say Docker compose down to stop all the containers. And we can start it again, and we will make sure that all the containers are up and running and everything is fine. So now let's just go to the browser and start do some checking. For example, we want to make sure that the Postgres admin is up and running, also as well as the Mongo Express and so forth. All right, so now if I go to my browser and try to reach the localhost 5050 this one, it will be automatically added. So this is the port of our Postgres admin. So this one, this PG admin, you remember we exposed it over the port 5050. So now if I go back to my browser, the first thing we will be prompted to define a root password or a password for PG admin. You can choose anything. For my case, I will be using root, but in the future, I will not be using this interface since I have everything in IntelliJ. So it's just for you in case you don't have the ultimate version. So now all you need to do is to add a new server, and here you just give it a name, and then the connection, you give it for example, the remote address or the host name address, the port, username, password, and all you need to do is to click save and start using PG admin as your tool to check or to have all the databases in one place. So this is the first thing. The second, we will also try to reach out and to see if our Mongo Express is up and running. So all we need to do is to go to localhost and then the port 8081. So let's change this one. 8081, and now let's see if this can be reached. All right, so it seems that Mongo Express is not accessible, and let's check our dashboard. So here we see that it's not able to connect, so authentication failed. Let's go back and check what we made wrong. So this is the configuration of our Mongo Express, and here we have admin user and admin. Okay, so here we have the typo. It's admin password, not admin a password. So all I need to do is to run docker compose down again and docker compose up -d. And now we normally, like logically, we should be able to reach out our Mongo Express. So now we have everything up and running. And if I go back to my browser, refresh this page, and here we see that we have our Mongo Express. So this we will be using Mongo Express in order to check the databases and the data for the microservices that will be using the MongoDB database. Alright, so now we are done with the configuration and the setup of our infrastructure. So it's not the final setup. Of course, like when we progress and when we advance in the implementation of our application, we will add the required or the necessary services one by one. So now we can start implementing the different services of our application. So all you need to do is to follow along. First of all, we will start by creating our first microservices patterns. So we will start first of all with the configuration service and discovery service. So for that, we will go to the Spring Initializer and choose Maven project. Here, the latest version at the time of the recording of this video is 3.2.5. Now let's add some metadata. So for the group, I will call it com.alibu, and for the artifact, I will call it config server, config-server. So this will be our configuration server, and here this is just a demo description, or this is the description of our project. So we can leave it as it is, or for example we can just say config server as a description. So here I will just change the package name to com.alibu.config server. So I will be using jar file and Java 17, and now we need to add one dependency. Alright, so for now we will add only one dependency, and later on we will add other dependencies, and I will show you and then explain to you why we need them when the time comes. Alright, so now the dependency that we need to do is to search for config server. Alright, so here you see that we have config server, which is central management for configuration via Git, SVN, or HashiCorp Vault. So let's select this one, and here we can go quickly and check the dependency. So here it should be 2301 for the Spring Cloud version, and here we have our Spring config server dependency and the starter test, and so on and so forth. So all we need to do is just to click on download and then take the zip file and extract it. So let's do it together. So first I will download this one. And then all we need to do is to go to our working space, and inside this services folder, all you need to do is to extract the folder there. And then I will show you how to do that. Alright, now we see that under our folder called services, we have this config server project. So now, as you can see, it's not recognized even as a Java project or as a Maven project. So what we need to do is to import this one into our working space. So how to do that? So all you need to do is to go to File, and then New, and then Module from existing source. And then all you need to do is to navigate to the location of your working space and select the pom.xml file and click on Open. So now this will start reading the Maven project and load it as a project. So now, just to make sure that it's a project, so you will see this small square or rectangle, the blue one right here. So now if we navigate, for example, to our Java resources, so here we can see that we have this default main, and like the annotations are recognized, and so forth. So now let's start first of all by configuring our configuration service. So the first thing that we need to do is in our config server application, the main one, all we need is to add an annotation called enable config server. So this is the first one. So this is what we need to do first. And then in order to set up and tell Spring where are the locations of our different configurations, we need to add some properties. So here I will go to the application properties, and first I will rename it because, you know, I prefer using YAML over properties. And now all I need to do is to provide few information. So first let's change this one to YAML representation, and then colon, and then config server. So this will be the name of our application. And now we are missing this indentation right here. So now let's start adding few properties. So first I will specify the server.port for my application. So I will use the port 8080. So like 4 times 8. So let me also remove these empty lines. So this will be the server port for our application. And then for the profiles, we can say, for example, spring.profiles.active, and here we can set it to native. So this means that we want to use the native profile. All right. So after that, we have another property. So this where comes the Spring Cloud configuration. So here we will have spring.cloud and then .config. And after that, we have config server. So like this, spring.cloud.config.server and then .native. So then what we need to do, so like natively or by default, where Spring config server or our configuration server should fetch or should search for the locations of our different configuration files or configuration files for each configuration or for each microservice in our application. So here I will add a property called search location. And by the way, we can also configure this to fetch the locations or to fetch the data or the configuration files from GitHub, for example, or from any remote repository. So for this one, I will use class path. So I will show you later on what will this be, and then configurations. So this will be the location of our configuration files. So the class path means this one. So the class path is this location, this resources right here. And then I will create a folder and I will call it configurations, and then I will paste it. All right. So now we have our configurations folder, and there we will place all the configuration files that are required or for each microservice that we will implement all together. So now, for now, what we did is only we have our configuration or config server, which will store all the configurations for all the other microservices. So now we can just go ahead and try to start our config server application and see if everything is up and running and if we are able to run the application. So as you can see here, started config server application in 1.2 seconds and so on and so forth. So now this means that the application is up and running. All right, so I can stop this one right here, and then I will show you how I run several services all together. So now we are done with the config server. What we need to implement next is our discovery server. And you might ask the question why I started with those ones. So first of all, we need our config server because we need to store all the configurations for the future microservices that we will implement. And then we need our discovery server because we want, when we start or when we run an application, we want to automatically register them into our discovery server. So that's why, or like this is the decision or the reason behind starting with these two microservices before any other microservice. So for example, the API gateway, the distributed tracing, and so on and so forth, this we will implement later on because it's not a mandatory step or something that will block us from doing. Even like if you want, config server is not something that we should try or like we should start with it in the beginning, so we can start implementing the different microservices independently, and then we can add the different distributed patterns like config server, discovery, and so on and so forth. But for us, let's start by preparing everything, and then we will see all the things working together smoothly. All right, so now we can move on and start implementing our discovery servers. All right, now we can create our discovery service. So for this time, I will not use the Spring Initializer because so many of you asked how we can create it using IntelliJ, or why I do not create my projects using IntelliJ. So for me, it's just preference. I prefer using the web version, but let me also show you how to create it using IntelliJ. So here, all you need to do is to select services and then go to file and then new and then project. And in here, all you need to do is to specify your working space or your working location, or the location where you want to create this folder. And as you can see here, we are under e-commerce app and then services, which is this folder right here. So now let's call this one discovery. So this will be our discovery server, and in the group ID it will be com.alibu, and for the artifact it will be discovery. And then, for example, for the package name, it will be this one, so we can keep it as it is, and it will be Java 17. And here, don't forget to click or to select Maven. All right, so let's click on next, and now it's time to start selecting the dependencies. All right, so here, all we need to do is to select or to search for our config server. And then we'll just need to search for config server. All right, and here you will find two. So the config server is the one that we used previously to create or to add this dependency to our configuration server. And now we need our config client, since this is the one that will allow an application to connect to a Spring config server and fetch the configuration from there. So this will be the first dependency. And we need then, let's search for Eureka. And now we need our Eureka discovery server. So like we have discovery client and we have Eureka server. So for this one, we need our Eureka server because this is the Eureka or the discovery project that we want to create. So these are the two dependencies that we need. So just to remind you, the config client is the one we need to fetch the configuration, or like to that will allow us to connect to the configuration server and fetch the configurations. And the Eureka server is because we want to create, or we want to consider this Eureka or this configuration, not the configuration, but the current microservice that we are building, we want it to be our discovery server. So now all we need to do is to click on create. So this will open a project in a different or in a new instance of IntelliJ, but let's close this one. And in the same way, so as you can see here, this config server is considered as a Maven module, but this one not. So here we have two options, whether we go again with file and then new and then module from existing sources, and we select the pom.xml file, or from here, from this Maven, we can add another one. So we can add a module, and here you see that we have discovery, and all I need to do is to click on pom.xml and open it, so it will be loaded and considered as a Java project. All right, so now let's move on and proceed to the configuration of our discovery service. So the first thing we need to do, we need to go to source and then main, Java, and discovery application. So the first thing, we need to add an annotation, which is called enable Eureka server. So enable Eureka server. So this means that we want to enable our discovery service. All right. So then we need to tell this microservice or this discovery service from where or from which location he should fetch the configuration. Since we have in our application, we have here the Spring Cloud Starter configuration. So this is the configuration server or the configuration client, and it comes already with the auto configuration and so on and so forth. But we need to provide few information. So here, let me rename this one to YAML file. And here there is one thing which is very important. We need to leave, or like we need to set up this application.name. And here let's call it discovery, for example, or let's call it discovery service. All right. So this name is very important, right? Okay. So then we have Spring and then cloud and then config, and we have an option called import. So this from which location we want to fetch our configuration. So here we have something called optional. So this means that if we cannot find the configuration of our microservice, like we don't want the application to fail, let's also try to start it. And then we have config server and then colon, and now we need to specify the URL of our configuration server. So we mentioned, or you remember, that our configuration server runs already on the port 8888. All right, so we need to remember that one. So here we have localhost colon 4 times 8, and that's it. All right, so here I think we have a typo. So it's not Spring Cloud, it's just Spring config and then import. So Spring config and then we have import. So this from where we can import our location. So it's not spring.cloud, but it's just Spring config and then import. And here all we need to do is to specify the application name. So this application name, why I mentioned that this is important and we need to pay attention to this one, because when we go back to our configuration server and when we start the configuration, so now we will write and add some configuration to our config or to our discovery service. All right, so how to do that? So the way to do this is we need to go to our config server under configurations. Let's do right click and then let's create a file. So the file, I will call it exactly the application name of the current one that I'm configuring. So in this case, it's called discovery server. So .yaml, so I will use the YAML representation, and now we can start adding some configuration or the configuration for my discovery service. So then when we start our config server, and after that we start our discovery server, our discovery service will connect to the config server, and it will try to fetch the configuration using this application.name. So it will try to look for a configuration called discovery-service.yaml or property. So like both of them are fine. All right. So like you can use any representation you want. So now let's add some configuration to our discovery service. So here we have Eureka, and then colon, and then we have instance, and then host name. So here we need to define the host name. So it's local host. All right. So this will be the instance name or the host name of our discovery service. So here I just want to I can recommend something. So before writing or typing the configurations directly in the discovery service, since we don't have the discovery server dependency, so we will not have the auto completion. So the way to do it, one of the ways that I recommend, what we can do is we can come here and start typing or adding the properties, and then we can take them and put them in the discovery service or in the configuration service inside the discovery service.yaml file. All right, so here let me show you what I was writing. So here instance, and then we have host name. So instance host name. So now we mentioned that this one will be localhost, since we will run first of all the application locally, and then at the same level as instance. So it will be eureka.client and then register with Eureka. So the register with Eureka, it's by default true. All right. So this one is by default true, and we want to set it to false when it comes to Eureka itself. So this means that the discovery service should not register himself into himself. So you see this is the problem. That's why we need to set it to register with Eureka. Also for this one, you might find it sometimes in this way. So in a camel case, register with Eureka, this is also correct, and this does not pose any issue, because this is the property that we have already in our Eureka client configuration bin. All right, so both of them are correct. All right, so the next one we have fetch registry. So fetch registry, we will say false. We don't want to fetch the registry or the discovery service, because now we are configuring Eureka itself. So this will change when we implement it or when we add it to another one. So again, here, as I mentioned, we can use it, we can use this way of writing. So if you see both, or in the documentation or somewhere else, you see it written differently. So this is not false. All right, and then finally we have our service URL, and for the service URL, and then we have default, so service URL, and then we have default zone. So here we have service URL and then default zone. So this just to define the default zone of our Eureka service. So for that, we will use something like this: HTTP and then : / and here we can reference to this one. All right, so we can reference to this variable. So it will be eureka.instance.hostname. So as you can see, if I navigate, so if I highlight it, so it's automatically highlighting also this one. All right, so then we need another variable. So we need to mention the server.port. All right. So we don't have it yet, but we will add this property just in a few seconds. / Eureka and then /. So this / is important. Okay. So don't forget about this one. Now let's give our Eureka configuration. Let's give it, let's specify the server port. So here I will add server.port, and we will run this one over 8761. This port. All right, so here you see that now we are pointing this port to this one. So this is using environment variables. Alright, so this is the configuration of our Eureka server. So as I mentioned before, all we need to do is to take this one, cut it, and then we need just to place it in here. So now we are 100% sure that we did not introduce any typo, or we have something like this. Alright, so now to make sure that the application is up and running and everything is well configured, what we need to do, so we will come here to services. Alright, so here we have the Docker services, but we can add other services. So here we have run configuration type, and we can search for Spring Boot. Okay, so for Spring Boot, so this will add, or like will fetch and update automatically all the available services that we have. So here, this is our configuration service application, and this is our discovery application. So what we need to do is first to run our config server, because we have all the configuration stored there. And when we run another application, we need to make sure that the server is up and running. So here you see that when the application runs, it will display the port of the application. So now let's run our discovery application and make sure that the application is up and running or not. So here we are able to fetch the information, and now all we need to do is to go to our browser URL, for example, and try to reach this URL with this port. So let's go ahead and try it out. So now in the browser, I will try localhost and 8761, and this is the Spring Eureka UI. So for now, we don't have any instances registered to our Eureka instance or to our Eureka server, but later on when we start implementing one of the services and register them to the Eureka, we will start seeing the list of the services registered in here. Alright, so now that's why we mentioned, like when we mentioned that we don't want that Eureka to register himself into the registry service, this is why we do not see anything so far. Alright, so let's go back. We can stop all of them. And now we can move on to the implementation of our very first microservice. Alright, so from our architecture diagram, we are done with the implementation and configuration of our config server, as well as our Eureka server, which fetches the information and the configuration from our config server. And now we need to start implementing the different microservices that we have. So here we will start with our customer microservice. So the customer microservice will include few dependencies. So among them, like the Spring or like the MongoDB dependency, and we need two other dependencies. Like as we did for Eureka server, we need first of all our config server client or config client in order to allow the customer microservice to fetch the configuration from the config server. Also, we need to add the Eureka client. So here we use the Eureka server because we consider this one as our server or our discovery server. Now we need the client in order to allow our customer to register himself into the Eureka server. So now all we need to do is to create this customer microservice and start implementing the microservice for customers. So let's go ahead. Now let's open this one. And here inside services, in the same way, I will go to file, new, and then project. So here I will call this one, I will call it customer. So customer, again, Maven project. So the package or the group ID, it will be com.alibu, and the artifact, it will be customer. So then for the package name, I will not leave it customer, but I will call it e-commerce. All right, so like I will have the same package name for almost all the microservices. All right, so now we have this one. Let's go and click on next. So first, let's search for MongoDB. So Spring Data MongoDB. So this is the first one. And then we need to search for Eureka. But for this one, we need to select the Eureka Discovery Client. Then we need our configuration service or config client. For this one, it's like under Spring Cloud config. So it's called config client. All right. And of course, we need now our Spring Web. So let's go back to the classic dependencies. We need Spring Web. We need also validation or the Spring starter data validation. And that's it. All right. So also let's not forget our Lombok. So like the famous annotation for less boilerplate code. And that's it. So now let's go ahead and click on create and import our project into as a Maven project. So in the same way, let's go to Maven plus, and now we have customer pom.xml, and then click on open, and this will start loading our customer module or customer project. So it's not a modular application, but it's just a mono repo. And in order to have all of them working, as I mentioned, all we need to do is to go to Maven and then add Maven project and select the pom.xml and hit OK. Alright, so now let's open our customer project. Let's here open the resources and application.properties. Let's switch it to YAML. And now let's add few configurations. So first, let me break this down. Same here. And now it's called customer. So our application name, we will call it customer application or customer service, for example. All right, so here I will call it customer service. And now we will start adding few information. So first, I will add a server port. So for this one, I will run it over 8090. So like the choice of the port numbers is like 100% random for me. All right. So like you can choose any port number, just don't mix up when you use it in the future in the different projects. All right. So now let's add some configuration. So it's Spring data, and then we have MongoDB. And then we have username. So the username we chose Alibu, and for the password also we mentioned that it's Alibu, so it's in the Docker Compose file. We have here, or we need to define the host, not hosts. So it will be localhost. So here it's not additional hosts, but just host. And then we need to specify the port, which is 27017 for MongoDB, and the database. So the database, we want it to be customer. All right. So like, let's call it customer. And here we need to specify also the authentication database, which is admin. All right. So this is the configuration. All I need to do is to take this configuration from here. Let me just cut it. And let's create in the config server under source main resources and configuration. And let's create a new file. Let's call it customer-service.yaml. And we can paste this one. So here we don't need this application name because we only need it in our, or like in the customer service configuration itself. So let me remove this one. So the configuration looks exactly this way. Spring data MongoDB, and then we have the server port of our application. So now if we go back here, we can just paste this one again. And now we have almost our configuration for the customer service. Now we just need to specify a few things. So now we need our config and then import. And now we need the optional option and then config server. And now we need to specify the HTTP localhost // and then localhost and then the port 8x8. All right. And that's it. So now we have the basic configuration of our customer microservice. So before that, let me show you something. So now I will start my config server again, and then I will start the discovery server, and finally I will start the customer application without implementing anything. All right. So my config server is running. Let's run the discovery server. And now we will run our customer server or customer application. So then we will see first, like if the application is up and running, which is yes. And now if we go back to the browser and refresh this page, and here you see that we have our customer service. All right. And the status is up, and this is where the application is available. So like this is the link for the application. So for example, if we include a health endpoint, or for example, like a basic endpoint, we will be able to access it via this URL. All right. So now we have everything up and running. We are able to fetch the configuration. And also if we try to go to Mongo Express, normally we should see right here Okay, so for the database, it's not yet available. When we insert the first data, it will be also ready in here. All right, so now we are done with the configuration. So now let's move on to the implementation of our customer microservice. All right, so here just one thing I need to mention. So here, like, the customer application did not start correctly because we made a typo when we specified the host name. So like it was specified as localhost, not without the L. So all I did is just to fix the typo. All right, so if you missed this one, just go ahead and fix it. So now let's close our config server and let's start implementing our customer application. So under sources, main Java. So here first I will start by creating a document. So I will create a folder called customer, and then I will create a customer class. So customer.java, I can make this one full screen. First I will add few annotations. So all args constructor and no args constructor. I need also a getter, or let's first start or add the builder. And we have the getter, we have the setter. And now to make this one as a document, we need to add the document annotation from MongoDB. All right, so now let's add few attributes as specified in the class diagram that we defined together. So here I will have a private string ID, and this one will be the ID of my document. And then we will have a private string first name, and then private string last name. All right, so be patient with me, guys. We have also private string email, and finally we will have a private address. So for the address, we don't have it yet. We need to go ahead and create another document called address. So here let's create a class address in the same package, and now let's specify a few information for this address. So I will copy all these annotations first. So like no need to retype everything manually. So here instead of document, so it's not a document, I will just add a validated to this one because we need to add validations later on. All right, so here for this, we have a private string street. So this is what, like, the attributes that we defined together. I want to have also a private string house number. And then I want to have a private string zip code. All right. Okay, so this is the two documents, or like, let's say, like the representation of a customer within a MongoDB database. Now let's start with creating a customer controller, and from there we will create all the required classes and services and so forth. So let me create a customer controller class. Let me make it full screen, and let's add few annotations. So REST controller first of all, and then we have a request mapping, and for this one I want it to be /API/v1/customer. And then we need the required args constructor annotation. And now first I will create a private final customer service. So it's a class that we don't have yet, and I will call it service. So let's go ahead and create this class in the same package. And all I will do is to add the service annotation. We will go back, or like we will come back to the implementation of this one later on. So now the first thing, I want to add a post mapping, which is a method that I will use in order to create a customer. All right, so a public response entity of type string. So I'll just return the ID of the newly created customer. So let's call it create customer. And here we need to require few things. So first we have our request body, and this one, it should be a valid one. All right, so like we need to add validations. So I will call it customer request, and let's call it just request. So we don't have this customer request yet. So all we need to do is to go ahead and create this customer request class, or we can make it a record. So let me create it as a record. So create record customer, and we will come back to the properties that we want to include later on. So now after this one, all I need to do is to return a response entity.ok, and then let's call our service.create customer method. So create customer, and then we need to pass our request. So we don't have this create customer yet, so let's go ahead and create it, and it should return a string. So for now, let's keep it return null. And the first thing that we need to do is this customer request object. So let's specify a few attributes for it. So for this, we will need exactly the same information that you specified here. So like you can just change the names or change anything you want, but just since this is just a showcase and we want to simplify things, so that's why I will use the same attributes from our document. All right, so here let's add a comma instead, and that's it. So the address, we will use the same address object, so like no need to create another to repeat another address object just to use it as a representation. So just to simplify things, we will use the same one. All right, so now I will just add few validation annotations. So here this should not be null, so like it's not null, and I will add the message, for example, customer first name is required, and let me duplicate it also for the last name. And here we have customer last name. In the same way, we want it for the email. So customer email is required. And now I will use also the email annotation for the validation. And here, let's say, for example, customer email is not a valid email address. Is not a valid email address, for example. And here for this address right here, since we added also in this one, we added this validated annotation. This means that this object will be also included in the validation. So in case we add validation annotations, it will be also considered. All right, so let's move on with the implementation of our service, or of our first method, which is create customer in our customer service. So now I need to add my required args constructor annotation from Lombok, and I will inject my first service. So here I will create a private final customer service, or sorry, not service, but customer repository, which we don't have yet, and let's call it repository. So let's go ahead and create an interface. As you can see here, I'm selecting interface. So let's create an interface customer repository. So for this customer repository, it's like a simple one. All we need to do is to extend our Mongo repository interface. And here we have customer. So it's customer and then string as the ID. All right, we can close this one. Also, we need our private final customer mapper, and let's call it mapper. Of course, we don't have this one, so let's go ahead and create a class for it, and let's give it the service annotation. So if we need something or a method, we will implement it later on. So now let's go back to our customer service and let's finish implementing this first method. So now first I will just create a var customer equals my mapper, or we can do it in one line. So it will be repository.save, not save all, just save, and then mapper dot to customer, and then to customer from my request object. So you can also split it, so it's like totally fine. And then all I need to do is to return customer dot get ID. All right, so now since we need to implement this one, so let's go ahead and create a method for it. So I will just rename it first to remove the typo. So it's a customer, and now let's implement this two customer methods. And here, for example, all I need to do is to return customer customer.builder.build, and all I need to do is to specify the information that we have. So request.id, and we have first name, which is first name. We have also last name, which is last name. And we have address, which is our address object. So not address, but request.address. And of course we have email. All right, so now this is the mapping method. Also we can add here, for example, if you want to, we can add if request is null. We can whether return null or return just customer.builder.build, but for now let's say null, for example, as a null check. Okay, so now we can go back here, and create customer method is already implemented and done. Then we will go back to our controller and add a put mapping to update a customer. So in the same way, public response entity. And this will also, like this one, it will return a void. So we can have it a void, or we can have interrogation mark. So like both of them are correct. So let's keep void, for example, since we do not want to return anything. So I will call the method update customer. And for this update customer, we need, of course, our request body. And this request body, of course, should be valid. And here we have again our customer object request. So our customer request object, let's call it request. And now let's implement this method. So here, let's call service.update customer. And we need to pass the request as a parameter. And all we need to do is to return response entity.ok or .accepted, for example, accepted.build. Now we don't have this update customer. Let's go ahead and implement it. So let's go back to our customer service and implement this update customer method. All right. So now what we need to do, I will create a var. I will call it customer equals my repository dot find by ID, not the request, but the repository dot find by ID. And I need to pass request dot get ID. Request just dot ID, since it's a record. And now or else throw. So if we cannot find anything, I would like to throw an exception. So here I will create a new custom, I will create a custom exception, and I will call it customer not found exception. Just because I'm talking with the outside world, so I need to provide or to specify a dedicated exception. So first let's create this one, and let's create a class, and here I will create it under a package. I will call it exception. All right. So here not extends X, but extends runtime exception. So I will add an equals and hash code annotation with call super true. And I will add, for example, a data annotation. All right. So here all I need to include is a private final string MSG or message. So this equals and hash code and call super true because we just need to call the super class of this one. All right. So let's go back here, and now I will just need to provide my string message for this custom exception. All right, so here let's say, for example, that no customer cannot update customer, no customer found with the provided ID, something like this. All right, so let's use string.format method, and here let's say cannot update customer, and then customer. So let's fix this one, and here no customer found. No customer found with the provided ID, which is our %s. And here all I need to do is to add my request.id. So also now we can optimize this one by adding a static import, and it will be in this way. All right, so otherwise, if I find my customer stored in the database, I will create a method here and I will call it merge customer. So like merging a customer just to make sure that we do not override an existing property or existing value with a null value. That's it. So like this is the only reason. So I want to merge my customer with the request. And then all I need to do is to call the repository.save, and then I want to save my customer. So now let's create this merge customer method. So it will be a void. And now all I need to do is to perform a few checks. So here if string utils dot is blank. So if so let's use is not blank. So if it's not blank of my request dot first name, what I need to do, like this merge method is quite simple. So here all I need to do is to do customer dot set first name my request dot first name. That's it. So this just we want to perform a check. If we have the first name, so we update it. Otherwise, we do nothing. So I will duplicate this method and just perform a few changes. So this one last name, and here also last name, and finally we have email, and here let's set the email, and also in the same way we can do for address. So, but for the address, we cannot use the is not blank, but if we say this one is not null, so here we can say set address and request dot address, and that's it. All right, so now we have our update customer. We can also move on and start implementing our next method. Next, let's implement a get mapping to find all the customers. So let's add a get mapping. And then we will have a public response entity, and this one will be a type list of customer response. So customer response. So we will create this object in a few moments, and then find all. So we don't need any parameters, and all we need to do is to return a response entity.ok of my service dot find all. So dot find all customers. So let's call it this way, and semicolon. So first we need to create a class of, like customer response. So a typo again. So here let's fix it. Customer response, and our customer response will be a class including, or like we can even make it a record. So like this should be also fine. So let's use records, and for this one we will use almost the same as the customer request. All right, so except we don't have the validations. So just just copying, and just to make things a bit faster. All right, so let's remove the validation annotations, this one and also this one. Let's optimize the imports, and here is our customer response object. So now let's go ahead and create the find all customers method. And here all we need to do is to call our repository and find all the customers, map them, and then return the result. So here this will be return repository dot find all, and then let's stream over it, and then dot map. So when we map, so we can call our mapper and then from customer, for example. Or like maybe we can call it to customer response. Like feel free to choose the one you want, and then collect, and then collectors dot to list. So we don't have this from customer yet. So let's go ahead and create it, and this one should return a customer response. All right, so it's always a good practice to split the response and the request objects. So please go ahead and do that. So let's open our mapper, so which is here, and now let's create our object, or like our mapping information. So what we need to do is to return a new customer response, and now in the constructor we need to specify the following information. So it will be customer.getID, customer.getFirstName, and then customer.getLastName, then customer not ID but email, and finally customer.getAddress. And now we have our method. So now we will implement the next method. So the next method will be a check. All right, so we want to check if we have a customer or if a customer exists by ID. So it will be a get mapping, and then it will be slash exists slash, and then I need my customer dash ID. All right, so then all I need to do is to return a public response entity of type Boolean. All right, so this is just a check to see or to check if the customer exists or not. So I will call it exists by ID. And here we need our path variable, and let's call it customer ID as we specified it there. And all I need to do is customer ID. So now let's return a response entity dot OK, and then I need to call my service and then exists by ID. All right, so now all I need to do is to pass the customer ID. We don't have this method yet. Let's go ahead and implement it. So first let's fix the typo. So all I need to do is to return repository.find by ID, and then we need to pass the customer ID dot is present. So is present will return true or false. True if the customer exists, and false if not. Okay, so now we are done with this method. Let's now implement another method. So I can also copy this one because it's almost the same, but it will not be slash exists, but it's just find a customer by ID. All right, so here let's call it find by ID, and again we will have a customer ID, and here let's call this one find by ID. Let's go ahead and create the method in the same way. So yes, here we have a typo. This will be a customer response, and find by ID should also return a customer response. So here in the same way, let's return our repository.find by ID, and if we have it, let's map it to mapper.fromCustomer, or else we can throw an exception. So here I will throw a customer not found exception. So it will be a new customer not found exception. And here in the same way, I will use the format method. So for example, no customer found with the ID or the provided ID. And here, let's say plus ID. And here we need, of course, our %s. And here we have our customer ID. Let's fix this typo. And we are done with this find by ID method. So now I think we still need to implement one last method, which is deleting a customer. All right, so now let's add a delete mapping. And in the same way, we need also this one, like we need a customer ID, and we can copy also this one just to make things a bit faster. So this one, it will be a response entity of type void. And here, let's say delete by ID or delete a customer. All right, we need also our path variable. Let's copy it from here. And now all I need to do is to call my service.delete customer. And then we need to pass our customer ID. And then let's return a response entity dot accepted, for example, dot build. Now let's go and implement our delete customer method. And in this delete customer method, it's like just one line. So it's repository dot delete by ID and then customer ID. All right, so here we have two things. So first we have our customer not found exception, and also within our objects, for example, this customer request, as you can see in here, we have validations. So I think you got it, guys, but we need to think about handling the exceptions. All right, so let's create a class and let's call it global exception handler. Okay, so let me move it to a package I will call it handler, for example. And here move to package, and this is my package handler. So for this global exception handler, I will just create a REST controller advice to handle the different exceptions of my application. So here I will call it REST controller advice, like, well, not call it, but just add this annotation. And first, our first exception handler, it will be of type customer not found exception.class. So let's say a public response entity, and then I need to return, for example, let's say just a string, and here let's call it handle, for example. So let me make it full screen. And here, of course, we need our customer exception class. Let's call it exp for exception. So here, all I need to do is to return a response entity, and then I will add a status. So here, for example, it will be not found. So it will be part of HTTP status. So HTTP status from org.springframework.http.not-found, and then .body. And here, for example, we can get the body from our exception.getMessage, get MSG, which contains already the exception or the message. For example, here like cannot update customer, or no customer found, and so on and so forth. So this is the first one. The second one, we need also another exception handler. So I will just copy this one, and here we need to catch the method argument not valid exception. All right, in the same way, method argument not valid exception. So now, instead of returning a string, I will return an object. I will call it error response. So this error response, like, we will not use this predefined interface, but we will create all right, so here we need to create a class, and let's call it error response. So this error response will contain or will hold few information. All right, so we can also make it as a record. So we can let's use records in here, and we will have a map of string and a string. So like string, it will be the attribute, or like the failed ones, and the string, it will be the message. So for example, it will be first name should not be is required, and so forth. All right, so now let's implement, or let's go back to the implementation of this method. So in order to do it, let me start from here. We will fix this part later on. So here I will have first var errors. So I need to get the errors, or like I need to initialize a map equals new hash map, and a new hash map of string and string. All right, as we specified it in our record, the object that we just created. So now let's get our binding results. Dot get all errors, and then all I need to do is to, for each element, for each error that we have in here, we can use a lambda expression. And here, let's say, for example, var field name equals my error dot get field. So here, what we need to do in order to do that, we need to cast this object to a field error. So we have an object called field error, and then we can get field. All right, so this will be the field name, and here we will create another attribute or another variable. Let's call it error message equals error dot get default message. And now finally, all I need to do is my errors dot put, and then I need to put it for the field name and the error message. All right, so now all I need to do is to return a response entity, but here it will be a bad request, and the body will be my new response error. So here new response, new error response. And here all I need to specify is the errors that we extracted right here. All right, so now normally the customer service or the customer microservice is fully implemented. Now we can move on and see what we should implement next. All right, so now we are done with the implementation of our customer microservice. Let's move on and start implementing the product. So here, just let me remind you and give you one small comment why I chose to start with customer and product and payment and so on and so forth. Because here we see that customer does not have any dependency with any other microservice, the same for product and payments. And here for the order, we need to query things, and like we need to check data from the product microservice as well as from the customer, and then we need to send payment processing, or we need to start payment processing. and so forth. So this is the order how to start, or like how I personally start implementing the different microservices. So like within a team, you will just split different microservices and each team will implement one, and all you need to do is just to agree on the contract service between each one, and that's it. All right, so now in the same way, let's go back here and let's create a new service. So file and then new project, and in the same way I will call it product. Now I will choose Java and Maven project. So here for the group, it will be com.alibu, and then product. For the package name, I will use com.alibu.ecommerce as we did before. So let's click on next. Now let's add few dependencies. So first let's start with the config server, and here we need the client. Also we need discovery server and Eureka discovery client. Then of course we need web, Spring Web, and then Spring Data JPA. We need also validation, and we need also Flyway. So like for this project, we will use Flyway in order to perform a database migration, and we will not rely on creating everything from scratch, or like we won't let the application create the database and the tables and so forth. Of course, we need our Postgres SQL driver, and finally we need Lombok. So this is our project, and these are the dependencies that we need. So let me check if we need another thing or like another dependency, but I think this should be enough. If we forget something, we can just add it later on. So now all we need to do is to click on create, and in the same way, let's go to Maven here, add a new project, and let's select product and then pom.xml. And now we will have our product added here as a Maven project. So let's reduce this one, and now we have product. So the first thing, let's go and change this one to a YAML file. And here, as you can see, we have already a folder called DB, and inside it we have another folder called migration, and this one is automatically created when we integrate or we include the Flyway dependency. So now I will just adjust this one. So name, and let's call it product service. Okay, so we made a typo somewhere. So it should be product, and let's also rename this one. So let's rename the module product, and also let's rename the directory to product. Okay, so now this should be fine. And if we check here, we have product. So let's also change the name here. Let's like fix this typo, and everything should be fine. All right, so now before moving and adding the configuration into our config server for this product service, first let's connect to our database. So in here, let me make this one full screen. So here, just add and then search for Postgres SQL. Otherwise, if you don't have the ultimate version, you can use the Postgres admin for that. So here, as we mentioned before, it will be Alibu as username and password as specified in the Docker Compose file. And here we see that we have a success. So let's apply it. And now let's add a schema. So here we have Postgres SQL, and here we need to create a database. So I will right click and then database, and I will call it product. So product database, and then let's click OK. So now we have our product database. Let's go ahead and select it. So I think I created it in the wrong place. So let's recreate product database in here. Okay, so already exists. Let's just try to display it. And here we have, okay, so here we have product. All right, now it's there. So we have our product database. So here just I need to mention something, which is very important. So locally or on my local machine, I will use one instance or one database instance to create all my databases. So like I will use just this PostgreSQL instance in order to run all the databases. But and this just because I'm running out of resources and like my laptop will not support creating 3 or 4 instances. But for your case, and mainly when you move to production, be sure or make sure that each microservice has its own database. All right, so like services or microservices, they should not share the same database. All right, so now we have our product database. We can now move on and start the configuration of our product service. So again, let's go to config service and then source, main, resources, and then configuration. So here, let's just let me remind you, we called it product service. And then we need to create a file, productservice.yaml. All right. So now when we first configured everything like the customer service discovery and so on and so forth, we just forgot one small configuration. So here, normally we need to tell our configuration servers few things. For example, here in this place or also in the customer, also we need, for example, first we need to specify the Eureka instance. So it's by default, it will try to connect to it if it finds it. Otherwise, it will not be able to find it. Also, there is a property that we should not, or like, well, it depends on the application or on what we want to implement. Exact. So here, what I will do, since we know that configuration files, they inherit from each other, so I will create here a file and I will call it application.yaml. All right, so all the other configuration or all the other YAML files will inherit first from this one. For this, I will first specify Eureka and then instance and then host name. So here I will specify the host name of our Eureka server. So it will be localhost, and then we have Eureka and then client, and we have the service-URL. So you remember when we configured our Eureka server, we used the service URL with the capital U, and this time we can use it in this way. All right, so here we need to specify also the default zone. So default zone, and now all we need to do is to specify http://localhost and then 8761, which is the Eureka port /Eureka. All right, then, so here I will just give a default name, for example, or let me skip this one. Okay, so now I will add another Spring property, which is the following that I mentioned: Spring Cloud and then config. And then we have a property called override system properties, system-properties. And this one is by default true. So I want to set it to false because I don't want to override any properties. So this means what? This means when what we have here, for example, our product service.yaml. And here, if we override something, or like if we have another property defined already in here, so when we fetch the configuration from the config service, it will override all the configurations that we have in that specific service. So this is what we don't want to do. So that's why I set in here the Spring Cloud config override system properties equals false. All right, so now we are done with the main, or like with the generic configuration. We can go back to our product service and add this configuration to our product service. So in the same way we did before, let me close all tabs, and in product, let's open our application.yaml. Let's leave the Spring application name. And now all I will do first, I will add server port. And for this one, I will use 8050, for example. And now I will add some configurations for our Spring application. So here we have data source. So it's data source, and then we have username, or first let's start with the URL as always. So let me make it full screen. So URL, it will be again JDBC : PostgreSQL, and then : / and then the port. So localhost and then the port 5432 and slash product. So product is the name of the database we just created. So username Alibu and password again Alibu, and we need our driver class name, which is org.postgresql.driver. So now let's move on and add some JPA properties. So we have JPA and we have Hibernate, and then we have DDL Auto. So for this one, all we need to do is just to use validate, because we want to rely on Flyway to create the schema for us. Then we have database. We can specify the database as PostgreSQL, and then database platform, and we need to specify the dialect. So org.hibernate.dialect.PostgreSQL dialect. So this is the dialect that we will be using. Now let's add some Flyway configuration. So here we have Flyway, and then we have our baseline on migration. So it's by default false. So here, like this one means like whether we want to automatically call the baseline when migrating on non-empty schema. So here we want to set it to true, and also we want to enable it. So it's by default, it's true, but I just want to set it in case you want or we need to disable Flyway. So here, let's say baseline description. So the baseline description, how we want to describe our baseline. And here, let's say baseline version. By default, it's 1, and I want it to start from 0. And here, I can also specify the user and the password. And so the user and the password should be the same as this one. Okay. So now to make it dynamic, I can use Spring. So let me close this one. Spring.datasource.user name. Here it should be username, and here the same way, spring.datasource. Where is it? Okay, so spring.datasource.password. So like it will be using, so every time we change this one, we don't need to change it again in here. So like this one will reference this property right here. So now we have all the configurations that we need. Let's take this one and let's move it or put it in our product service. Except we need, as always, we need to remove the Spring application name because we need it only in here. All right, so now Spring, let's just leave application name. Let me make it full screen, and also we can delete the server.port. So now we have the base configuration of our product service. Now we just need to add few things right here. So now I need to add spring.config.import, and then optional, and then config server. And our config server is located under http://localhost, and then 4x8. That's it. So now our product is ready, or our product service is ready. Now again, if I start all the applications, we should see everything up and running and all the services registering into Eureka. So what we need to do next is, first we will start by creating the entities and create the schema or the script for creating the database, and even inserting some data, and so on and so forth. So it will be a classic implementation of our product microservice. All right, so now let's move on and start creating our different entities and start implementing our application. So here in our product microservice or product service, let's go to main Java, and then let's start creating the two entities that we need. So first I will create a package called product, and then a product class. So this one, let me make it full screen. Of course, we will need few annotations. So I will need all args constructor and no args constructor and the builder annotation, as well as I will need getter and setter. And finally, I need the entity annotation. So this is our product. Now we need to define few properties. So here I will have a private integer ID, and this one I will give it the ID annotation, as well as I want it to be a generated value. All right. Then, as we mentioned before, a product has a private string name. So like the product name, private string description. And then we have a private, let's say double, or even we can use, so we can use double for available quantity. Then we have a private big decimal. So like one advice, guys, when you work with money, like with currency or like with attributes that represent pricing or money, it's better always to go with a big decimal class, since it has a lot of methods and it's well optimized for this case. So let's call this one price. And finally, we will have a private category. So we don't have this class yet, but we will create it, and let's call it category. So for this category, it will be a many-to-one relationship from the side of the product, and I will add a join colon, call it name, and I will give it, for example, category underscore ID. So for this case, let's go ahead and create our class inside a new package, call it category. All right, so now this is the new package. So we have category and we have a product. So let's go ahead and create, or like prepare the product or the category entity that we just created. Okay, so I will just copy these annotations, paste them in here. And now we can also copy the ID from here, and I guess also name and description, something like this. So I guess we can copy all this, and this will be the representation of our category. And then of course we have a private list of product. Let's call it products, and for this one it will be a one-to-many annotation, and then mapped by category. So category here, like this mapped by, should be exactly the same name of this category variable or attribute right here. Also, I will add some cascading styling type. It will be a cascade type dot remove. So when I remove a category, or when I remove a product, I want to remove all. When I remove a category, I want to remove all the products that are related to this category. So like there is no reason behind this one, it's just a personal choice. I don't know why, but it's just a choice. Otherwise, like you can remove it, or we can even just get rid of this one. All right, so now we have the two entities, but we don't have the database, or like they are not present yet in the database, since we chose that we want. So here, if we open the product service in Flyway, here in this configuration, we said that we just want to validate our schema. We don't want to create anything. So let's start by a script that will init or create our database. So what we need to do, let's go to resources, and then inside this folder db migration. So if you forget to add the Flyway dependency from the beginning, so you will not have this folder created by default. Otherwise, the way to do it, just create a folder, call it db, and then inside the db create another folder, call it migration. Don't create a folder and call it db.migration, because this will not work. All right, so now let's move on and let's create our SQL script for initializing the database. So here, right click and then file. So now within Flyway, I already provided a video in my YouTube channel about how to integrate or how to use Flyway and the different configurations, namings, and so on and so forth. So here it will be the version, so like just for versioning, and now we need 2 times underscore. So this is important, and then the script name or the file name that you want to add. So database and then .sql. So let's make it full screen, and here I think we can also choose the dialect for Postgres SQL, and the session we can leave this one to default. Okay, so now let's together create the script. First, we will start by creating our category table. So I will do create table if not exist. So if we don't have the table, we want to create it, and our table is called category. And now let's open parentheses and let's start providing and defining our attributes. So we mentioned that we want to have an ID and of type integer. Of course, it should not be null since it's an ID, and then it's a primary key. All right, then we have description of type varchar, and let's say like by default the length would be 255. And again, or like finally, we have a name, for example, or like name and description name. It should be the same thing. All right, so now we want to add another table. So create, of course, here we don't forget the semicolon. So now create table if not exists product. Now let's open brackets and let's start defining this one, so we can also copy these three attributes, which is the ID, name, and description, and then we can define the rest. All right, so the next one is our available underscore quantity. Let's not forget the comma here. Available quantity, and I want it to be double and with the precision, and also it should not be null. All right, and then we have our price, not primary key, just price, and I want it to be a numeric type, and let's say 38 and 2 for precision, so like it can be up to 38 digits on the left hand side and 2 digits on the right hand side. Now we need to add the mapping or the relationship between our product and our category. So here, let's say we will have a category underscore ID as we named it in the category entity, in the product entity when we created the join. And this one I want it to be of type integer, and I will add a constraint. So let me move this one. So I want to add a constraint. So for the constraint, we can call it anything. All right, so like we can call it, or like we can give it a random name, or like primary key, or for example, foreign key, category, constraint, or something like that. And this is not a problem. And then references category, and that's it. All right, so again, semicolon. So here, maybe let me call it foreign key 1 and with something else. All right, so now we know that PostgreSQL, when we have generated values, it uses by default sequences. So let's create a sequence. So create sequence if not exists, of course. And here we know how PostgreSQL, or like how Hibernate names the sequences. So it will be the table name underscore seq. So it will be category sequence and then increment by 50. Since we know that the default incrementation of the sequences is 50. In the same way, let's create the product sequence. So product sequence increment by 50. Now, if I start the application, I should see my two tables getting created. All right. So now if we go ahead and start the application, we will see and we will find that these two tables are getting created with the foreign keys and with all the dependencies and all the referencing that we created all together. Okay, so let's go ahead and try this one. First, I will start my config server, since there I have the configuration. So I need this one to be running first. Now I can run my product application and see if I'm able to create this one. Okay, so could not find product application. I think when we renamed it, something happened. All right, so let's try to run it from here. And now we have our, okay. That's because we did not rename this one. So product application and then refactor and okay. Now it should be able to run it. All right, so all I did, like here, click or select the product Maven project, click on nlink Maven project and then import it again, and the problem will be fixed. So now let's go on and let's restart our product application. So Here we don't need the discovery service. It might be also throw an exception, but it's not a problem. This is not what we want to do. So our application is almost up and running. So let's go and check the database if something was created or not. So if we refresh in here, let's select the public schema and see if we have tables. And this is the case. So we have our category table and the product table. So for example, for the product, we see that we have a foreign key, category ID. Also, we see this flyway schema history, and this flyway schema history will display the history of the different versions and SQL scripts that we will run within our application. So now I think we made some good progress, and now we are ready to move on and start implementing our product microservice. All right, now let's start implementing our product controller. So I will create a new class and I will call it product controller. So here I will add the annotations, REST controller, and my request mapping, and it will be /API/v1/products. And of course I will need my required args constructor to inject my dependencies, and here we will need our private final product service, which we don't have yet, and we will create it in a few moments. So let's go ahead and create the product service class in the same package, and I will give it the annotation service and also the required args constructor, and we will come back to the implementation of this one later on. So now I will first start by defining the method that we will have or we will need in our product controller, and we will start by the first method to create a new product. So this one, it will be a post mapping, and it will be a public response entity of type integer, since our ID is of type integer. So when we create a product, all we need to do is to return the ID or just return accepted. So both are fine. All right, so here I will need my request body, and it should be valid since we will have validations, and I will call it product request. So let's call it request. And here let's go and create our product request record. Let's leave it empty for now, and we will add the information later on. Now all I need is to return a response entity.ok, okay, not accepted, and here I will call my service dot create product, and of course I need to pass the request as a parameter. All right, so now let's go ahead and create this method, leave it empty, and we will come back for it later on. So the next one, we need another method to purchase products. So we need to pass a list of product purchase request, for example, and it will return a list of product purchase response. So like the list of the products that we were able to purchase. So it will be again a post mapping. And for this one, I will add purchase as a path. And then it will be, as mentioned, a public response entity of type list of product purchase response, and I will call it purchase products. So for this one, as mentioned, we will need our request body, which is a list of product purchase request. Let's call it request, or well, not requests, but just a simple request. This should be fine. And here I will return a response entity dot OK, and then I will call my service dot purchase products, and then I will pass my request as a parameter. So the first thing, I will create a record of this object called product purchase response, and then I will need also another object. Let's also use a record, and it will be our product purchase request. So now let's go ahead and create and prepare this method. So it will return a list of product purchase response. All right, next one. It will be just finding a product by ID and another one to find all products. So this one, it will be a get mapping. And here slash, and then we need our product ID, and then public response entity of type product response. So here we will have another object. So we need to create another object, product response, and let's call this method find by ID. And we need to pass a path variable. And let's call it product-id. And it will be of type integer product ID. So now all I need to do is to return a response entity.ok. And then we need to call our service.findById. And of course, we need to pass the ID as a parameter. So let's go ahead and create our product response. Let's use record also in here. And now let's create our findById method. Now, finally, the last method is a get mapping again. And here it will be a public response entity. And here it will be a list of product response and find all. So in here in this method, don't forget to add pagination. We will add it later on, but for now, like, we need to have it paginated. All right. So we need to return a response entity.ok, and then we need to call our service.findAll. Let's create our findAll method. And now we can start implement the different parts of our controller. So in the same way here, if we go to product, we have this name, description, available quantity, and we have price and the category ID. This is what we need to pass as parameters to our record. All right. So this is the product request, and let me paste them in here. And also, if I use when I use shortcuts, you can see it in here in this pop-up. All right. So now let's add comma, and finally I will add my integer category ID. So now let's add some validation annotations. The first one, it will be a not null, and I will add a message. And for example, product name is required, just as a simple message. The same for the description, product description is required. The same for the quantity. So like for the quantity, we want it to be positive. So like, let's use the positive annotation. And here we will say like available quantity should be positive. So available quantity should be positive. And in the same way, we will use it for the price. And here, let's say price should be positive. And finally, we will add the not null annotation, and here product category is required. So product category is required. So this is the first object. Now we can move on to the product service. So let's implement this one. So we will fill the list of records one by one. So now let's start by implementing our product service method to create a new product. All right, so here, the first thing, we need to inject our product repository, the one that we don't have yet. Let's call it a repository, and we need, so let's make it final also. And also we will need a private final product mapper, and let's call it mapper. So we don't have yet these two classes. So the first one, it will be an interface, and then we need to extend JPA repository and of type product and integer. So this is so classic. We already know that. Now we need also to create a product mapper class, and let's give it the service annotation. So now if we go back here, first we need var product equals mapper.toProduct. And we need to pass our request as a parameter. So let's go ahead and implement this method. So this should return a product. And all we need to do is to return a product.builder.build, and we need to set the different parameters. So ID, it will be request.id, and we have name, it will be also our request.name, description, it will be also description, and we have a price, it will be also the price, so request.price. We have also available quantity, and it will be available quantity, and we need to set also the category. So the category, it will be also another object, category.builder.build, and here all I need to do is to set the ID of my category out of my request. All right, so maybe let me break this down so it will be more visible and more readable for you. And this is the first method, or the first mapping method. So once we map the product, all we need to do is just to save it. So let's return our repository.save. So it's repository.save and then product.getID. Not save all, it's just save.getID. So this is the create product. Then let's implement the find by, which is also an easy one. So here all I need to do is to return my repository.findById, and then I need to pass my product ID. If I have it, I need to map it. So I will call my mapper dot to product or from product or to product response to product response. And I can say or else. So or else throw, and I can throw, for example, a new entity not found exception. And I can say, for example, product not found with the ID plus my product ID. And then we need to implement this to product response method, and this one, it will return a product response. And this product response, it will contain few information like we have for the other one. So it will contain like the ID, the name, description, available quantity, the price, category ID, category name, and category description. So first let's go to this record, and we can paste the information that we have in here. So let me clean this up, and then we will have our integer category ID. Then we will have a string category name, and finally we will have a string category description. So this is my product response. Now we can go and implement the mapper. So here all I need to do is to return a new product response, and here all I need to do is to pass this information. So product.getID, and then product.getName, product.getDescription, and then product.getAvailable quantity, product.getPrice, and now I need my product.getCategory.ID. Okay, so this may be a little bit annoying. All right, so then we have our product.category.name, and finally we have our product.getCategory.description, and this is the mapping entity, the mapping method, sorry. So we can, in the same way, we can do the find all. So this one, it will be repository.findAll, and then I need to stream and map. So my mapper to product response, and then collect collectors to list. Now let's go and implement the purchase product. So purchasing a product, we need to perform few checks. First, we need to check if we have all the products, and we need to check the size. We need to check if we have the available quantities for all the products. We need to perform few checks, and then if everything is fine, we can go ahead and start purchasing our product. So let's go and start implementing this one. So the first thing I will need is to extract the product IDs from my request object. So here from my product purchase request, it will be a record, and in here I will add few information. So first I will have an integer product ID. So product ID, and I will need a double quantity. So this is all I need in order to purchase a product. So here what I want to do is to add a not null annotation. So with a message, for example, product is mandatory. So like I'm trying to change a little bit the messages, and here quantity is mandatory. All right, so now we have our purchase request object ready. So now let's first, as I mentioned, let's first start by extracting the IDs. All right, so here first I will create a variable. I will call it product IDs equals my request, and then I need just to stream over it and map my objects. So I want to map it. So I want to get my product purchase request or product IDs and then to list. All right. So this will return a list of product IDs. Okay. So then I need to check, or like I need to check if I have all these products available in my database. So for example, if we pass an ID that does not exist, or like a product ID that does not exist in our product service, we should block the request and return an exception. So here I will create another variable and I will call it stored products, just to say that these are the products from the database, and it will be a repository, and I will create a method and I will call it find all by IDs or by ID in. So like I need to pass a list of product IDs and then I will order it by ID. All right. So here I will pass also my product IDs as a parameter. So we don't have yet this method. So let's go ahead and create it. And this will return a list of products. All right. And that's it. So now if we go back here, what we need to do. So the first check, we need to check if my product IDs dot size is different from my stored product dot size. So this means that, for example, if the user wants to buy or to purchase 5 products, and when I query the products in the database, I only get 4. So for example, let's say that the user wants to buy the product with ID 1, 2, and 3, and in the database in here, I only have products with IDs 1, 2, and that's all. So I don't have a product with an ID equals 3. So in this case, we need to block the purchase request or the purchase process and return an exception to the user. So let me delete this one. And now in this case, all I need to do is to throw a new product purchase exception. So we will create this exception right now. And let's say, for example, 1 or more products does not exist. And that's it. So we don't have yet this exception. So let's go ahead and create it. So I will create a class and in a package called exception. All right. So this is create a class and exception. Okay, I think I will create it manually because my IDE, I think it's just making some problem. So I will create a class in exception.productPurchaseException. So this, let me make it full screen, extends runtime exception. And all I need to do is to add a constructor with a string message, and that's it. All right. So if we go back here, let's import this class and we are done with this part. All right, so once we make sure that we have all the products available, like the products that the user wants to purchase, they are available in our database. So here I will create a var stored request equals my request dot stream. And I will just sort the IDs. So here I will use the sorted method from the stream, and I will use comparator.comparing, and I want to compare my product purchase.product ID. So like I want to sort them by ID, and then .to list. Now we can start performing, or like we can start purchasing the different products. So for that, I will add a purchased products equals a new array list of type product purchase response. Product purchase response. And now all I need to do is to loop over my list of products. So here I can return my product purchase response, or purchased, it should be purchased products. And now all I need to do is to have a for loop. So for int I equals 0, I smaller than stored products dot size, and then I plus plus. So here a semicolon. And now all I need to do, first I will create a var product object equals stored products dot get at the index I. And then I will create another variable, which is my product request equals my stored products dot get I. So like here, like the product request and the product, both of them, I will get them from the stored products. So here it's stored request, not the stored product. So it's stored request. So let me also rename it. So that's why I couldn't see it. All right. So stored request. And then all I need to do is I need to check if the available quantity, so like I'm doing this just to check if I have the available quantity is less or equal to the requested quantity. All right. So here I will perform a check. So if my product.getAvailable, so like typos, product.getAvailable quantity, if it's less than my product request dot quantity. So in this case, we know that we cannot purchase this product. So in this case, I will throw a new product purchase exception. And now I will say, for example, insufficient stock quantity for product with ID. Let's fix this typo. So for product with ID, and here product request.get.id. So this is the check that I want to perform. I need to check that we are able, or we have a sufficient quantity to purchase this product. So if this is not the case, so if the quantity is sufficient and is available, so here I will create a new, like another object. I will call it new available quantity. So like I need to update. So for example, let's say that the product we have in the database, it has 10 available quantity equals 10, and now I want to purchase 3 of them. So like I need to update the available quantity and make it 7. All right. So now equals product dot get available quantity minus product request dot quantity. All right. So like we need to update this one, and then all I need to do is product dot set available quantity, the new available quantity. So just updating the quantity, and then I need to call my repository dot save, and I need to save the product. And finally, so here what I want to do, I want just to fill this purchased products list. Once we purchase a product, so I will do my product, my purchased products dot add, and now I will call, like I will create a mapper, or like a method in the mapper. So I will call it to product purchase response, and I will pass my product object and also the product request dot quantity, and that's it. So now in the product purchase response, it will be also a simple one. So here let's create this method, and now let's also fill this object. So since we didn't do it yet, so I will have an integer product ID, and also I will have a string name. So like this is the information about the product that we purchased, a string description, and then we will have a big decimal price, and finally we have a private, or like a double. All right, so this is my object, and now the mapping method will be super easy. All right, so now all I need to do is to return a new product purchase response, and here I need my product.getID, product.getName, and then product.getDescription, and finally we need the price from the product.getPrice, and finally we need the quantity that we passed as a parameter, so this quantity right here. All right, so now once we finish this implementation, so this is the end of this purchase product. So here let's just resume and re-explain the method. So first of all, I need to extract the list of the products ID, since I need to check that all the products that we want to purchase, they already exist in the database. So that's why we created a method find all by ID in. So like ID in, we need to pass a list of integers. So in here, as you can see in here, so it can be a list of integers, or we can also pass a simple array. Okay, so we can close this one. Yep. All right. So then, if the size of the two lists, so this product ID and the stored product IDs, so like I'm talking about the sizes, if the sizes are different, we know that that the IDs that we received in parameter, we have among them one or more product that does not exist in our database. Then first I stored, I extracted the IDs of my stored request, and then I created an object of purchased product, and then we need to perform a check to make sure that the quantity that we want to purchase is already available for that product. So for example, if I want to purchase 5 pieces, I need to make sure that the product has already 5 pieces or more available in my database, and then just updating or recalculating the available quantity and update my product, and then just return the list of the purchased products. Alright, so after implementing the product methods, or like the product service methods, we need to handle some exceptions. So I will just make it a bit faster. So I will go to customer and then Java, and I will copy the full handler package and I will paste it here in my product. So here I will paste it, and now we have our handler. So we have our global exception handler, and now all we need to do is to adjust it a little bit. So here we don't have this customer not found exception, but for this case we want to add our product purchase exception dot class, and in the same way here product purchase exception class, and for that we want to return a bad request. So it will be a bad request, and now instead of get msg it will be .get message. Also I can import this one statically. And then we have this method argument not valid exception, which also stays the same. We don't need to change it, and we need to add one other exception handler. So let me duplicate this method right here, and now all I need to do is to manage, or like to catch the entity not found exception dot class. So let's say entity not found exception, because here in our service, in our product service in here, we throw, when we get the find by ID, we are throwing the entity not found exception. Alright, so let me bring it back as full screen. So this is the one. So like even the entity not found exception, we need just to catch it and return a bad request. Or also we can, since our exception handler accepts a list of exceptions, we can add we can add also as here as a second parameter our entity not found exception, but for me I always want to separate things in case I want to have something specific. So in this case we are able to handle our exceptions. So let's optimize the imports so we get rid of this error, and now we need to do one final thing. So here in this database migration, we already created one first file to initialize or to init our database, like to create the schema of our database. So then I will ask ChatGPT, and I will provide this SQL or SQL script file, and I will ask ChatGPT to insert few data for me. So first I will create my file, and I will call it v2 underscore, like 2 times underscore insert underscore data.sql. So I will just ask ChatGPT and copy and just paste the result. All right, so this is the result from ChatGPT. So this is what he mentioned, and here let's say PostgreSQL and the default session. So this will be, or this script will insert few data into my database. So let's go ahead and try this out. So again, we need services. We need I need my config service to be running, and I will also run the discovery. So I will run all of them. So also we can see that we have all the application or all the services getting registered into the discovery service application. So I will start the customer, and finally I will start my product service. So let's wait for it. So now everything seems to be fine. So the first thing that I want to make sure that we have the data available in our database. So if I open the category, we see that we have computer keyboards, monitor, and so on and so forth. This is the data that we just inserted. And in the same way, we have this list of products with the available quantity, prices, category, and so forth. All right, so also if we go to the browser and refresh this page, we see here that we have customer service and product service. Both of them are up and registered into our discovery service. So now the next step is to go and implement so let's go back to our diagram right here. So we need to implement this order microservice and then payment, and finally we need to implement the notification. And after that, of course, we will set up Kafka and so on and so forth, and we will test the application. And of course, before that, we need to set up our API gateway. So let's move on and continue implementing our application. All right, so now we made good progress. So we are done with the customer microservice as well as the product microservice. So now we can move whether to payment or to the order microservice. But we will start with the order since it's related to product, customer, and also payment. So here in this one, we will implement the relation or like the communication with the product microservice and the customer microservice. And I will show you two ways how to do that. Then the order microservice needs to communicate with the payment in order to initiate a payment. But this one or this functionality, we will do it or like we will implement it once we finish the payment microservice. We will come back and update the order microservice. So we will leave it just as a to-do, as well as we need to establish an asynchronous communication between the order microservice and our Kafka broker. So also we will see how to customize or how to create a Kafka instance or to how to start a Kafka container from our Docker Compose file or like using Docker since like the tutorial that I provided about Kafka was like installing locally Kafka. So now it's the time to see how to install and set up Kafka on Docker Compose and using Docker. All right, so now what we need to do next is first to create the order microservice, configure the order microservice, and then we will start implementing it one by one. So in the same way, I can close this one. So here, let's click on new project, and then in the same path. So here, let's call it order. And now, of course, Maven and Java language. So here for the group, it will be com.alibu, and the artifact it will be order. And here in the package, I will call it in the same way e-commerce. So Java 17 and a jar file. So now let's go ahead and select few dependencies. So the dependencies that we will need for this one are like as always. So first we will need our Spring Web since we want a web application. Of course, Postgres SQL driver and Spring Data JPA since we will connect our microservice to an SQL database. And we need, of course, our Spring Starter validation and as well as discovery service client, like our Eureka discovery client. And we need also our config server client. So here we need the config client. Also, let's not forget about Lombok as always. So let's select also Lombok. And now for the synchronous or for the synchronous communication using the HTTP protocol, we will use two different ways. So like I will show you how to implement it using REST templates and also how to use OpenFeign. So let's search for OpenFeign. So maybe let's search for Feign. So here we have OpenFeign. So all we need to do is to select OpenFeign, and I guess that's it with the starters that we need for this microservice. So let's go ahead and click on create, and if we need something, we will add it later on. All right, so let's click create. So in the same way, let's go back here and then file, module from existing project, and let's select our order and then pom.xml file. So now let's click on open, and we will have our project loaded in here. All right, so now, as I mentioned, we have our project. So the first thing we need to do is to add the configuration. So let me change this one to a YAML file. And then, of course, we need to change the structure. Let me make it full screen. Oops, I made a typo, so I need to rename the file. So it should be YAML. and then we have Spring, application, and then name. So our application name is order-service as always. So now let's go and see what are the properties that we need to add. So the first thing, we can go back here to our config server and then main, resources, configuration, and we can take, for example, the product service, and we can take all this data source part. All right. So maybe we can copy all this one and then we can remove what we don't need. All right. So here I will paste everything. So let me move this up. Okay. And we can remove the flyway. We don't need it. And here we have Spring data source and then application name. All right. So here it will be order instead of product, and the username and password are the same. So here I will use create or update. So like we can also add flyway to the order microservice. So now that this is what we need, but I just will need to add a few other dependencies. So for the port, let's change it to 8070, for example. So here let's review what we have. So we have Spring data source, we have the URL, username, password, and the driver class name. We have the JPA, so we defined the DDL auto, we defined the database platform, and here of course we have the application name, since we will leave it in this file and we will move this configuration to our config server. So let me remove these extra spaces. So in here I will just start defining few other properties. So I will call it application, and then I will create like a subnaming, for example, config, and here I will create first my customer URL. So this will be the URL to connect to our customer microservice. So it will be http://localhost, and then the port. So here the port, there is something tricky in here. So normally we should here, so for example, like when we think about it for the first time, we say, okay, like I will just reach the customer service using this port right here. But since in our application, let me remind you, here in our application, what we have, so we can connect the order microservice directly to the customer microservice using its address and port, since both of them, or like all the microservices, are in the same private network, so we will be able to reach it. But we know that each microservice will register to the Eureka server. All right. So here we have two options: whether to fetch the information or to fetch the microservice URL from the Eureka server, or using the API gateway. And the question is why. So why we need to do that? Why we should not directly use the address and the port of the specific microservice? So when we talk about scaling the application, so for example, if we have high demand on the customer microservice, maybe we want to scale it up to 2, 3, 4, 5, and n instances at the same time. So in this case, the customer will have multiple instances with multiple, or like with different port. So the port can be also randomly generated. So we will not have an idea about which port we need to use in order to connect to our customer microservice, for example. And this applies to all the other microservices, by the way. So here, one of the ways is always to reach the microservice using the API gateway. Since the API gateway contains also a load balancer, so the API gateway will know all the instances of a specific microservice. So the order we connect to the API gateway, since it's public, it's a public URL and it's available publicly, and then the API gateway will redirect the request to the microservice with the load balancing also. All right, so this is how we need to think about it. So for now, just for the first phase, I will just use the port of this one, because like maybe we want to start testing it, but later on we need to change it. All right, so like maybe we will test the flow before even finishing the whole application, or maybe we will test it at the end. So for now, just I will set it to 8090. As I set it up in here, so like the service port of the customer service, it's 8090, and we know that all our APIs are under api/api/v1/customers. All right, so this is the first one. The second one, we need also another property. So here we need the product URL. So product URL. In the same way, we will do it as we did before. So we will use the 8050 port for this one. So let's go back in here and 8050, and it will be /API/v1/products. And as I mentioned, later on we will change this port to the port of our API gateway. And I will also just here I will make it just in advance, and I will create the URL or prepare the URL for the payment microservice. It's not yet implemented, but we can use it. So here, let's say it's payment, since we follow the same naming pattern. And here for the API, for the payment service, we can use, for example, the available port like 8050. Let's for the payment, let's maybe say it's 8060, for example. All right. Or what we can do in here, so we can just set it to this one. So for the API gateway, I always use the port 3x2 or like 8222. So we can set it from now to the port 822022. So here, just if you are running the application locally without the API gateway, so you can specify directly the port in here. Otherwise, just specify the port or the URL of our API gateway. So let's leave it this way, and we will come back to it later on. So now all I need to do is to copy this configuration, and now in the config server, in this place, all we need to do is to create an order-service.yaml. So this is the YAML file. Let's paste everything in here. And all we need to do is to remove this application.name. Now, if we come back in here, let's move all this and leave only the application.name. And we will also adapt and adjust the rest. All right, so now let's finish this one. So here we need our config.import. So we have optional, and then we have config server, and we know that our config server is under http:/localhost, and then the port 4x8. All right, so this is localhost, so like the same type as always. So here we have, this is the configuration of our application. All right, so now our order microservice is ready to use. And also just to remind you, here we have in the configuration, we have this application.yaml that all these configuration files will inherit from it. All right, so now we can close this one, close all tabs. And now we can come to the order microservice and start implementing it. All right, so the first thing that we need to do is, all right, so here let's open again the order, source, main, Java, and the first thing that we need to implement is to create the entities. All right, so let's start with the order entity. So I will create new class in a package called order, and I will create a class called order. Let me make it full screen. And now for this order, let's add few attributes. We will come back to the annotations later on. So here I will have a private integer ID, and I will need a private string reference, and then I will need a private big decimal total amount. So this will be the total amount of the order amount, and then we will have a private payment method. So this will be an enum containing all the payment methods that are supported by our application. So we will create it in a few moments. And then here, let me also show you again the domain diagram. So here we have our order, which is linked to our customer. And we mentioned before, when we work with microservices, and when after applying the DDD domain, or like the domain driven design, here if we have a relationship, all we need to do is to take the key or the ID of one entity and make it as a foreign key to the other entity. So like we don't need to add a constraint, since we cannot add a constraint since our databases are not connected. Or like not the databases, but the entities are not connected, or are not under the same database instance, or they are not even located in on the same server. So like we can have For example, the customer database on an AWS, the order database on Azure, for example, and we can have another one deployed locally or like on a VPS server or like on-premises server, and another one, for example, on Google, and so forth. All right. So now after the payment method, what we need is a private string customer ID. So a string because I know that my customer ID is of type string, since the customer application or the customer microservice uses a NoSQL database. So I know, because like we need to know this information in advance. So for example, if you are not sure, I think string can hold all the types of IDs. All right. So then what we need to do, we need also a private list of order lines. So here, let's say order line, and let's call it order lines. So we don't have this entity yet. We will create it later. Then I will have a private local date time. So this one, it will be created at, so I want to add some auditing. Also, I will need a private local date time, last modified date. And now let's start creating our other object. So first, let's start with the payment method. So I will create it as an enum in the same package. All right. So for the payment method, let's, for example, define few payment methods. Let's say that our application supports PayPal payment, credit card, for example. You can define as many as you want. Visa card, and let's say, for example, also MasterCard. I'm just trying. Okay, so let's add Bitcoin. That would be nice. All right. So here, let's say these are our payment methods. So this is, since this is an enum, we need to add the enumerated annotation. And here, let's say it's of type string. We can also import this one statically. So add static import, and now we have order line. So that we need to create the order line. So let's first just create a class, and I will create it in a package, and I will call it just order line. So I will change the package name, and now we have our order line. We will come for it and implement it later on. Okay, so now we need to start adding few annotations. So first, I will add the all args constructor, the no args constructor. So like maybe you don't need those, but for me it's just a habit. So I will add the builder annotation, or again like getter, like the classic annotations, like the classic Lombok annotations. Now we need the entity annotation, and then we need to add an entity listener. So here for the entity listener, we will use the auditing entity listener class, and here we will finally add table annotation, and we will give our table a name. So let's call it customer underscore order. All right. So here I'm using customer order, or like this table annotation, since the keyword order is already reserved. So that's why I called it customer order. So here we need to add the ID and also generated value, but we are not done yet. For this created at, or like created date, maybe let's make it let's rename it this way. So it will be a created date. And for this one, I will add also the colon annotation, and I will say it's updatable false. I don't want it to be updatable, and also nullable false. So let's duplicate this one. And for this, it will be last modified date. And now I will say insertable false. So like I don't want it to be insertable. And of course it can be nullable. All right. So here for the order line, we will change it, or like we will add the attributes in few seconds. So we know that one order can figure out in many order lines. So it will be a one to many. And we need our mapped by. So I will call it order, since I know we will call the attribute order in the order line. And now we are done with the implementation of our order entity. So again, let's go to the order line and add this few, or let's add the attributes for this one, and then we will start implementing the different services. All right, so here they can also copy, copy this annotations, paste them in here. And also we need our ID, so we can also copy it from here. Let me paste it in the order line. So now for the order line, we have a private order and then order. So for this one, it's a many to one, and then we need our join colon. So let's give it, the join colon, it's not mandatory, but we can also specify it. So if we don't specify the join colon will be by default named order and then ID. So order underscore ID. So this is how Hibernate and JPA, they compose the ID. So like it will be exactly named in this way. But I prefer always having my the full control over everything. So now we need also a private, and here we have an integer product ID. So here let's go back to the domain diagram, and here we have an order line is already connected or has a relationship with the product. All right, so the order line, or in each order line, we should see the reference to the product. So that's why we need to add the product ID in here. And then we have, of course, our private double quantity, and that's it. So we can also add a bunch of other information if you want. For example, you can add the price to keep trace of the selling price that was used at that moment, and so on and so forth. But we don't want to overcomplicate the application from business wise. All I want to do is to focus more on the implementation of the microservice architecture, and then we will extend the application step by step, mainly when it comes to the front end, when we will implement the front end for our application. All right, so now we are done with the implementation, or setting up these two entities. So now we have the required entities for our order domain or our order microservice. Now we will move on to the implementation of the order service. So we will create everything related to the order, and we will see how to do that. All right, first we will start by creating an order controller. So order controller class, and here I will add my REST controller annotation and request mapping. So let me make it full screen, and it will be /API/v1/orders. And of course I will need my required args constructor from Lombok, and that's it. So here, first we will start by creating a private final order service class. We don't have it yet. We will create it in a few moments. So we have a service. So let's create the class order service in the same package, and I will give it the service annotation as well as the required args constructor. So now we will start with the first method. So the first method will be create an order. So this will be a post mapping, and then it will be a public response entity of type integer. So I would just need to return the ID of the created order, or just returning a void, or whatever you want. So here let's call it create order. And for this create order, I will need a request body, and it should be also valid. And here I will create an object called order request. So we don't have this order request yet. We will create it in a few moments. All right, so now all I need to do is to return a response entity dot OK, and then my service dot create order, and I will pass my request as a parameter. So let's first start by creating a record for our order request. And for this record, we will need few information. So first I will need my integer ID. So the ID in case I want to update my order, and I will have a string reference. So the reference, we can also create a small algorithm that generates automatically the reference of our order. So let's call this one reference. And then we will need a big decimal amount. And of course, we need a payment method. So let's call it payment method. We need also a string customer ID. So we need to know for which customer this order is. And finally, we need a list of purchase request. So the purchase request, so this will hold the information of the list of the products that we want to purchase. So let's call it products. We don't have this purchase request yet, but we will create it in few seconds. All right, so before that, let's add a few annotations. So for the amount, I will add a positive annotation. So this is for the validation. And let's give it a message. So for example, order amount should be positive. So let's fix this typo, order amount. And then of course, another typo, positive. We will need also a not null annotation for the payment method. And here we say, for example, payment method should not be null, or like should be precised. All right, so then we need the same thing for the customer ID. So here, for example, for the customer ID, let's say, for example, customer should be present. So customer should be present. All right, so in the same way, I will use also not empty and not blank. So this one, it will be not empty and not blank. And in the same way, for these products, I will use the not empty annotation. And here, for example, I will add a message. You should at least purchase one product. Purchase one product. So since this not empty annotation, so here you see the supported types: char sequence, collection, map, and array. So that's why I used it in here. All right, now let's go ahead and create this purchase request record. So I will create a record and I will create a package. I will call it product. So here it's selecting the wrong target destination, but I will cancel this one and I will create it manually. So let me copy the name, and in here I will just create a new record in this place and product as a package. All right, so here we have our purchase record. So the purchase record, it will contain first a not null annotation and with a message. Product is mandatory, for example, and it will be an integer product ID. And then we will have also a positive annotation. So for example, a message like the quantity is mandatory, and it will be a double quantity. So for example, maybe for some products, we can order 1.2, 1.3 quantity of a specific product, for liquids, for example, or like for other types of products. So now if we go back here, we need to import this record, and now we are done with the order request. So then we can go back to our order line service or to our order controller, and let's go ahead and create our order method. All right, so now when creating this method, so we'll see what we need to do. So here we have a few steps that we need to perform. So here, first check the customer. So we need to check if we have our customer or not. So this is the first thing. And then we need to, so here, purchase the products. So purchasing the products is using the product microservice. So product microservice. Maybe let's make it this way. And then once we purchase the product, so here we need to persist order. So we need to persist the order object. And then what we need to do is to persist the order lines. All right, so once we persist the order lines, we need to issue or like to start payment process. So this one will be a to-do since we don't have our payment microservice ready yet. And then what we need to do is to send the order confirmation to our notification microservice. We don't have this one yet, but we will just use, so here we will use Kafka. So we need to send a message to our Kafka broker. All right, so now let's start with checking the customer. So for checking the customer, here we will use open Feign. So what we need to do is first to create a customer client. So I will start by creating a private final customer client, and I will call it customer client. We don't have this one yet, but we will just create it. So here I will create an interface and I will place it in the customer. Okay, so again, like the same issue. So I will create it manually. So here I will create a new interface in a package called customer.customer client. So here for the customer client, it's so easy. Like using OpenFeign is so simple. What we need to do is simply to add here at Feign client. And then for this Feign client, we need to give it two main information. So first, it will be our customer service. So like the name of this client. So this is customer service, and we need our URL. So the URL, of course, we need comma right here. So for the URL, we will use something like we'll use the interpolation in order to fetch the property from our properties file. So like I'm talking mainly about this property right here. So main resources, configuration, and then order service. So we need this customer URL. All right. So, and you see it's under application.config.customer URL. So let's go ahead and do it. So it's application.config.customer-URL. So now all we need to do is to add our method. So we know it's a get mapping, and we know from our customer, let me remind you in here. So in our customer microservice, we have here under source, main, Java, and then our customer controller. We have the /API/v1/customer, and we have a find customer by ID or find by ID, which is /customer ID. So all I need to do is to provide this information in here. So let me close all the unnecessary tabs. So it will be /customer ID. So this one, it will be an optional. So I will use the optional of an object. I will call it customer response. So I will create a record or a class customer response, and I will call this method find customer by ID. And then I need to pass, of course, my path variable, and it's called customer ID, and it's of type string customer ID. So like you can use ID or customer ID, like feel free to name it. So here, all I need to do is to create a record in the same package. Okay, so now like it's choosing the correct one. So here, let's go ahead and create our customer object response. So the customer object, so it will contain a string ID. So this will be the ID of our customer, a string first name, and string last name. And of course, we need the email since we want to send an email to the customer. All right, so when working with OpenFeign in here, when we work with OpenFeign, don't forget to add one important annotation. So we need to go back. So let me close all this. So we need to go back here to the order application, and here we need to enable Feign clients. And also here, when we implemented the order and the order line, we added the auditing the auditing listener. So we also need to enable JPA auditing. So enable JPA auditing. So now if we go back to our order service, let's import this one. And now we have our We can also close this, and we can also close the order request. We can also close the controller. So here, as mentioned, first we need to check if the customer exists. So here I will replace this one. So var customer equals this dot customer client, or like directly customer client, dot find customer by ID. And our customer is request dot get customer ID, and here or else throw. So in case I don't find the customer, I will throw an exception. So the exception, it will be a new, for example, and here I will create a new business exception. So here I'm just trying to create as many exceptions, or like to show you as much information as I can in one video. So here I will create a business exception. So let's create a class in a package called exception. Okay, so leaving the same source. I hope it goes correctly. So here we need to extend the runtime exception. So, okay, so it's the package is correctly created. So for here, I will just remove this one, and I will add a private final string MSG, just message. And here I will use my equals and hash code with call super true. And of course, I will add just the data annotation, just to have the constructors and so forth. So now we are done with fetching the customer. So if we have the customer, otherwise we will throw an exception. And let's say, for example, cannot create order. So here, for example, cannot create order, and let's give some information. No customer exists with the provided ID. And here maybe we can also paste the customer ID. All right, so now what we need to do next? So next we need, as we mentioned here, we need to purchase the products. So for this one, what we will be using, so here we used Feign client. So here we will use REST template. So using REST template is not the same as OpenFeign. So like we can also use OpenFeign, as you can see, or like as you saw in here, it's so simple. It's just an annotation. It's just an interface with an annotation and just a simple method. But I want to show you, as I mentioned, as many information as I can. So here I will create another private final, and I will create, for example, product client. And I will call it product client. So we don't have this product client yet. So let's go ahead and create our product client. So here, let's create a class in this time. So let's change it to product. Okay, so it's still in the same folder. And just here to make sure, okay, we have already product in here. So now all I need to do, I want to mark this one as a service, and of course, a required args constructor. So now what we need to do? So first we need a private string product URL. So product URL, and here I will inject it using the value annotation from Spring. So then it will be $, and then application.config. So here I made a typo. application.config.product-url. So this is the URL of my product microservice. Then I will need to create a private final REST template. All right, REST template, and I will call it REST template. So here it will mention that we don't have any bean of type REST template defined or found in our application. So what we need to do, simply we need to create a bean for that. So I will create a new class in here. So let me reduce this. So here I will create a new class in a config package, and I will call it REST template config. So creating a REST template is so easy. So first we need to add the configuration annotation. So since this class is a configuration class, and all I need to do is to create a bean of type REST template. So here public REST template, and I will call it REST template. And all I need to do is to return a new REST template. And that's it. So like here we can also add other properties and other configurations to our REST template, but for our case we can use it in this way. All right, so now we see that we have a bean, and we are no longer having the issue telling that we cannot find a bean of type REST template. So now what we need to do is to perform, or like is to create our method. So it will be a public list of purchase request. So we know that the response will be of type purchase, sorry, not purchase request, but it's purchase response. And we'll create the object. And here, let's say, for example, purchase products. And here we need to pass the list of product request, not product, but purchase request. So let's call it request body. All right, so now let's just go quickly and create a record of type purchase response in the same package. So the purchase response, it will be exactly the same one that we created in the order microservice. So here you see that I'm not trying to copy paste or like to reference one from the other, because here we are working in a microservice. So that's true that I created a monorepo project, but imagine that each microservice is implemented using a different technology. So that's why we need to, when we implement one microservice, we need to focus only on that one and avoid thinking, okay, so I have this somewhere else, so why duplicating it? So let me move it to a common project, or let me create a common dependency or something like that. So this is not required. Just imagine and like put in your head that each microservice might be implemented using a different technology. So like one can be implemented using Java, the other one it can be PHP, Next.js, JavaScript, and so forth. So like you need to keep this in mind. So all right, so let's move on. Now we have we will create our product ID attribute, and then we have string name, string description, and we will have a big decimal price, and finally we will have a double quantity. All right, so this is our purchase response object. So now let's move on and let's go back to the implementation of our REST template, or to our for our purchase products method using REST template. So now the first thing we need to create an object of type HTTP headers, and let's call it headers equals new HTTP headers. So here we need to use, I think I imported the wrong one. Yes. So here, let me switch it. So we need to use the one from the Spring framework. So import class, and it's the one from org.springframework.http. So now I will set few information. So the first thing, we need to set the content type. So headers.set, and like the headers is, you can imagine it, or like you can consider it as a map. So like it will be a key value. So here I will use first of all HTTP headers.content type, headers.content type. So this is the header, and by the way, you can also specify it as a string, and this is the value for it. But since we have it in here, why not using it? All right, and then as the type, so it will be media type dot application / JSON value. All right, so also the application / JSON value is this value right here. All right, so let's import both of them statically. So let's add static import, and now we are done with the first part. So then what we need to do is to have, or like to prepare an object of a request entity. So I will create an object of type HTTP entity, again from the same package, org.springframework.http, and this one, it should contain the type that we are expecting, and we are expecting a purchase response. Sorry, not the type that we are expecting, but the type that we need to pass. So we need to pass a list of purchase request because it's already a request entity, not a response entity. All right, so let's call it request entity equals a new HTTP entity, again from the same package. And here we need to pass our request body, which is this one, or like the products list, and we can also pass the headers. So here for the headers, for example, if you need to pass a token, if you need to pass an API key or any value, you can also pass it in here. All right, then I will create an object of type parameterized type reference, always from Spring Framework. And this also will be a list of, now I need my response. Okay, so like the first time this HTTP entity is for the request, and now I need a list of purchase response. So here let's call it response type. Let me also fix this typo. Response type equals a new parameterized oops, I made a typo again. So parameterized type reference. All right, so we can also leave it this way. So we okay, so let me, I think maybe I can break the lines so this will be more visible. We can also remove the type. So here we create an object of type parameterized type reference, and this will be our response type. And this response type is the object that we will pass to our response entity or to the exchange method in order to ask it to parse automatically the response to this object. So we will see it just now. So now I will create an object of type response entity of type list of purchase response. All right, since this is the final object that we want, and let's call it response entity. And now we will use our REST template object, this one, and we have a method called exchange. So this exchange method, first it takes the URL, so it's product URL, and then plus, and we know that we have the endpoint called purchase, the one that we created in the product microservice. And then we need to pass the method, the HTTP method. So it's a post method. I will import it statically. And then we need to pass our request entity. So this is the object request entity. And now what is the response type? All right. So now this is why we need this object response type. And this is why we declared it of type parameterized type reference. So here simply we need to do we need to return our response entity dot body. So our response entity dot get body. So this will contain the body of the response or the response itself. But here I will just make a small check. So if my response entity dot get status code, so we have a method status code and we have a method called isError. So isError will check if the response is an error type or not. So like if it's of type 5xx or 4xx. All right. So whether if it's a client error or a server error, we want to throw a business exception. So throw new business exception. And here, for example, we can say an error occurred while processing the product purchase. And here we can say, for example, we can get the response entity dot get status code, so we will know what is the status code exactly. So here we can add colon and space. All right, so this is how we can use REST template in order. So you might already like remark that using Feign client is much easier, but in case or like for some cases we need to use or we can use or we want to use REST template. So here you have all the information that you need. Now we can go back to our product, to our order microservice and well, not the order microservice, but the order service itself, and we can finish implementing our create order method. So here for purchasing the product, all I need to do is this dot product client dot purchase products. And here I need request dot get products. All right, so here we have something. So it is required purchase request. I think we made, all right, so here it should be purchase request. Yes, so here it should be purchase request, not order request. So I made a typo there. So now we have the part, or like the step that will purchase the list of products from the product microservice. So now what we need to do next is to persist the order. Okay, so here I will create a var order equals this dot repository. So I don't have it yet, so maybe first let's go and create a private final order repository. We don't have it, we will create it in a few seconds. So let's create an interface in the same package. So here extends JPA repository for my order object or my order entity, and then integer as an ID. All right, so now I can finish the save, and here I will need my mapper. So I can use, for example, mapper.to order, for example, out of my request object. So I don't have the mapper yet. So here I will create private final order mapper. Let's call it mapper. And we don't have this class. So let's go ahead and create it. Let's give it the service annotation. And now we can create these two order methods. All right, so this will return an order. So return a new order.builder.build. So here I guess we have, yes, we have the builder. So return order.builder.build. And here all we need to do is to set the different information. So we have ID, we have customer ID, we have reference, and we have amount. Also, we can get the request dot amount, and we need finally our payment method. So request dot payment method, and that's it. So we have ID, we have the reference, we have the customer ID, and we have the amount and the payment method. All right, so now we go back here. Once we persist the order itself, we need to persist the order lines. All right, so let's move on. And here, so I will just create a for loop. So for purchase request, so it's an object of type purchase request, and I will call it purchase request of my purchase request dot products. So like I need to get all the products, and out of the products, I will create an object, like I will create an object of type order. All right. And here for this one, like I can inject here, for example, the order line repository, but I will do it in a different way. So here I will create a private final order line service. So I will call it order line service, and I don't have it yet. So let's go and create this class in the order line package. And let's give it the service annotation and also the required args annotation. So it's just like we will create a service that will handle or take care of creating the order lines. So here I will do order line service, and I will create a method save order line in the same way, because I will show you why I delegated this to a service. And then I will pass an object of type new order line request. So this will be a record, and I will pass a null as an ID, and also I need my order dot get ID. So get ID, and then I need the product ID. So my purchase request dot product ID, and I need my purchase request dot quantity. So this will be my my order line request object. So like this is the ID of the order line, the order ID, product, and then quantity. So here, since we don't have this method yet, let's go ahead and create it, and it needs an order line request. Now let's create a record of type order line request in the package order line. So here you see that automatically it tries to detect what are the information that we want to pass. So here let's just rename it. So this will be the ID, this one will be the order ID. Let me also break the lines, and this one, it will be my product ID. Just I will try to make sure that they are in the same order. So like the order ID, the order line ID, the order ID, product ID, and quantity. All right, so it's correct. Now we can go back here, and of course we forgot a parenthesis. So 1, 2. All right, so now this for purchasing or like for saving the order lines. Now let's go and implement this method first, like the save order line. All right, so let's go to this one. So here, like as always, I will change this one to an integer. And now I will inject my private final order line repository. And let's call it order line repository or simply repository. And then I will need also a mapper. So private final order line mapper, and let me call it just simply mapper. So first let's create this interface in the same package, and now extends JPA repository of type order line and integer. All right, so we are done with this one. Let's create the order line mapper class, and let's give it the service annotation, and we will implement the methods as we need. All right, so first I will create a variable. I will call it simply order, for example, and then mapper to order line, and I need to pass my request. So order line request, I will just rename it for a shorter name. So I will name it to request. And then let's implement quickly this method. So it will return an object of type order line. And here all I need to do is to return order line.builder.build with the required information. So here we have the ID, which is from the request. We have also the quantity, and we have the order ID, or like here we need to pass the order. So here let's say order.builder.build. So let's say ID, and then we have here order ID, and then dot build. Let me format. And then we need our product ID, and we need the amount, I guess, or I think that's all. So we have 4 information. All right, so now this is the mapping method, and all I need to do now is to return my repository dot save, and then I need to save my order object, and then dot get ID. So this is the order line method. All right, now you see, like when we progress a little bit, we need to implement few things like from here and there. So that's why we are like I just wanted to show you how I would implement it in real life. All right, so here we need to start the payment, and then we need to send the order confirmation to Kafka. So this one we said that we will come back to it later on. So I will just mark it as a to do. And then for sending the order confirmation, first we need to set up Kafka. So we need to update our Docker Compose file and make sure that Kafka is up and running. Then we need to configure Kafka to configure our topic, and then we will send and then we will implement the sending of the information of or the notification to the notification service. Now let's prepare the infrastructure for our Kafka server. So again, we will open our Docker Compose file, and here let's add a new server. So after Mongo Express, or like you can choose where you want to add it. And here we will add, first we know that Kafka needs Zookeeper. So I will add a service and I will call it Zookeeper. And I will pull it from the image confluenting. It is called confluentency/cp-zookeeper, and then we can use the latest version. So this is our image. Let's give our container a name. So let's call it, for example, Zookeeper. And then we will add a few environment variables. So first I will add Zookeeper underscore server ID. So this configuration is only required when you work on locally, but when you need to deploy your application, maybe you need to add a few other configuration and maybe like enable other properties. So I will give it an ID 1. Again, I will use Zookeeper underscore client port. So here, just to define the port for our client, and by default it's 2181. And we have also another property called Zookeeper underscore tick time. So the tick time, let's define it. So it's tick underscore time, and let's define it to 2 seconds. Then we need to enable some ports. And for the ports, let's say, so like as you can see here, it's 2181. So just add a 2 and 2181. So like it will be 22181 over 2181, which is the default port that we defined for our Zookeeper. Then I would assign it to my network, and the network that we called Microservices network. And that's it for the Zookeeper. Now we will define the property or the service for our Kafka broker. So I will call it Kafka, and then the image, so it will be the same one as in here. So like it's the same prefix. It's confluent in C, not confluent in C, but confluent in, and then letter C, and then slash, it will be cp-kafka. And then we'll also use the latest version. And let's give it a container name, or like let's give it a name, and then we call it MS, or like microservice, and then Kafka. So then I need to define a port. So I will use 9092 over 9092, which is the default one used by Kafka. And here we have something called depends on. So here our Kafka broker needs first Zookeeper to be up and running. So I will just say and tell it that it depends on Zookeeper. And now we need to define few environment variables. So here I will just paste it and explain them one by one. So first we need to define a Kafka offset topic replication factor. So like how many replication we want. So as I mentioned, like locally we only need 1. So here we have a transaction state log replication factors. It's also 1. So here like I learned this one by experience, like when working locally with Kafka on Docker. So we need to define these ones, otherwise you will face few issues and the Kafka container will not start. So also we have a transaction state log min ISR, it's also defined to 1. And here we need to define, or like to give it the URL of our Zookeeper. So here Zookeeper, since both of them that are in the same Docker Compose file, so we can reference it using the Zookeeper instance name, or like service name right here. All right, so I guess I pasted it in the wrong place. So let me fix it. So here it should be part of Kafka, not maildev. All right, so then we have the Kafka listener security protocol map. So we will add this information. So it's plain text over plain text and plain text host plain text. And then we have the Kafka advertised listeners. So here we need to define the port, like or what is the port for our Kafka broker, which is localhost 9092. All right, so then of course we need to define or like to assign it to our network. So it will be microservices network. And that's it for the configuration for Kafka and Zookeeper. So now if we, what we need to do is just, let me clean this one, is just docker compose up and then -d just to restart everything and create all the containers. So here there is something, I think we made a typo somewhere. So let me double check it. Yes, so this one, like we had /. So let's try again to start our containers. And as you can see, all the containers are up and running. All right, so now we can move on and continue the implementation of our order microservice. Now let's go back and continue implementing our order microservice. So here, the first thing that I need to do is to configure my topic. So in the config package, I will create a new class and I will call it Kafka order config or order topic config. So I will call it this way. Let me make it full screen. First, this will be a configuration file, and then I will create a bean. And then what I need a public new topic. It's an object called new topic, but we don't have it yet because we need to add Kafka dependency to our pom.xml. So first let's open the pom.xml from the order microservice, and then we need to add the Kafka dependency that I will show it to you just right now. So the dependency is called, so here maybe let me scroll down a little bit. So maybe after open Feign, let's add a dependency, and it's called spring-kafka. So like this one, and here it's coming from the package org.springframework.kafka, and all I need to do is to refresh my dependencies. So now we have our Kafka dependency available, so we can go back to the configuration file and add our new topic object. So here it's called new topic. Let's import the class, and as you can see, it comes from the Apache Kafka clients admin and then new topic. So let's call this one, for example, order topic. So order topic, and then all I need to do is to return a new, like a topic builder. So it's called topic builder. So here my IDE is not recognizing it. So, but let me try to import it manually. So here I will say use import org.springframework.kafka, and then config, and then we have topic builder. So let's try to use this one. So it's a topic builder, or maybe I made just a typo. Okay, yeah, I made a typo. That was the reason. And here let's say name, and let's give it a name. So for example, let's call it order topic. Also this topic name, we can externalize it to the configuration, but it's fine here to leave it also hard coded in here, since like we will use only this topic, even for example if we decide to move to another environment. So now we have the configuration of our topic. We have the topic, the order topic. Let's close this one, and now in order to be able to send an element or like information to the Kafka broker, we need to add some other methods. So here I will create a new class, and I will call it order producer. So since our order microservice is the producer, so I will call it order producer, and I will put it in a package. I will call it Kafka. So this order producer, it will be a service. Let me make it full screen. So it will be a service, and then I will need the required args constructor. And for example, I can also add the SLF4j if I need, or if I want to add other logs. So what I will do is I will create a public void. So public void, and I will call it send, for example, order confirmation. And this order confirmation will take an object of type order confirmation object. So order confirmation, we don't have it yet, but we'll create this record in few seconds. So let's go first and create this record order confirmation. And this order confirmation, it will contain the data or the information that we need to put or to send to our Kafka broker. So what I need to send to my notification service, I need to send the order reference, and then I need to send a big decimal amount, or like the total amount, just the total amount. And then I need my payment method. So like I need all this information just to display or to send a decent or a correct email with all the necessary information. So let's call this one payment method. And we need also a customer response. So the customer response will contain the customer information. So I will call this variable just customer. And then, or finally, we have a list of purchase response, and I will call it products. So this one will present the list of the products that the customer has purchased. So now let's go back to our send order confirmation method, and let's finish the implementation. So first I will just add a simple log, so log.info, and then here let's say sending order confirmation, just to make sure, or like to be able to follow and see the logs later on when we do something. So here what I need to do is to use a message object, and here the message is from org Apache Kafka common.protocol. Sorry, I think no, it's the wrong one. I think we need to use the Spring. Yes, it's from org.spring.messaging. So we need to use this one. And here we want to send an object of type order confirmation. And then let's call it a message equals, and then we have message builder. We have a class called message builder. And then we can say with payload, and our payload is the order confirmation. And then we can set a header. So to which topic that we want to send our information. So here we have a class called Kafka headers. And then we have a topic or a type called topic. So this is the one, and it's called Kafka topic. So you can even you can also use this string directly, but it's better to use something predefined already. And now we need to pass the header value, which is our order topic. So this should be exactly the same name that we provided when we created our topic. And then finally we need .build. So now we prepared the message, we logged, and we have everything. So now we need to send the message, or like to produce a message from our order microservice to the Kafka broker. For that, we need to inject something. So here I will inject a private final, and we need a Kafka template. So we need an object of type Kafka template. So here it will be of type string. And what is the object that we want to send? It's of type order confirmation. And let's call it Kafka template. And here, all we need to do is Kafka template.send, and we want to send our message. And this is how we implement, or like how we send a message to a topic. So this is how we produce a message to a Kafka topic. But this is not the end. We need to add also some other configuration. But before that, let's go back and finish our order service implementation. So here we mentioned that Alright, in the order service, here we mentioned that we want to send the order confirmation to our notification microservice. So here, first I need to inject my Kafka, or like my order producer. So it will be a private final order producer, and let's call it, for example, order producer. And here, all I need to do is to say order producer. So it's order producer dot send order confirmation, and for the order confirmation all I need to do is to pass a new order confirmation object. So this order confirmation, it will contain the request.getReference. So this is the order reference. We need also the request.amount. So this will be the total amount of our order, and again we can get the payment method from the request. And finally, we pass the customer object that we got from here, from the customer microservice. So there we have all the information about the customer, and we have also our purchased products. So my object, it's called purchase. All right, so we forgot to save the purchase product. So this purchase product, we will save it, or we want to save it to a variable that's called purchased products equals. So let me fix this typo. And here we can pass our purchased products. All right, so like we know that this product client.purchase products will return a list of purchased products. And now this is how we send an object, or this is how we send and produce a message to our Kafka. And finally, all we need to return is our order.getID, since this should be the return type, or the object that we need to return. So now if you remember from the Kafka video that I produced before, so we need to add few configuration when we produce something and also when we consume something. So like the producer and the consumer, both of them need to define few information. And among this information, we talk about the serializers. So we need to define what are the serializer, or like the key serializer and the value serializer of our producer. Since here we are not sending a simple string, so we are sending an object, and this object should be serialized in order to be able to consume it later on, and to also to cast or to deserialize this object again to an object, sorry, not an order, but to an object of type order confirmation. So to do that, what we need to do, we need to go to our config server and add few properties. So here, if we go to main and then resources, and here configuration, and in the order service configuration. So for that, I will just, in the beginning, as I showed you before, I will do it in here. So just you can see the auto completion from the IDE. So what I need to define, we have here Spring, and then we have an information called Kafka, and then we have producer. So since our order microservice is the producer of our messages. All right. So first we need to define our Bootstrap server. So here let's define the Bootstrap server, or servers, because we can define many of them. So it will be our local host and then 9092. This is the configuration that we defined before for our Kafka producer, or like for our Kafka server. And then we have a key serializer. So the key serializer, we need to define, or like to tell Kafka what is the serializer of our objects or of our messages. So it's by default org.apache.kafka, and then common, we have a package called common, and then serialization, and then we have a string serializer, and this is for the key serializer. So now, since Kafka does not have a default value, like a default JSON serializer, so we will use the one provided from the Spring framework. So here I will add the value serializer, and it will be from org.springframework.kafka, and then we have a package called support, and then I think it's called serializer, and then it's the class is called JSON serializer. So if you want to implement serializer, so let me fix this one. All right. So also if you want to implement your own JSON serializer, you can just do it, whether by extending or implementing this interface or defining your own serialization. So then we have something else that we need to add. So here we need to add few properties, and then we have a JSON, a property called JSON type mapping. So here let's add properties. And then we have a property called JSON. It's called, spring.json, like it should be written in this way. So spring.json.type.mapping. I will explain what is the reason, or like the value, or like why we need to specify this information. So here, since we want to serialize or to send a JSON object or an object, so the producer needs to inform the consumer of our topic what is the object that we are sending. So here we are sending an object called order confirmation. So order confirmation, this is what we defined in here. All right, so this is what we defined in here. So what we need to do is this is the order confirmation, and where this one is coming from. So we need to provide the full package of this order confirmation object. So it's coming from com.alibu.ecommerce, and then Kafka, and then order confirmation. So we are just providing this order confirmation object, so this one right here, and we are providing this package name. So let me copy it and paste it again just to avoid any kind of typos. And that's it. And then it's the class name. So then when we send this one, the consumer will be aware of this object, that this object can be accepted. So this is like a security level from Kafka that we cannot produce, or like we should, when we produce and consume something, we need to inform like to the two sides. So like the producer need to inform the consumer what is, or from where the object is coming from. So like this means, for example, we trust this package, or we trust this class, and it's able, or like it's fine to consume it. All right, so this is the configuration for Kafka. I will just copy or like cut this part right here, and then just place it in the order service. So here after database, in the same level of JPA, because the information, or like the property, is called spring.kafka.producer, and so forth. So this is the configuration that we need. And don't forget to add this configuration. If you skip this part, you will face issues when sending and consuming data from the Kafka topics. All right, so this was this first method. So the first method is create order, and I think this is the most complicated one, or like the one that has the most of the relationship. So because we need to get the information, or like to contact or to connect to our customer microservice, and then we need to connect to our product microservice, and then we need to do or to interact with our Kafka broker. Now what we need to do next is to implement the rest of the method. So let me close all this one. So close all tabs, and now we can go back to our order controller and we can finish the implementation of the rest of the methods. So the rest of them will be something simple, because what we need to do is just to retrieve the data, or like to retrieve the orders, find all, find by ID, and that's it. So first, let me add another method. It's called getMapping. So here it will be a public response entity, and here it will be a list of object of type order response. So we don't have it yet, we will create it, and let's say, for example, find all. So like for our case, we will not use this one, but I just want to create this method. So I will create a record, and I will just implement it in few seconds. And here all I need to do is to return a response entity. So response entity.ok, and then I need to call my service.findAll. So this find all like is a classic method, nothing fancy in here. So let's go ahead and create this list find all. So now all I need to do is my repository.findAll, and then .stream and map. So here I can use the mapper to order response, or maybe let's change a bit. Let's use from order, for example. And then of course we need to collect, and to collect it to a list. So now let's go ahead and create this method. So this needs to class or method needs to return an order response object, and this order response will be a record as mentioned before. So here we will just provide few information, and here all I need to return is an integer ID. So this will represent our order ID. We need a string reference. So this is the reference of our order, and the big decimal the amount. And then we need a payment method, of course, like we want to know what was the payment method, and for example a string customer ID. So you can also like extend this one by contacting, for example, or fetching the list of customers for each order, return it, and so forth. But you can we can make it also in the front end. When the user wants to display the customer information, we can just add a button or like a link in order to fetch this one. So like we don't need to fetch it eagerly, so we can like fetch it in a lazy way. All right, so now let's go back here, and all I need to do is to return a new order response. So here it will be order.getID, and then we have order.getReference, and we have also the amount. So let's say order.amount. Then we have the payment method. So I don't have the auto completion, but let's say order.payment method. And finally, we have order.getCustomerID. So this is the find all method. And as I mentioned, this one is like too classic one. All right, so the next one is finding an order by ID. So it will be again a get mapping, and we will have our path variable, and let's say /order-ID, for example. And then all we need to do is to call our service to fetch this order ID. So it will be a public, again, like a response entity of type order response. And then let's call this method find by ID. So here we need our path variable. So just path variable, and let's call it order-ID and integer order ID. So then we need to return our response entity.ok, and then service.findById and order ID as a parameter. So let's go ahead and create this method. So this is also a simple one. So all I need to do is to return repository.findById and then order ID, and then I can map it if I find something. So here it will be mapper.fromOrder. And finally, like if I don't find anything, I can throw an exception. So the exception, let's say, for example, let's throw new entity not found exception. And here, for example, as always, we can say no order found, or like no order found with the provided ID. So for example, we can use, maybe let's use the string.format method. So just to be able to easily include or like to map the attributes or the values. So here we say no order found with the provided ID, and then let's say %d because we need to pass a decimal or like digits. So here it will be order ID, and that's it. So this is the find by. So now we are almost done with the implementation of our order microservice. So what we need to do next is to implement a controller and few things for our order line entity. So here what we need to implement really is, for example, like a get mapping to find by order ID, like find all the order lines by order ID. This we might need in the future when we implement the front end part. So let's go ahead and implement that one. Now in the order line package, let's create a new class and let's call it order line controller. So also, by the way, this method that we will create in here, we can also move it to the order controller and have everything there, but I just wanted to split a little bit. So here I will add a REST controller and a request mapping. So the request mapping, it will be /API/v1 as always, and here order -lines. So then I need my required Args constructor, and let's add the method that we need. So first I will need my private final order line service. So order line service, let's call it service. And then I will need my get mapping, and it will be /order because we want to filter or to find all the orders by all the order lines for specific order by order ID. So here let me add order -ID, and now we will have a public response entity of type list. So it will be a list of order lines or like order line response. So order line response, we will create this record in a few moments, and then find by order ID. So here we need our path variable, and it's called order ID, and then integer order ID. So then what we need to do, simply to return wrong place. So here return response entity .ok, and then we need to return my service dot find all by order ID, for example. So here let's give it the order ID as a parameter. First let's create this class or this record. So let's use a record in the order line. We will fill it in a few moments. And now we need to create this method find all or like find all by order ID. So for the order line response, here we will need just two information, like as simple as that. So for example, let's say we want to return an integer ID. So the ID of the order line, and for example, just to make it simple, if we need, we will extend it later on. So, and here we have the quantity, for example. So the order line service, now it's quite simple. So here, all I need to do is to return my repository dot find all by order ID. So I don't have this method yet, but we will create it. And here we need our order ID. So let's first let's fix this one, and let's create this find all by order ID. So this will return a list of order line, just not order line response, but order line. So let me close this in here. So now let's go and check this order. Okay, so here we have order. Maybe we have a typo. Yes, so it's again a typo. All right, so it's order ID. Now if we go back here, it's called order ID. And then we have a stream and then map, and we have our mapper dot to order line response, for example. And then collectors to list. So let's create this method. So this will return an order line response. So simply we want to return a new order line response with order line.getID and order line.getQuantity. As simple as that. So now we are done with the implementation of the order line controller. So here we still like to finalize or to 100% finish the implementation of this order service. We still have two things. The first one is we need to come back to the order service and finish the implementation, or like sending the information, or like this to do. So like start the payment process. And then since we have also like we are throwing exceptions, business exceptions, and so on and so forth. So what we need to do is, of course, to implement a handler for our microservice. So the next step is to implement a handler, and then we will finish the 90% or like 95% we will finish the order service, and then we will move to the payment service, and finally we will implement the notification service. So let's go ahead and implement the rest. Alright, so now let's go to the order, source, main, Java, and then let's copy this handler package and paste it in our order microservice. Since we know that it's almost the same, so I will just paste it in here and add a few adjustments. Alright, so here we have our handler, and we need to adjust our global exception handler. So here instead of, the entity not found will stay the same, as well as the method argument not valid exception also stays the same. So here I just need to replace this one with a business exception. The same for this business exception. And here instead of getting message, I want just to get my MSG variable that we defined inside our business exception class. And that's it. So now we have our global exception handling, which is up and ready. So let me optimize the imports, since we imported like the wrong class from the other project. So now all we need to do is to move on and implement the next phase, or the next microservice, which is our payment microservice. So here the payment microservice will connect to a PostgreSQL database in order to save the payments, and also we will need to send some data to Kafka. Also, it will be almost the same as we did before with the order. And finally, we will implement the notification microservice. And then the final phase, we need to set up our API gateway, and then we will be good to go to start testing our application. And then at the end of this video, we will set up the distributed tracing and enable Zipkin, and we will see all the tracings and the logs of our microservice architecture. Alright, in the same way, let's start by creating a new project. So in the same location, and let's call it payment. So this will be our payment microservice. It will be Java and then Maven. So the group, it will be always com.alibu, and the artifact is payment. So I will just change the package name, and I will call it com.alibu.ecommerce. And then next. So now let's add a few dependencies. We need our Spring Web. We need validation. We need Spring Data JPA. So let's search for JPA, it's easier. And then we need, of course, our Lombok annotation. And we need our discovery client, not client. So we need our Eureka discovery client. We need also our configuration client or config client. And then what we need also, we can use Kafka. So here we have Spring for Apache Kafka or Spring for Apache Kafka Streams. I guess this is the one that we need. So we will check the dependency later on. Also, we need finally our PostgreSQL driver. So let's go ahead and create a project. And in the same way, let's add it as a Maven project inside our working space. So here I will select payment and then pom.xml and click on open. So let's quickly go and check the pom.xml file. So let me reduce this one. And from the payment, let's open pom.xml. I just want to check if we imported the correct Kafka dependency, which is this one. So like we need to use Kafka, not the Kafka streams. And then we have PostgreSQL, we have Lombok, and so forth. So now our project is up and ready. We can start implementing our payment microservice. So the first thing, I will start by creating a payment entity in a payment package. So let's call it just payment.java, for example. So payment. So this payment, it will be a simple entity. So what this microservice is about is just to save the payment that the payment was issued. And then maybe in the future we will set up, for example, one payment method like PayPal or Stripe or anything else. But for now, let's keep it simple because we want to focus only on the microservice architecture, and then we will add few business requirements or like few features in the future. So I will add my all args constructor, and then I will also need the no args constructor. I need the builder annotation, also the getter and setter annotation. So like these are the basic Lombok annotations. I will add also the entity annotation, and of course I want to add some entity listeners. So since I want to track the creation date and the last modification date, and using here the auditing listener class. And finally I will add a table annotation. I will give my table a name, so I will call it payment. So this one is not really needed because it will be the same as the entity, but it's not a problem, or like it's not harmful if we add it. So here I will add my ID, and then I want it to be a generated value, and let's say for example private integer ID. And then I will need my private big decimal amount. So this will be the amount of the payment. And then we need a private payment method. So payment method, it will be like, or we will have exactly the same payment methods as we define them in here in the order microservice. So let's open it and just copy the values. So Java and then order, and we have here payment methods. So let's just copy the values from here. And when you work in a real project, you need to make sure that you are using the same values or the same payment methods. So let's create an enum in the same package, and let's paste these values right here. All right, so now we need to make it enumerated, and then let's say it's enum type.string, and we can use a static import for it. And then we need to keep track about the order ID. So I will add an integer order ID. And then finally, I just need to add the create date and the last modified date. So for that, I will open the order.java class, my entity in here, and I will just copy paste these ones to gain some time. All right, so here we have the created date and the last modified date. And then, of course, since we have auditing, we need to go to our payment application. So let me reduce this one, and payment application. And here we need to enable JPA auditing. So don't forget this one, otherwise the auditing will not work. Okay, so now we have our entity. All we need to do is to start creating our controller, service, and so on and so forth. So in the payments package, I will create a new class, and we will call it payment controller. So this payment controller will contain only one method. So here I need my REST controller annotation and my required as constructor, and of course the request mapping. So I will call it /API/v1 as always /payments. Then we need to inject our private final payment service. We don't have it, we will create it as always. And then I will create a post mapping. So this post mapping, it will return a public response entity of type integer. So all we need to do is just to return the payment ID, and here let's say create payment. Or what we can also do is to create or to generate a payment reference and just return that one to our customer or to our clients. So here we need, of course, our request body, and it should be valid, not value. So from Jakarta, let's optimize the imports. And here we need an object of type payment request. So this will contain the information of our payment. And then what we need to do simply is to return a response entity.ok. And then what we need to do is just service.create payment. And then we will create all the necessary classes. So request, first let's start by creating a payment service. So this will be a payment, and then let's add a service annotation and also the required args constructor from Lombok. And then we will create an object of type payment request, and it will be a record. Alright, so now to initiate or to create a payment, we need view information. So let's say that we need an ID in case, for example, we want to enable updating a payment. Then we need a big decimal. So big decimal, it will be the amount of the payment, or exactly the amount of the payment. We need also our payment method. So let's call it payment method. We need also an integer order ID. So integer order ID, and then we need our string order reference. So the order reference, we need to send it to the confirmation service, and then we need an object of type customer. So here let's call it just customer. So the customer, we don't have it yet, so let's go ahead and create a class or a record customer. So in the same project, so the customer will contain the information of our customer. So this one, since we have here in our controller the @valid annotation, and when you use a complex object, I mean like a record or another class, you need to mark this class as validated. So when you use this validated, all the attributes that you will include inside this record, they will be also validated, or like all the annotations will be validated using the Spring validation dependency. So here let's add a string ID, since we know our customer or like the ID from the customer is of type string. We also need our string first name, also a string last name, and finally we need a string email. So here let's add the annotation. So this one, it should be not null, and let's say, for example, message first name is required, just to make it simple. The same for the last name, and here let's call it last name. And finally, let's say for the email, also let's say email is required, and also let's add the email annotation. So email annotation, and for example, let's say the customer email is not valid, or like is not correctly formatted. Is not correctly formatted. So we need the email to be valid and well formatted, because we want to send it to the notification service, and then from using this email, we want also to send a payment confirmation to our customer based on the on our client requirements that we saw in the beginning of this video. All right, let's go back to our payment controller and create the method create payment in our payment service. So this implementation will be quite simple. So first, all I need to do, I will create a payment object, and I will call it, like I will call, for example, equals repository. We will create this this field, or this parameter, and then we need to call save method, and then we need to use our mapper dot, for example, to payment method, and we need to pass our request as an object. So since we don't have any of this, the first thing that I will do is I will inject a private final payment repository, and let's call it repository. And then we need also a private final payment mapper, and let's call it mapper. So let's go ahead and create these classes. So we have payment repository. Let's create it as an interface in the payment project. And now, as always, extends JPA repository of type payment, not payment repository, just payment, and then integer. So this is the type. And now we need our payment mapper, which will be a class. So let's add the service annotation. Then we need simply to create this payment method. So let's go ahead and create a payment. So this will return a payment.builder.build. And here all we need to do is to map the attributes. So we have ID, we have custom order ID, I guess. Yes. So we have order ID, we have payment method. So this will be my request dot payment method. What do we have also in the payment? We have amount and order ID already mapped. So the final one, or the final information, is amount, and this will be my request dot amount. And that's it. So now let's go back to the payment service. What we need to do next is to send a notification to our notification microservice. So in the same way, we need to set up Kafka, we need to add the properties, we need to do all the required things. But we did not yet add the properties for our payment microservice, but we will add it all at once, since we know how things work and since we know how we do, or like how we add this information. So I will close this one. I will just continue implementing the Kafka producer and the topic and all the configurations that we need. And finally, I will come back to the application.yaml and add all the properties and of course externalize them in our configuration server or config server. So let me close all this. First, as we did before, we need to add a new class. So let's add it in a config package and let's call it for example, notification or Kafka payment topic configuration. So let's call it Kafka payment topic configuration. So config, just as a simple name, I will make it full screen. And for this, like we will do in the same way. So we need the configuration annotation, and then we have a bean. And of course, we need a public new topic object. And then let's call it, for example, payment topic. So this will be the topic that we'll create in Kafka in order to send all the payment confirmation, or like the payment information, generally speaking, or payment notifications to our notification service. So then return a topic builder, and then let's give it a name. So the name will be, for example, payment-topic. So you can call it anything you want. And finally, .build. All right, now we are done with the configuration. What we need to do is to implement our notification producer. So here I will create a new class in a package called notification. So notification, and then I will create a class called notification producer. All right, so here, let's fix the typo. Notification producer, let's make this one full screen. And now we will start implementing our notification producer. So this one, I want to make it a service, and I need the required args constructor and SLF4j just for logging. Now, since we are familiar, we know what to implement and what to do exactly. So first I need my private final Kafka template. So Kafka template of type string, since this is the key, and the value, it will be of type payment notification request. So we don't have this object, we will create it. So let's call this one Kafka template. So first let's create this payment notification request record. We can use record for that, or class, like both of them are okay. So here we will have our string order reference. So these are the information that we need to send to our notification service. And then we have a big decimal amount. So we need to send the amount. We need also our payment method. So here we need payment method. Let's call it payment method. We need also a string customer name, or customer, let's call it first name. We need also customer last name. So this one will be a string. So we can copy this one. So here it will be just last name. And finally, we need a string customer email. So customer. All right, so we are done with this payment notification request. Now, if we go back to our notification producer, all I need to do is to implement a method. So this will be a public void send notification, and I need my payment notification request. So let me call it simply request. And now first let's log.info, for example, sending notification. And here, for example, we can say with body. So here I can do something like this, and I can parameterize it this way. So here request. So like this, when we use the open and closing brackets, this will include the value or the serialization of this request inside this one. So like we will have a log later on sending notification with body, and it will display the information of our object. So then we need to create an object of type message, as we did before. So here let's give it a type payment notification request. Let's call it message again. and equals our message builder. And then we will say with payload, which is our request. And of course, we need to set the header. So the header, it will be, as always, our Kafka headers dot topic. And then we need to give it the topic name, which is payment topic as we defined in the configuration. And then dot build finally. So now we can also import this one statically. And finally, all we need to do is Kafka template dot send our message. And that's it. So now we have our send notification. So let's go back now to our order service, to the payment service, not order service. So payment service, and now all we need to do is to send our notification to the notification service. So here, simply, okay, now we can return payment.getID, and here we need to inject our notification service. So private notification producer, let's call it notification producer. And here just we need to call notification producer dot send notification. And now all we need to do is to create an object of type notification request. So the notification request, it will be order.get order.order reference. And then we need request.amount. Then we need the payment method, also from the request payment method. We need also request.get customer dot first name. And then we need my request.customer dot, so here request.customer dot last name. And finally, I need my request.customer dot email. So here, why I use this one without checking if the customer is null or not is simply because I have the validation of this customer object right here. And also like this object or like this request is validated already in the controller. All right, so here we just forgot the final keyword. So we want it to be automatically injected. Okay, so this is the implementation of our payment microservice. So now let's go ahead and finish the configuration for it. So let's open the source, main, and then application.yaml file, and let's do what needs to be done. So here, like if we just externalize the information, so we need here spring.application.name. So let's call it payment-service. And then what we need to do is just to externalize or like to add the properties or the other properties that we need for our microservice. So let's go ahead and add them. So like we can also do some copy pasting from other microservices since they are almost the same. So here for the payment service, we need first, let's go to our config service and then main resources and configuration. For example, in the same way as product service, we can copy all this data source part and let's paste it in here. So we have data source and here we need order instead of product. And of course, don't forget to create the database. All right, so here we have product. We need to create, for example, first let's check if we are connected. Yes, so here let's create a new database. And let's call it order, for example. So we will call it order and then let's click OK. Oops, I guess. So here, let me see. All right, so this is for the order microservice. And now we need another one for the payment. So I just made a small mistake. So let's call this one payment. All right, so also let's display this one. Let's refresh in here and we can also display now the order the payment database. So let's leave it in here. And now in this one, it should be payment, sorry, not order. So here we have payment and for the rest, everything is almost the same. Now from the order service, we can also copy this information we have right here. So like the Kafka configuration. So now let's paste it in this way, and also in the same level of data source and JPA, let's paste this information. So I will make it full screen. So the Bootstrap server stays the same. The key serialization and the key serializer and the value serializer also they stay the same. Also, we need to add this property, which is the JSON, the Spring JSON type mapping. We need just to change this one. So here we don't have order confirmation, but let's call it just payment confirmation. And also it comes from the same package. Well, not exactly the same package. Let's double check just to avoid the typos and debug later on just for nothing. So here we have notification, and this is our notification request. Let me copy the package, and then I will paste it in here. All right, and then my class is called payment notification request. So here it will be payment notification request, and that's it. So here I will just take all this. So let me select it all. So I can also remove this one. Now all I need to do is in my config server, here in the configuration, let's create a new file and let's call it payment service.yaml. And here all I need to do is to paste this configuration. So we have the same configuration that we have there. Now we need to finalize our application.yaml, the one that resides in the payment microservice. So here, of course, we need to add config.import, and we have optional and then config server. And then we need to provide the http://localhost and then our port, which is 4x8. All right, so now we are done with the microservice payment. All we need to do is to go back to the order microservice and finish the implementation, or like calling the payment or initiating or starting the payment process in our order microservice. All right, now let's go back to our order microservice and let's finalize it. So in here, I will create a new class. First, it will be an interface, and I will create it in a package called payment. So we will use Feign client in order to initiate or to start a payment process. So here I will just call it payment client. And in here, let's also use, so before that, we need to make sure that for the config server, let's go to our payment configuration, and we need to make sure that we use the correct port. So otherwise, like we might have few conflicts, like using the same port 2 times. So for that one, we can use 8060, for example. So here, if we go, because I think it's the one that we defined in here. So here we have payments, and now in the payment service, I guess we have, okay, so we did not define this one. So let's say server and then port. And let's say, for example, 8060 for the payment service. All right, maybe let me do a global search. So it's not used, so it's the only place. Okay, so now let's go back and let's start implementing our payment or our payment client. So simply this one, it will be a Feign client. And as always, we need to give it a name. So it will be product service. And then we need our URL. So the URL, it will be again, like we will fetch it from our application.config.payment URL, the one that we defined already in here. So let me remind you. So here we defined already a payment URL object, or like value. So then what we need to do, we have our post mapping, and all we need to do is to return an integer. And for example, let's say request order payment. So let's call the method this way. And here we have our request body, and we need an object of type payment request. So we don't have it, and we will create it. And this will be our request object. And okay, so this one should be an interface. I already mentioned that it should be an interface, but I created as a class. So let's go ahead and create a record of type payment request. So this will contain the information that we need in here. So maybe just to go a bit faster, if we go to the payment microservice, and then I guess we can copy the same attributes from here. So we have this payment request. So it will be the same, like the amount, payment method, order ID, the reference, and the customer object. So let's copy this once. And now we can paste it in here. And since, okay, so let's import the payment method first. And here the customer, it will be our customer response. All right, so instead, because this will be the same object, so we need our customer response. All right, so now we are done with the payment client. All we need to do is just to include it in our order service. So let me reduce this one and go back to our order service. So here in the order service, what we need to do, or like all we need to do, is simply to inject our payment client and just initiate or start the payment process. All right, so here let's add a private final payment client. So payment client, and let's call it payment client, for example. And here just let's replace this to do with a payment client dot request order payment. And here we need just to pass an object of type payment request. So I will create a payment request object. So here let's say var payment request equals new payment request. All right, so here what we need to do is request.getAmount, and then request.payment method, then my order.id, so get ID, and then we have order.getReference, and finally we have our customer object. So now we are done, or like we finalized the implementation of our order microservice. So like almost all the microservices, let's go back here and double check again. So if we open diagrams, and here in this diagram, we are done with the implementation of all the microservices. Also, we have Kafka already set up and ready to use. And finally, all we need to implement, like I'm talking about the functional microservices, is the notification microservice. And this notification microservice will connect to a MongoDB database just to store or like to keep trace of the emails or like all the notifications that we sent, or we can also make it stateless. So like we don't need to persist any data. So it's really up to you. So then what we need to do is like this notification microservice will send an email confirmation, or like we will send an email globally speaking to the customer itself. And finally, in order to finish the implementation, we need to implement our API gateway. So now let's move on and implement this one. All right, now let's create a new project and let's call it notification. So in the same way, I will go to file, new, and then project. So I will call it notification, and then it will be Maven project. And here in the same way, I leave everything as is, just I will change this one to e-commerce. So then next, so here we need first mail, since we want to send emails. Also, we don't need the web. We need our MongoDB or Spring Data MongoDB, because we want, as I mentioned, we want to persist the emails, but it's not mandatory. So like we don't need, so you can make it a stateless server or service. Just you need to receive or like to consume the data from the Kafka topic, and then just send it to the user. Also, I will choose Thymeleaf as a template engine. Also, we need the web. Sorry, I think web we don't need it, but first we need, of course, our config server. So the config client. Also, we need our discovery client, so from Eureka, and we need, of course, Kafka. So Kafka, we need Spring for Apache Kafka, and then we need Lombok. So as usual, so Lombok. And that's it. So let's click on create, and in the same way, let's import our project. So here from Maven, or like even from the menu, but from Maven is also fine. So here let's click on notification, select the pom.xml file and import the project as a Maven module or a Maven project. So now we have our notification service. So as always, the first thing, let's start with creating a few entities. So here in the main Java, and then later on we will come back to the configuration. So the first thing, I will create a class in a package called notification, and I will create a notification class. So this will be my document. So the notification class, like I will add as always a few annotations. So all args constructor, no args constructor. I need also my builder to easily build my object. And then we need getter and setter. And finally, let's give it a document annotation. So here, document, the one from MongoDB. All right, so now let's define few attributes. Let me reduce this one. So first I will have a private string ID, and this one I will give it the ID annotation. Then we need a private, and I will create a notification type just here to keep trace what is the type of notification. So I will create it as an enum. So here in the notification project, so I will give it two values, or like I will have two possible values. So here I will have order confirmation, and the second one, it will be payment confirmation. So because this is the main goal, or like this is the main functionality of this notification service. So then we go back and we finish we add other attributes to our documents. So here I will have a private local date time, just to keep trace of the notification date. So notification date, and then we need an object of type order confirmation. So let me make it private order confirmation. So this is an object that we will create. So order confirmation, and let's call it order confirmation. Also, I will need another object, payment confirmation. So this will represent the object that we will persist into our database. Since it's a NoSQL database, or like a non-relational database, so I can just include objects as it is. So here let's call it payment confirmation, and here in the same way. All right, so for this order confirmation, I will create it as a record, and I will change the package. So from notification, I will create a sub package in here. So here I will have a package called Kafka. Inside it, I will create two sub packages, one for order and the other for payment. So here I will create a record. So then it will be under Kafka dot, and then let's call it order, for example, and then let's create it. So here, I think it was created somewhere else. Yes. So, okay. So this is wrong. Let me delete it from here. And let's create it again. Okay. So let's try again with the IDE. So I want to create a record under Kafka, and then dot order. So here, let me change to notification, and then create. Okay, so now we have it. And in the same way, I will create my payment confirmation object. So I will create a record, and again in my Kafka dot, now I will create a package called payment. So here, just make sure that it's selecting a notification, like as a target destination directory. Otherwise, as you saw, it will be created in the wrong project. So let's start with the order confirmation and set up or add few properties. So first I have a string order reference. So these are the information that I want to store, or like I want to keep trace. And then we have a big decimal total amount. And then I want to have my payment method. So the payment method, I will just create it. Let's call it payment method. And then I will have a customer object. So it will be customer, and finally the list of my products. So a list of product, and then I will call it products. So here for the payment method, I will create it in this package. So I will like create it within the payment. So it's, since it belongs to the payment. So here I will create an enum in the payment package. All right, so let's open our payment enum. Payment method.java, I think we have one already in here. So payment method.java, the one from order, for example, and I just need to copy the values, and that's it. All right, so now we have our payment method, and then we need to create a customer record or a customer object. So we can keep it in the order. So here for the customer, all I need to do is just to include the customer information. So for this one, maybe let's go a bit faster, and we can go to the payment main Java, and I think here we have in the notification we have customer somewhere. So we need this ID, first name, email, first name, last name, and email. So I will delete the validation later on, like the validation annotations. So let's remove this one, this, and these two validation annotations. So this is my customer object. And then finally, we need to create an order object. So let's create it also as a record in the same package. So it will be also under order right here. So for the product, we will have also few information like the product ID, name, description, price, and quantity. So let's go ahead and add this. So we will have an integer product ID and then a string name. And after that, we will have a string description and a big decimal price. So this is like you can customize this object as you want. And then we will have a double quantity. So just to keep trace of what we did. All right, so let's close this, and this. Now let's go back to the notification, and we can go to the payment confirmation object. So for the payment confirmation object, it will be just a simple one. So here, let me make it full screen. We will have a string order reference and then a big decimal amount. So this is about the payment, and we will have, of course, our payment method, and string customer first name. So I guess for that I can paste the one I already copied. So let me first remove this. And here we will have, we don't need the ID, we just need the customer. Let's rename it to customer first name and customer last name. And here, let's say customer email. All right, so this is my payment confirmation object. So here we are done with the implementation of this notification document. Then what we need to do is simply to move on and prepare what we need else. So here, first of all, I will just create in this payment package, I will create a new interface and I will call it notification repository. And of course, we need to extend our Mongo repository of type payment confirmation and then a string as the ID. Sorry, wrong package. It should not be under payment, but it should be in notification. So let's move it to notification. Here, so we have only two packages, Kafka and notification, and we have here the notification repository, and notification type. So let's close this one. Then what we need to do, we need to create a consumer. All right, so here under this Kafka package, I will create a class and I will call it notification consumer. So this will be the consumer of my topics. So in this notification consumer, I will create two methods. So one method to consume the payment notifications and another method to consume the order confirmation notifications. And both of them, what they will do, first we need to persist the data. So we need to save this notification and then we need to send an email. All right, so this is what we will implement right now. All right, so first I will need to mark it as a service. So here, let's say a service, and then I will use the required args constructor from Lombok and slf4j just for logging. All right, so here, as I mentioned, I will need my private final notification repository. And let's call it repository. And I will need also here, let's just say a private final email service. It's one that we will implement in a few moments, email service. And we will create it in a few moments. But first, let's define at least the methods that we want to implement. So here we want to have a public void consume payment success notification. Payment success notification. All right, and for that we need an object of type payment confirmation. So that's why we created the object payment confirmation, since it's also the same one as we have in our or from our producer. Let's call it payment confirmation. So here, if we go back to our payment, yes, so here for the notification, we have this payment notification request. As you can see here, we have the same attributes as in this one. So here, this is so important. We need to have the same names in the same way. So let me split and move it to right. So here, as you can see, we have order reference, amount, payment method, customer first name, last name, and customer email written in the same way. So if you change it, you might face issues while deserializing, or you need to add the JSON properties to it. Okay, so I just renamed it differently just to make sure that this is an object or a class, depends, or like belongs, not depends, but belongs to our notification service. All right, so let's continue. So the first thing that we need to do is to define that this method is a Kafka listener. So we will use the annotation Kafka listener. So we can define many listeners, but for this one, it's just one listener. And here we need to define the topic. Not topic partitions, but just topics. So here we know that our topic is called payment-topic. All right, so then what I need to do, first let's log.info, and let's say, for example, here string.format, and let's say, for example, consuming the message from payment topic, topic, like the name of the topic and then just topic. And here, let's say, for example, %s, and here I will add my payment confirmation object. So I can import this method statically. Then what we need to do, just first of all, as mentioned, I will save my payment, or like my notification payment. So here I will create an object of type notification. So notification.builder.builder and then build. So here what I need to do, all right, so okay, so first I need to pass the type. So .type, and the type is payment confirmation. So because this is the payment confirmation, and let me import it statically, then we need to pass the notification date, and it will be a local date time.now, local date time.now. And then we need to pass our payment object, or like payment confirmation. It will be my payment confirmation. All right, maybe our payment repository. Okay, so it's not of type payment confirmation. So it's just of type payment, of type notification, sorry, not the payment at all. So notification, that was the mistake. And now the error should be gone. All right, so first, as mentioned, we save the notification. And then what we want, so first let's construct, so here we will send the email. So let's leave this one as a to-do, send email in here. And in the same way, I will copy paste this method and I will just adjust it. So here it will consume our order topic instead of payment topic. So it will be order topic, and here it will be order confirmation. Let's rename this one to order confirmation just to be compliant. And here consume order confirmation notification. And let's call it this way, order confirmation notification. So here, let's keep the message consuming a topic from order topic. And then we need to change the type. So here we will use the order confirmation instead. And here, let's say, instead of payment confirmation, let's call it order confirmation. Now, all we need to do is to send this email. So now let's go back to our notification. So this is payment. This is a bit confusing. So, okay, so here we are under notification. So let me make it wider. So here we are under payment notification project. And in here, I will create a new class and I will call it email service under the package called email. So I will create a new package called email, and inside it, I will create a class called email service. So first of all, we need to make this one a service and required args constructor to inject our dependencies. So for that, we need first our private final Java mail service. So Java mail sender, sorry, not service. Let's call it mail sender. So as mentioned earlier, so for later on, we will add the configurations and the properties for everything, like for the mailing, for Kafka, and so forth. But just first, let's start with the code and we can add the configuration later. Then I need my private final Spring template engine. So this one, it's the one from ThemeLeaf, and let's call it template engine. So here, what I need to do, first, I will make my method async. All right, so because when we receive a notification and we want to send an email, we don't want to block the whole process until the email is sent, so we can make it async. And when we have an async call, what we need to do is we need to enable async. So here, let's go to notification application, and here let's say enable async. All right, so this configuration is done. Now we can go back and finish the implementation of our Java mail sender. By the way, for the people who followed already the book social network, you know that we implemented something like this, and it will be almost in the same way. So here I will create a method, public void send payment success email. So I will create one method for the payment and another method for the order. So here first we need to pass the destination email. So to whom I want to send this email. So destination email. Then I need to have a string customer name. Just this will be the customer name, and I will have a big decimal amount. So big decimal amount. And finally, I need the order reference. Order reference. All right, so now let's move on to the implementation. First, as you know, I need to create an object of type my message. So my message equals mail sender dot create my message. And then I will create a my message helper. So let's call it message helper equals new my message helper. And then I need to pass two parameters for it. So the first one, it will be the my message itself. So the object that we just created. And then we need to pass a my message helper dot multipart mode mixed related. So this value right here. So the multipart mode mixed related. And then we need to pass the encoding, which is UTF-8_8 dot name. So let's import this one first. So this one comes from, by the way, okay, so let me write it first and then we will import it statically. So it comes from the standard charsets dot UTF-8, and then we need the dot name method. So now we can import it statically. So add static import. And now we are done. Let's also do it for this one. So we have at least shorter message, or I can break it or break the line so you can see everything. So here, this my message helper, it might throw a messaging exception. So let's add the message or like the throws to the message signature. So now our message helper, the first thing that we need to set is the set from. So from whom we are sending this email. So let's say, for example, contact at Alibu, all right, alibocoding.com. So this is my my email. You can use it, or like you can send me emails if you want to. So then I will create a final string template name equals payment. So here I will create just an enum containing the list of the templates that are available for this notification service. So let's go ahead and do it. So in this email, I will create an enum, so a class, and then select enum, and let's call it email templates. So email templates. So this enum, it will contain two values. First, we have a payment underscore confirmation. So confirmation. And here I will add two things. So first, it will be the template name. So I will call the first one payment dash confirmation .html. So this will be the template name. And then I will add a subject exactly like the email subject. It will be payment successfully processed. So this is the first one. I can duplicate it. And the second one, it will be order confirmation. So here, let's say order confirmation. And here, let's say also order confirmation .html. And now let's just give it order confirmation. All right. So then what I need to do, since we have two properties or two parameters right here, I need to declare two things. So I will add a getter annotation since we need the get. So it will be private final string template. And then on the same way, I will need also, let me add the getter, and it will be a private string subject. All right, then we need, of course, to add a constructor with these two parameters. So template and subject, and that's it. So our enum is ready. So let's go back in here. So for the template name, we will select the first one. So here it will be payment confirmation, or like, let's say email templates dot payment confirmation dot get template. So this will be the template name. We can also import this one statically. And then what we need to do, since we have now we configured the email, we need to pass the parameters. So let me add this one to a new line. So I will create a map of type string and object. So I will call it variables, for example, equals new hash map. So equals new hash map, and then let's say variables dot put. And first of all, I need to set the customer name. So customer name, and then let's pass the customer name as a parameter. So I need two other properties or two other variables. Next, I need the amount. So we pass amount, and finally we need order reference. And let's call this one order reference. So we will prepare the templates later on. So this one, let's rename it amount. After that, since we work with theme leaf, we need to prepare the context. So context, the one from theme leaf, let's call it context equals new context. And then we can say context.set variables, and all we need to do is to pass our variables map. Then we say message helper.set subject, and our template name, or just template, like both of them are fine. And here we can say get subject, or we can use directly our payment confirmation.get subject, since we are using the enum right here. Then we need to add a try catch block. So first we have a string HTML template. So this is the object, and we need to call our template engine and ask it to process the template. So we need to process the template name and then the context. So like the context, as I mentioned, this is the container that will contain or will hold all the variables, and the template name is the HTML template that we want to process. And then we need to set the message helper.set text. And for the text, we need our HTML template and the flag HTML to true. So as you can see, first we have like this first constructor, and the second one is string text with a boolean HTML. Then we need our message helper again and set to, like to whom we want to send this email, and this will be sent to our destination email. And finally we have mail sender, and then send our my message. So finally, let's log a few data. So it will be log.info. So log. Okay, I did not include my SLF for J. That's why I didn't have the log. So log.info. And here, let's say, for example, our string.format method. And here we say, for example, this is an info level and email successfully sent to %s. So like this, to whom we want to send this one with template %s. So here, for example, yeah, that's it. And here we need our destination email and the template name, and that's it. Okay, so now we need to catch. So what we need to catch? We need to catch our messaging exception in case something happened. So let's call it E for a simple name. And here let's say log.warn. It will be just a warning. So let's say warning and then cannot send email to, and here all I need to do is to pass my destination email. All right, so let's optimize the imports. And then in the same way, we will implement a method to send order confirmation email. So I will duplicate this method just to go or to move faster. And then I will show you what we need to change. So here we will call it send order confirmation email. So let's rename this one order confirmation email. And then we need the destination. We need the customer name. We need the amount, the reference, and we need also the list of the products. So here I will create list of products and let's call it products. So far everything stays the same, except here we need our order confirmation enum. So let me also paste it in here just once and for all. And then we need few parameters. So we need the customer name, and the same way we need here an amount. So let's call this one total amount. So this will be the total amount. We'll have the order reference, and we need another object, which is the products. All right. So, and here it will be products. So this part stays also the same. So we can also refactor the two methods and make it more generic, but this is not so important because like the most important one, or like the focus of this video, is to learn microservices, not how to send an email. All right, so here we have our template engine, we have the template name, and we have everything almost the same, so nothing we need to change, and that's it. So now we have our email service implemented and ready to be used. Let's go back to our notification consumer and let's bring this one. So here it will be email service. Let's import this class. And now instead of this to do send email, all we need to do is just to send an email to our customer. So here first I will start by creating or initializing a customer name object. So here I will call it customer name equals payment confirmation dot customer first name. It's just a simple concatenation, like nothing fancy, plus, and here payment confirmation dot customer last name. And now all I need to do is to call my email service dot send payment success email. And here I will pass the parameters. So the first one, it will be payment confirmation dot get customer email. And here the customer name. Then I need my payment confirmation dot amount. And finally my payment confirmation dot order reference. Let's remove this one. So since our send email, send payment success, so let me rename the method. So it's send, not sent. So since this method throws messaging exception, so we also need to throw messaging exception or surround it with try and catch. So let's all just add it to the method right here. Okay, so I will copy this one. And now we need to replace this to do in the consume order confirmation notification. So here it will be, instead of payment, it will be order confirmation. So let me replace it. Let's paste it in here. And now it will be dot customer dot first name. And here it will be order confirmation dot customer dot last name. And we need parentheses in here. All right, so here we need also again our order confirmation.customer.email. Let's replace with this one. The amount is our order confirmation.total amount. And here we need our order confirmation.order reference. And finally, we need our order confirmation.products. And this one, it's not send payment success email. So send order confirmation email. And of course, we need to rename it since we made a typo. And also we need to add the exception to the method signature. And we are done. So now we have our notification service implemented. So let's just recap really quick. So what we did in the beginning, so we created the project, we added the dependencies, and then we added we created a notification document, just a document to contain the information of our notification. And then of course we need a repository, and this is just an enum to differentiate the type of the notification, whether it belongs to the order or to the payment. Then we know that we will consume two types of data. So first we have the order. So here this is the order confirmation object, and as you can see, it contains order reference, total amount, customer, and products. So we need to create the customer, and also we need to create the products. In the same way, we created a payment confirmation object containing this information within the payment method that we declared in the payment. And then we created our notification consumer, which is like two simple Kafka listeners. One listens for the payment topic and the other one listens to the order topic. And here what we did is just to pass the object that we are expecting as a parameter to this method. And all we need to do is to process it, send the email, and do what we need to do with it. And finally, we implemented our email service. All right. So now just to finish with this one, let's close all. And now we need to add the properties for our notification service. So I will change this one to YAML representation, and I will make it full screen. And now we will add the properties to our payment service. So here, first of all, it will be application and then name and notification. So here, let's call it notification service as always. And now I will go back to my config service my config server to copy few properties instead of just retyping everything. I know my customer service uses MongoDB, so I will copy this part. So we can start with this one. So here Spring, and then we copy the MongoDB properties. And then I know also that my order service has the Kafka properties. So I will copy and show you what you need to adjust. So let's copy all the Kafka part. And let's come back in here and paste this Kafka in here. All right, so now, since our notification is the consumer, so instead of producer, we need to change this one to consumer. All right, so for the consumer, what we need to do? So we need first our Bootstrap servers. We need to define the group IDs. All right, so I will move it to the up. So here I will create two groups. So first payment group. So like one group for payment, and order group. So order group. So these are my consumers. And then we need to define the offset, or like the auto offset reset. And let's say earliest. So if you are missing a few information about Kafka, please refer or go back to the Kafka video that I published before in my YouTube channel. And here, when we talk about consumers, we do not talk about serializer, but we talk about deserializers. And it's the same for the value deserializers. And now we need to add properties. So the first one, or like the one we see in here, stays as it is. So here we have the spring.json.type.mapping. And here we need to map it, as I mentioned before, in the same way. So we have order confirmation, which is com.alibu.commerce, and like we need to specify or to provide the full package of this one, since we consume two types of data. So here we need to go to our payment service, and we need to copy also this one. All right, so we need to copy this mapping. And be careful of typos, since if you have a typo, you risk that the application or like the Kafka consumer will not work. So here we just separate it with a comma. So here we add a comma and then payment confirmation payment confirmation object with the package or like the full path of the payment confirmation object. Now we need to add other property. So here there is a property. So by default, Kafka has a security. So when we send an object of type order confirmation from a specific package, you will get an error message saying that this is coming from an untrusted location or an untrusted package. So what you need to do, you need to tell Kafka what are the trusted packages. So here you need to add another information. It's called spring.json dot trusted packages. So trusted.packages, and then you need to specify the list of the trusted packages. So when you are working in development mode or locally or like in a non-protected environment, so you can accept, or you can say it's okay, we can accept star. Otherwise you can say, for example, I want to accept anything coming from com.alibu.ecommerce.star, for example, or you can provide the list of the packages separated with comma in here and to tell these are my trusted packages. All right, then what we need to do, we need to add some mail properties. So in the same way as we did it before, so here we will provide the properties, and then first let's say host, and it will be localhost, since we will use mail dev, and we need to specify the port, which is 1025, and you just a username, let's call it Alibu. So you can type anything in here, so it's not mandatory. So and then Alibu, and let's define some properties. So the first property will be mail, and then let's say SMTP, and then let's say trust star. So like we want to trust anything since like also just a dev mail, or like it will be working locally. And here we have an authentication, and let's set it to true, and start TLS, let's say enabled, and then true. So it start TLS, and then we can also set a connection timeout. Let's set it to 5 seconds. This is like the basic configuration that I use almost everywhere. And here we can also define a timeout of 3 seconds and a write timeout of 5 seconds. So these are the configurations of my notification service. So I will select all, and then in the config server, in the configurations, I will say here I want to create a new file, and I will call it notification-service. Of course, .yaml, don't forget the extension of the file. And here all I need to do is to remove this one. And finally, don't forget to define the server and then port. So for this one, let's use the 8040, for example, since we used the 8050, 6070, and so on and so forth. So for this one, let's use the port 8040. That's great. Now we have almost all the microservices implemented. So here we just need to finish this one. So let's go back to this. Let's do some cleanup. We need to leave only the Spring application name, and also we need Spring config.import. So config.import, and here let's say it's optional, and then config server and our config server address or URL. So it will be localhost and then 4 times 8. So this is what we need to define for our notification microservice. So let's close everything, and now let's go back to the diagram. So here I cannot use a check mark, but we implemented customer, product, order, payment, and notification. We also have our Eureka server or discovery server, and we have also our config server. So now in order to start testing the application, all we need to do is to implement our API gateway. But one last thing before moving to the implementation of the API gateway, we forgot to create our email templates. So let's go back to notification and then source, main, resources. And here all I need to do is to create a templates folder. So let's create first a folder, and we will call it templates, because Themeleaf will automatically fetch the templates from here. So now let me open also the email templates and just copy the names. So here I will create a first file and I will call it payment confirmation.html and another one order confirmation.html. Meanwhile, I will ask ChatGPT and I will provide it with the context and as much information as I can, and I will ask him to generate two templates, one for the payment and one for the order. So I will just paste you the code, explain quickly, and then we will see the output later on when we test the full application. Alright, so now I have here, this is what ChatGPT generated for me. So it's simply it's a simple HTML file with payment confirmation title with the customer name as the information that we passed. So this is the theme leaf text. So this will be automatically interpolated and mapped. So here the same for the payment. So this is the amount, the order reference, and here this is a simple thank you message. So in the same way, I will paste the code from the order confirmation. So for the order confirmation, it will contain the order details as a header or a title, the customer, the order ID, and here we will have a table containing the product name, the quantity, and the price. And here we are looping over the products that we passed as a parameter. And finally, in a footer, we will display the total amount and a simple message. And let's pretend this is just all rights reserved by my name. All right, so now we have the templates, we have everything up and ready. So now let's move on and start implementing the API Gateway microservice. Now, in the same way as we do always, so let's create a new project and let's call it Gateway. So it will be Maven, Java 17, and let's leave the package also as alibu.com.alibu and then e-commerce. Or for this one, we can also leave it as a gateway. So let's leave it as it is. And here we need our gateway. So it's not a reactive one, but just gateway. We need also our discovery client. And we need, of course, our config client. So here let's search for config and then config client. So this is all the dependencies that we need for our API gateway. So let's click on create and import our project as a Maven project. So plus, let's select gateway, pom.xml, and then open. So for the API gateway, really nothing fancy, nothing we don't need to write any logic. All we need to do is to provide some properties and some configuration for our API gateway service. So we need to route all the URLs. Once we receive them from the API gateway, we need to route them to the correct microservice using load balancer and using the service name. So let's go to our API gateway and then source, main, resources, and application.properties. So first I will change it to YAML file and I will make it full screen, and let's start adding the properties of our API gateway. So here, and let's all call it gateway service. So here first I will define my server port and I will make it 882.22. All right, so now let's add few properties. First we have spring.cloud.gateway, and then we have discovery. So I will just make it manually. So we have Spring Cloud Gateway and then discovery, and we have an attribute called locator. Let's set it to true. Locator and then enabled, and we set it to the value true. And now we need to define few routes. So at the same level. So here I think we are missing discovery, and then locator and then enabled true. So now in the same level of discovery, we will define our routes. So here we have an attribute called routes, or property called routes. So for this routes, we will define the different routes that we have. So here we will start with the first one. So let's give it an ID, which should be the same ID of our service. So let's call it the first one. We will start with the customer service. So then we will have a URI. So what should be, or what is the URI for our routes, or for this specific route? So here it will be LB for load balancing. And then I want to route, like when I receive something, I want to route it to localhost http / and then customer-service. So this is the service ID in the Eureka service. All right. And then we can define also predicates. So based on what? Based on which predicate I want to route my service, or I want to route my my URLs. So I want it to be based on a path. So when I receive something with the path /API/v1/customers /*, so like /customer/ anything, I want to redirect and to load balance this request to http :// service. So that's why we need to use our discovery service in order to avoid managing or like creating many instances, or like in case we have many instances, we don't need to manage each of them, or like where to route, what is the available one, and so on and so forth. So the API gateway will take care of that. So in the same way, I will copy this one and I will paste it in here. So the second one will be my order service. And in here, I will use order service, and in the same way, /orders /*. And then let's paste and implement the next one, which is our order lines, for example, order-lines. And here for this order-lines, I want also to redirect it to the order service. Okay, so here let's rename this one to order service. And then the predicates, when I receive something with order lines, so order lines, I want to redirect it to this one. All right, so here I see that we have some warnings. Let's check if we imported the correct dependencies. So in here we have config, we have Spring Boot Cloud Starter Gateway MVC. Okay, so it's not the Gateway MVC, it's just Spring Boot Starter, Spring Cloud Starter Gateway. So let's refresh the dependencies. And now, okay, all right, so now it looks much better. So hopefully my IDE helped me to figure out what are the missing things. So now we have, as I mentioned, we are defining the routes, or the different routes of our application. So the next one, let's add the product service. So here product service, and here I want to route it to product service, and the pattern or the predicate is /products. When I receive any request with containing this path /API/v1/product/ anything, I want to load balance my request to the product service from my discovery service. So here I'm just exposing all the microservices, but then we need just to filter them and expose only the ones that we see in this diagram. So like only the ones connected to the API gateway, which is customer, product, and orders. All right. So like the payment, we don't need it, but I will just mention it in case you need it. All right. So here I will just call this one payment service, and here I will also call this one payment service. And then we have the path. All right. Also, we need this payment because we use internally this payment microservice. So, for example, when we want to send or to start processing a payment from the order, we mentioned that we want to go back to the load balancer and proceed to the payment. But we can add later on a security level just to say or to mention that we cannot proceed, or like we cannot process a payment from outside the private network. So this also can be done later. So for the API gateway, this is all what we need. So I will select all, and then in my config server, source, main, resources, and then configuration, I will create a new file, and I will call it gateway service.yaml. And I will paste everything in here. So now I just need to remove this application name. And now let's go back here. And let's remove all the unnecessary things since we externalized them to our configuration service. And here we need to add our config.import. and then optional from our configuration service, and then http://localhost, and then 4 times 8. So this is what we need for our API gateway. Again, let me re-explain or clarify the properties that we have in here. So first, here we have our Spring Cloud Gateway. So these are the properties for our API gateway. And here we have discovery locator true enabled, discovery locator enabled set to true. This means that we want to connect to our discovery service, like we have in this diagram right here. So we want to connect, or we want that our API gateway connects to the Eureka server and fetches all the available instances and microservices from there. And then what we need to do is just to define the routes. So the routes, we define them in this way. So this is like a table representation. So the first one, it will be the ID. So we need to provide the ID of the route. So it's a customer service. We can also do that using Java. We can implement it using the code, but within the properties, it's also doable. And it's also personally, I prefer using it or doing it using the properties. And then this is the URI. So where we want to transfer or to redirect the request. So here we want to redirect when we get a request for the customer service, we want to redirect it, and LB is load balancing. All right. So we want to load balance it to the HTTP customer service, and based on what? So here we have predicates. Okay. So for the predicates, we have one of the properties or one of the predicates. We can do it based on the path. So when we receive any request containing /API/v1/customers /anything, we want to redirect or to load balance this request to the customer service. All right. So also we can add other predicates. Let's say, for example, headers, or header equals something. Let's say, I don't know, blah blah. So if I receive something with the header called blah blah with this path, or even without this path, so I want also to redirect this request to my customer service. So here you can play around, or you can customize the routing the way you want. In the same way, we implemented the order service, order lines, and as you can see in here, order and order lines, both of them, they will redirect to the same microservice or to the same service. But the only thing that differs is the predicate. In the same way, we defined the product and also the payment service. So now all we need to do is to start all the microservices. We need to start the whole architecture, and we need just to test it using Postman. And let's send our first request and see if we receive an email, if we are able to process all the data. But first of all, let's go ahead and check this information right here. So here we remember that we created the database product with a category and with a few products using Flyway. And here in the payment, we did not start yet the project, so we will start it. So let's go back to our payment service in here, and just let's check or recheck the DDL auto. So here, this one, let's say update, for example, for the payment. And the same way, so here it's create. So let's say also validate. Sorry, not validate, but just update, because I don't want to delete the schema when we restart the service. And now all we need to do is to start our application and start testing it. So let's move on to the test part. All right, so now we can start the testing phase. But before moving forward, I just want to highlight something, because while copy pasting some code, I just forgot to change a few things. So in our notification service right here, we have our consumer, and here we have the key deserializer and the value deserializer. So while copy pasting here, this one, it should be string deserializer instead of string serializer, and the same way for the JSON serializer. So because we copied it from here, and in here, as you can see, it was string serializer and JSON serializer, but for the consumer, we need to deserialize the values and the objects. Also here in these properties, and mainly in the Spring JSON type mapping, so here we mentioned that we want to map our order confirmation So this is the object. Let me re-explain it again. So for example, when we talk about the order, here in the order service, we said that we want to send an object called order confirmation, and from the producer, this is the package or like the full path of our object that we want to send within a key called order confirmation. And when we want to deserialize it, we need also to provide the same name or the same key right here, but the value should be also the path of our order confirmation in our notification service. So here, if I go down to our notification service and then source main Java, so here we have it in under com.alibu.ecommerce, which is this the first part right here, and then it is under Kafka, and then order confirmation. So like the URL or the path of this class should match exactly the path of the target object where we want to deserialize our order confirmation object. And the same goes for the payment confirmation. So also payment confirmation, it's under the same base package, and then Kafka, and then we have payment in here and payment confirmation object. So this is what we need to change before moving forward and starting our applications and start the testing process. So let me close this one once this is clear. And now all we need to do is to start the different services. So first, let's start with our configuration service. So I will start with the config, since all the microservices, they need to pull the configuration from our config server application. And here, just to make sure, so this one, we know that it's running under the port 8888. Then we need our discovery server application. So since all the applications or like the other microservices, when they start, they need to register themselves under the discovery application. So here, like you can notice something, or like you can early debug or see if something is wrong. So for example, let's assume that our discovery server application is not correctly pulling the configuration from our config service. So here we have our discovery server. So here we have the server.port, and here, as you can see, we have the discovery application, and it's running on the server or on the port 8761, which is the one that we pulled from our config server. So here I will just, for example, for the customer application, I will just make a change just to show you what I mean exactly. So here I will go to resources, and I will I make a typo in here. All right. So when I start my customer application, let's see what will happen in here. So now let's start it. So the application is up and running, which is okay, but as you can see, the customer application is running on the port 8080, which is the default one that Spring uses. So this means because we have this optional right here, so when we remove the optional, the application will fail when it tries, or like when it fails to pull the configuration. So this optional has two sides effects. So here, if we are not able to pull the configuration, the application will still start, but with the wrong configuration. So as you can see here, it's the port 8080. So whether you can remove this optional right here or leave it, or just make sure that you have the correct port of the application. So let me restart this one, and now you will see that the customer application port will change to the one that we specified already in the config server, which is the 8090. All right, so in the same way, let's start the other services. So we can start them in the same order as displayed in here. It's not a problem. So the notification application, it's not a web application. We decided not to do it, or not to implement it as a web application. So that's why we don't see a port right here. So again, or in the same way, let's start the order application, payment, producer, and finally we need to start the API gateway, since the API gateway needs to pull all the configurations from the discovery application. So, well, it's a reactive one. So like the API gateway, it's a reactive one, and it will keep on updating or on checking, or sending a heartbeat or a polling service, like you can call it, whatever you want, to our discovery application, and checks every time if we have an application or like a new application available with a new port and so on and so forth, like a new instance. So this will be also fine. But here, just for testing, we start everything. So we start with the config server and then the discovery. So these two are mandatory to be started first. And the first one that needs to be up and running is the config server, because all the other microservices, they need to pull the configuration from our config server Otherwise, we will fall to the scenario that I already explained about the customer application. And finally, now we have our API gateway up and running, and all we need to do now is to go to Postman, for example, and start testing our application. So here, as you can see, by the way, so here I just enabled the debug level for the API gateway, and that's why you see that we have this debug, and you will see this message even if I clean it, and like you will see this message or like these logs that the API gateway will keep reaching the discovery application or the discovery server application to see if we have new services or new instances available for us. All right, so now we can go to Postman and start testing the application. So here I prepared two endpoints. The first one is to create a customer reaching the localhost 8222, which is our API gateway port, and then /API/v1/customers. And the other one is to create an order it's supposed to request, and in the same way it will reach the API gateway and then API/v1/order with the information that we need to pass to our order application. But before that, I will just duplicate this tab and check if we can reach or like if we can fetch our products. So I will try products, and this one will be a get request, so we don't have a body. So I will just click on send. So here we see that we have a 200, and this is the list of our products. Since in our product service or product microservice, we have already an endpoint that fetches or returns the list of our products. All right, so now let's go back to this customer, and let's start or like let's try to create a new customer with this information like John Doe and the email john@email.com and this address information. So I will click on send. Okay, so here first we see that we have a 404. 404 means that we don't have this path, or like the API gateway is not able to find this path. So this means that maybe we made a typo in our customer microservice. So let's go back in here. So let's check the customer. So under Java and then customer, and the typo should be somewhere in here. All right, so here when we created the post mapping, it should be customers, not customer, or like we change it also in our Postman. But the best way is to follow the naming conventions of the APIs. So let's change this one to customers, and all we need to do is to restart our customer application. So I will restart it from here, and then we can proceed, or like we can go back to test our application. So the application is trying to restart. Also, we can check in the browser that we have all the instances up and running. So let's go ahead and check first. All right, so here if we go to the address localhost 8761, which is our discovery gateway, and all we need to do is just to restart or like to refresh our application. And as you can see here, we have for the customer service, we have one down and we have one up. So the one up is the one that we just restarted, and the one down because like for the old instance or like for the previously running instance, the discovery gateway or the discovery server will try to reach out this one. So like if we wait a few times and refresh this web view, we will see that we will only have this one up and running. All right, so here we see that we have our customer service, API gateway, notification, order, payment, and product service. So all the products are registered under our discovery server. So now if we go back to Postman and try to create this user, so let me click on send, and here we have a 200 response with the customer ID. So let's go ahead and check it under our Mongo Express. So we said that it's running under the port 8081. And by the way, if you get interrupted to provide credentials, the credential is admin and pass. So like admin for the username and pass like with PASS as a password. So here we see that we have our customer database got created since we inserted a new customer in the database. And here we see that we have customer. And then we can check the customer information, which is we have here the information like the first name, last name, email, and this is the address object. So if we create another one, we will also have the same information in here. All right, so now we can go back to Postman and we can proceed or start create of our first order. So also here in the same way, I prepared the body of our request. So the reference, it will be something like this. So here maybe we can change this one to 2024. 1201, or like maybe we can change the date, or like we can change the reference. And here we have an amount, we have a payment method which is PayPal, and we have a customer ID. So the customer ID, we need to get this one. So first let's try with the perfect scenario, or like with a nominal scenario, like providing everything in the correct way. So also for the product IDs, since we have our product database, or the list of products that we have in here. So let me refresh and let's check the product database. And in here in the product, we have public tables and then product. So in the product, we see that we have this list of products with the IDs that I provided in here, like 1-851, 2-251, and so on and so forth. So now all we need to do is to click on send and see if everything will go fine. So here we send the request, but we see our 500 internal server or error. So let's go back to our application and let's check the logs. So here, let's first check our API gateway. So in the API gateway, we see nothing, or we don't have any errors. So only these debug levels, and I will remove it just in few moments. And then let's go to our order application. So in the order application, we see that we have an exception. So let's go ahead and check it. And here among the exception, we have a Feign exception not found. We have a 404. So this means, or like it says, like a 404 not found during post, like when sending a post request to our payment microservice. So I think like, or I have the feeling that we also made a typo in the payment microservice. So let's go to payment and then source main Java and then payment and payment controller. So let me make it full screen. And yes, exactly. So this one is like, it should be API, not IPO. So here also I will go back to my gateway, since I enabled the debug level. So I will go back to API gateway, main resource application, and this one, like I will completely remove it because I just wanted to check a few things meanwhile. So now I can remove this one, and all I need to do is first to restart my payment application. So I will stop it and restart it again. And in the same way, I will restart my API gateway application just to remove this debug level that we saw altogether. All right, so let's restart this one, and then we can go back to Postman and send the request once again. So here we need just to wait a few moments until the API gateway is able to fetch all the services from the discovery, and now we can go back and let's now click on send. All right, so here we see that we have 200 and we have the ID of the newly created order. So now let's open the browser and check the mail and see if we receive an email with the information that we specified and the template that we specified before. So I will open a new tab and open my localhost 1080, and here we have two emails. So the first one, we have an order confirmation. So we have order details for the customer John Doe, and this is the order reference, that the one that we created. We'll create a new one and we will change the customer also. And here we see the information or the list of the products, which is the product name with the quantity and the price, and we have here a total amount. So like the total amount is not well calculated, but it's fine because this is just to test the microservice architecture. And here we see another email, which is the payment successfully processed. So payment confirmation. So here I think we also have an issue with the mapping of the username of the customer first name and last name. And here we see the information of our order. So like we can fix these few things in just few seconds. Now let's go and create another customer. So here in the customer, I will create, for example, Ali Bu Ali, and this one I will change it to ali@mail.com. We can leave the rest as it is. Let's create. So this is our new customer ID. Also, if we go back and check the customer database, we should see the Ali Bu Ali@mail.com. All right, so now let's go back to Postman, and here first I will just change something here. So like I will put something that doesn't exist. All right, so like a customer ID that doesn't exist, and let's click on send. So here we have our 500 error. So this first, like we need to handle all the exceptions in the order service. So this we can do it later on. And also let's go back and check our order application. So I will just clean and send again. And here we see that we have a 404 not found during fetching the customer with this ID, which is okay. And here we see that we have no customer found with the provided ID, and this is the log that we provided already in our customer microservice. So now let's go back. Let's take again our customer ID and replace it in here. So now let's leave this one to 2022-24, and let's say, for example, 401, and let's click on send. And now we have another issue. So let's go ahead and check it. So here we have insufficient stock quantity for product with ID equals 1. So here, if we go and check our product table, so here, let's go back and check this one. So now here we have the available quantity equals 0. So that's why we were not able to purchase this product. So maybe let's change this one to 40 manually, and this would be also fine. Like it's not a big problem. And now let's go back to Postman and send this one again. So now we have our 200. And if I open back the browser, so here first, let's go back to our database and let's check the notification. So the notification, we see that we have order confirmation, and this one, for example, is for john@mail.com, and we should see another one for ali@mail.com. All right, so this is the payment confirmation, and these are the information of our order. And here, this is the one that we just created. And for the customer, we see that we have the customer information, and for the product, we see also that we have these 3 product information. All right, so let's also check the email. So first, we have our order confirmation to the correct customer with the correct information that we provided earlier. Also, we have our payment confirmation. I think here we just forgot to pass the parameter of the customer first name and the customer last name. So we can fix that, and then we can proceed to the next part of our implementation. While testing the application, we saw that any of the services might throw an exception. So it might be whether a technical or a business exception. So here, let's focus on business exceptions, for example. So when we start an order, here we have two scenarios. So whether the customer does not exist, or the product, we have insufficient quantity, or the product itself does not exist, and so on and so forth. So also when we try to follow up, since we just already know the architecture of our application, but imagine that we are working in a new project and we are just onboarding on it, and we don't know the architecture and how the different components or the microservices are linked. So here what we need, so we need to enable or to have a tracing that gives us all the flow from like the entering request until the end of the request. So for that, we are talking about distributed tracing. So for that, we will install Zipkin and we will implement distributed tracing for our application. So first, let's go ahead and add Zipkin to our Docker Compose file. So I will close this one and then open my Docker Compose file, and somewhere here, for example, let's say Zipkin. So we will install Zipkin. So whether you can use Docker Compose, or you can just go to the official website zipkin.io and download it and use it from there. But since here we are using Docker Compose or Docker infrastructure, let's continue using this. So I will call it Zipkin, Zipkin without G, and then we have the image. So the image is from OpenZipkin. So OpenZipkin / Zipkin. All right, so /Zipkin. So this is the image. We can also use the latest. And here, let's expose some ports. So by default, Zipkin uses the port 9411 over 9411. So like the right-hand side is the port name, is the container port number, and this one is the one that we will use in our case. Let's also make Zipkin part of our network, which is our microservices network. So now all we need to do is again to run docker compose up -d, and we need to check that everything is up and running, as you can see in here. So the next step is to set up Zipkin for our application. All right, so now let's start with our API gateway. So here we will just follow the different microservices that we have here, like API gateway, customer, product, order, payment, and notification microservice. All right, so now in the API gateway, let's open the pom.xml, and here let's click on this edit starters, or like I will show you later on also the dependency that we need to add. So let's click on edit starter, and all we need to do is to search for Zipkin. So the Zipkin is part of the observability group. Let's hit OK, and here we will see that we have the Zipkin dependency. So here when we add Zipkin, it automatically will add the Spring Boot starter actuator. So the Spring Boot starter actuator, it's like a micrometer, or like it will expose some health check endpoints and like a bunch of other information that are needed. And the main dependencies about Zipkin is this one. I will just group them here. So here we have Spring Boot actuator, and here we have the IO Spring Boot Zipkin reporter and Spring Reporter Brave, and we have the tracing bridge Brave. So these are the three dependencies. If you have already Actuator, it will just add these two dependencies. So let's do the same for the other microservices. We also need it for customer. Let's go in the same way, click on edit, search for Zipkin, add, and then OK. So then in the same way, you will have Spring Boot Actuator and Spring Boot Reporter Brave. All right, let's continue for the other microservices. The same for notification. So here, click Edit Starter, search for Zipkin, select it, and click OK. And then we have Order, and then let's do the same way. Let's search for Zipkin, select this one, and click OK. So here you see that we are adding the Spring Actuator Brave and the Bridge Brave. And finally, or like last but not least, we have also our payment microservice. Let's add Zipkin, select this one, click OK, and finally we have our product. So here pom.xml and edit starters, and let's search for Zipkin, and let's click OK. All right, so I will close all the tabs, and here in the Maven I will update all the projects. So like I will select all of them and click on this on reload all Maven projects, so it will download and add Zipkin to the class path. So here, before moving forward and adding the configurations for Zipkin for the different applications, so here let's check something. So let's try, for example, to add it to the API gateway, and let's start with application.yaml. So since here we can see, or like we will have the auto completion. So here this information, or like the properties that we need to add, is under management. So it is under management, and then we have like Zipkin, for example. So let me show you. We have Zipkin, and then under Zipkin we have a bunch of information. So we have tracing.endpoint, we have tracing connect timeout and read timeout. So all these three information, they already have a default value. So let's check first the endpoint. So the endpoint, as you can see in here, it already has a default value which will point to HTTP localhost 9411. So like it's 9411. So this is the default port that Spring will try to use. So in case you are using a different port locally, or for your infrastructure in this case, so for example this Docker Compose file, if you decide to use another port, let's say 22 or something like that, just make sure to add this information right here. All right, otherwise it will be able to automatically get it from here, from the default value. The same for the read timeout and the other properties. All right, so like the same for the connect timeout, which is 1 second, and also the read timeout, which is 10 seconds. So for that we don't need this. All we need to do is to add tracing, and then we have something called sampling and then probability. So here let's check our probability and let's read about it. So the probability is simply like the probability in the range of from 0 to 1 that a trace will be sampled. So here in our case we want it to be 100%. So let's give it the value 1.0. So like the probability, it's between 0 and 1. So 0 means 0% and 1 means 100%. All right. So this is all we need to do in order to configure our Zipkin or our distributed tracing. So I will cut it, and now I will go to our configuration server, and then source main resources. And in here we know, or we remember, that we have our application.yaml, that all the files they extend from it. All right, so here all I need to do is to paste this property in here, and nothing else is required to do in order to enable distributed tracing with Zipkin. So now what we need is just to test the application, like to run the application, and then to consult Zipkin and see what is going on. Now, in the same way as before, I will start the different microservices. So I will start with the configuration server, and then the discovery, and then I can start all these services in the correct order. So I will select all of them except the API gateway and start all of them. So like they will be starting one after the other. And once they are all up and running, I will start my API gateway and perform the first request, or like one request, and see if we have everything, or like if we can see the tracing. So now we can start our API gateway. And meanwhile, we can go to the browser and have a look on the Zipkin UI. So here, let's navigate to localhost and then 9411. And here we have our Zipkin interface. So here we will see the list of all the requests, all the traces, and here we can perform a search, we can see the dependencies and bunch, or we can also run some queries, and so on and so forth. So now let's go back to our Postman and let's perform our request. So here let's first start with products. So let's try to query the list of products, which is success. And now let's go back to Zipkin. I will refresh, and here when you click on run query, you will see this. So here what we have our gateway service, which is an HTTP GET, and here it was reaching the API gateway service and then the product service. And here we see that we have 3 spans, right? So, or like 3 stops. So here if we open this one, so we have our API gateway, and then we have our product service. So here, for example, the product service, it took 109 milliseconds, and for the gateway service it took 215, and for all the requests it took 279 milliseconds to complete. Now if we go back again and try, so first let's check if we have a customer already. So I will refresh this one. Okay, database not found. All right, so we need to create a new customer. So let's create the customer. So let's keep the same information and click send. So here we have the customer ID. And again, if we go back to our Zipkin and let's go back to the home page and run query, we see that we have another one. So like this was the first one, which is an HTTP GET, and this one we see we have an HTTP POST. So we see that we have gateway service, and then we have our customer service. Again, we have 3 spans. So now let's perform, or let's purchase some products and see what will change in there. So first I need to copy my customer ID and use it in here. So like for the rest, I can keep the information as it is and click on send. So now we have a 200, and here we can go back, click on run query, and now we see that we have many things. So first I will order them by start time, just to see always the latest ones. So here we know that this one was to fetch the list of the products. This one is to create a customer. And now let's see. So here we have gateway and then payment service. We have now gateway product service, gateway customer, and finally we have gateway order service. So why we have that? So here when we let's go back to our diagram. Let me open it here and I will explain a few things. All right, so now when we first started, or like purchased an order, we hit the API gateway and then we went to the order microservice. And then the order microservice will perform 2 checks. One is regarding the customer, and the other one is to purchase some products. And finally we have payment. So here when we configured our application, let me remind you, in here in our config server, and then when we go to our order service.yaml file, we see here that we define these 3 URLs. So we have customer URL, payment, and then product. And all of them, they reach the API gateway instead of reaching the API itself directly using the customers, or like the API customers port or the payment microservice, and so on and so forth. So we decided that every time the order microservice needs to check something, or like to check the customer, we need to send the request again to the API gateway, and then we need to load balance it. So here Like this is one approach. Another approach is to use, since for example for the customer or for the product we are using Feign also supports load balancing. So we can use the load balancer or like the load balancing functionality of Feign in order like to redirect and communicate with the microservices internally without the need to go back to the API gateway. So here we can, for example, for the customer microservice, we can change the ports and see how this will be impacted, or like how this will impact our tracing. So it's just a test, so let's go ahead and do it. So for the customer application it's 8090, and the payment microservice it's 8060, and finally we have products which is running on the port 8050. Alright, so now since we have only one instance running, all I need to do is first to restart my configuration server, since I just change the config, and then I need to change my customer. I need to change I think I need only to change the order application, not change but just to restart the order application, since we changed the configuration for the order service, so we don't need to restart all the other applications. And also in here, like we can enable the auto reload. So if we change something, the order application will automatically refetch everything from here. So now let's go back to Zipkin and let's see if we can clear everything, or I think it's fine. So we can keep it this way. We will always filter or order it by the start time, and also we can change a little bit the limit, whether the limit or like the time, so we can fetch, for example, the last 2 minutes or 3 minutes just to check that. All right, so now I already have everything. Like I have my customer, I have everything. So here maybe let's change this one to 600 just to see the difference, and let's click on send. So now we have our new ID. And if we go back here and just rerun a query, we will see that we have another one. All right, so here we will order it with, we'll sort it, not order it, with the start time. And let's go ahead and check. So here we have our API gateway going to the order service. And then we have, all right, so let me just go back. All right, so now we see different logs. So here we have our payment service, which was reached, or like we used it from the order service. And then we have also our API gateway to the orders. Again, I need to, okay, all right. So product service, and then we have our customer service, and then we have our order service from the API gateway. All right, so this is how the tracing looks like now. So let's go back to IntelliJ and bring back our configuration as it was before, so we can keep it consistent. Let me restart this back. And now we have our distributed tracing using Zipkin. You can go and explore more and more Zipkin and check the functionalities and what Zipkin is capable of. Also, in the future, we will build another dashboard, or like another distributed system with using the ELK stack. So like the Elasticsearch, Logstash, and Kibana. And I will show you how to build a few dashboards, how to improve the logging, and how to improve like our application generally speaking. So now we will move to one topic, which is one of the most important topics when we are implementing an application. When we talk about designing and implementing a solution, security plays a crucial role in our application or in our architecture. So for that, in our microservice architecture, we will set up Keycloak to secure our ecosystem. And here, in order to secure our application, we know that all the requests, they go through the API gateway. So for that, we need to set up Keycloak and link it, or like validate each request coming to our ecosystem on the API gateway level. Then, for example, if for some, or like for example, let's say for the product service or for the order service, we have some endpoints that require some extended roles or authorities to do this action. So we can also set up the security in this level and link it to the same Keycloak instance to validate the user and to validate all the information, and if the user has the roles to connect or like to perform the required action. But for now, we will implement our security on the API gateway level, and that's it. That will be, or like that should be enough to secure our ecosystem. But as I mentioned, if you want extra security, you can also set up or like use this same way, or use it in the same way on the different microservices. And for that, also, if you are new to Keycloak, I would like to invite you first to check the 2 videos that I have on my YouTube channel, which is the Keycloak videos, and also the one that we used to integrate it with the Book social network in order to have a complete vision, or to move, or like to understand how Keycloak works and how we can configure everything. So for now, we will not be focusing on Keycloak, or like how Keycloak works, how to configure it, how the flow is, but we will just assume that you already know this information, and we will proceed from that. So the first thing, we need to start by setting up Keycloak in our Docker Compose. So here, after Zipkin, I just copied the configuration from the Book social network Docker Compose file. I will just perform few changes. And here I will just call it Keycloak for microservice. I will use the 2402 or like any other recent version. And I will expose locally the port 9098 or 9099. And here for the environment, we have our Keycloak admin and Keycloak admin password. It will be admin, and for the network, let's assign it to the same network. And of course, we need the command start dev in order to start our server. All right, so now we have Keycloak set up and ready to be used. Now let's move to the services and then API gateway. So in the API gateway, here we can add the dependency from here, like using the starter, and all we need to do is to search for our resource server, which is our OAuth 2 resource server. So let's select this one, click on OK, and let's check the dependency, which is this one. So it is the Spring Boot Starter OAuth 2 resource server. Then let's go and add some properties. So here in the same way, we will externalize it to the config server. But first, as we do always, here all we need to do is to add the following properties, which is spring.security. And then we have OAuth 2, and then we have resource server, and then all we need to do is to specify the JWT URI, and then we need our issuer URI, and it will be http://localhost and then 9098, and then of course we need realms. Let me make it full screen. So realms, and then for example, let's say microservice, or like let's call it microservice. So we did not create the realm yet, but we will create it just after that. So we have our realm will be called microservice or microservices. All right, so now we can start our Keycloak instance and go and start create our realm and create our client for that. Now we can create our security configuration. So I will create here a new class in a package called security, and I will call it security config. So here we have few differences from the classic security implementation, even with Keycloak. Since here we have a microservice architecture, and on the API gateway, it's a web flags or it's a reactive one. So here, let me show you what I mean. So here, when we go to the Spring Cloud Starter Gateway dependency and click on it, so here you see that we have this dependency called Spring Boot Starter Web Flag. So this means that we have a reactive web in here. So let's first add our configuration in here, and then we have enable web flags security. Instead of enabling just web security, we need to enable web flags security. So now what we need to do, we need to create a bean, and it will be a public security web filter chain. So instead of just security filter chain, this one will be security web filter chain. So let's call it security filter chain. And here we need to pass an object of type server HTTP. So let me fix the typo. Server HTTP security. So let's call it server HTTP security. And now let's add the configurations. So first, what we need to do is our server HTTP security.csrf. So first we want to disable the cross-site resource forgery. So to do that, it's server HTTP security, and then we have CSRF spec, and then we have a disable property. All right, so then we need to authorize few exchanges. So here, instead of authorized requests, when we talk about reactive web, we talk about exchanges. So here we have exchange, and then we will use lambda expression. So it will be an exchange, and then I will add few properties. So first I want to, for this path matcher, which is, so here like we are talking about Eureka. All right, so we want to authorize all the requests for our discovery server. So it will be /Eureka/**. This one I want to permit all. And then any exchange, I want it to be authenticated. So here, authenticated. And then we need to define our auth2 resource server. So here I will add auth2 resource server. And for this one, we need to customize it for our JWT. So it will be, for example, let's create a variable, let's call it auth2, and then we will use our auth2 object dot JWT, and then we can use our customizer, and then with defaults. So we will use the default implementation or default configuration from Spring. And finally, all we need to do is to return our server HTTP security dot build. So now we have the configuration or the security configuration for our API gateway that will filter all the requests except the Eureka. So this one will be permitted, and all the other requests should be authenticated. Now we can move on to Keycloak, create a realm, create a client, and then we can start, or like we can do or perform the testing process. So let's open the browser and let's go to localhost and then 9098. So this is our Keycloak, but first we need to do a docker compose app, since we docker compose app -d to have all the instances or all the containers up and running. Now if we refresh this page, so we will have our Keycloak interface. All right, so here let's log in with our admin, and here all we need to do is first to create a realm. So let me close this one. So here let's create a new realm, and let's call it in the same way as we did in here. So let me close all this, and then we go back here, and this is our realm name. So we will move this configuration then to the config server, but now let's finish implementing this one. So here I will call this one microservice, and I will set it to enabled true. And then in the clients, all I need to do is to create a new client. So let's leave it OpenID Connect, and here let's call it microservice API or client or whatever you want. So here we can also keep the same name as a display name, the same for the description. We can also enable this one to see it on the UI, which is totally fine. So here I will enable authentication, client authentication and authorization, and I can disable this too. So like I don't want to authorize any flows except client authentication and authorization, and I will show you what is the impact of these two buttons. So here the root URL and the home URL, so let's leave this one as it is. And now we have our configuration or our client. What we have in plus is this credentials tab. So in this credentials we have our client ID, which is this one. And also we have our client secret, which is this one. So in order to authenticate a user, so for this one, like we can go back in here and disable this client authentication and authorization, and enable whether the standard flow and the direct access. So in that case, or like in this way, we can enable the user registration, and then the user login, we can authorize the user login within the grant type password, but for this time we will use the grant type client ID and client secrets. All right, so like we can play with this one. So let's click on save to save all the changes, and then we will need later on when we go to Postman, we need to pass this client ID and client secret. All right, so now we have everything up and running. So let's go back to our IDE and start all the microservices. So as always, we need first to start our config server application, and then the discovery server, and finally we need to start our API gateway. So I did not yet move the configuration to the config server. We can also like keep it in here, so it's not a problem, and then we will move it to our our configuration server and do like a final check. So now I will select all these services or like servers and start them at once. And finally, I will start the API gateway, and we will see if Postman will allow us to reach, for example, the list of products, or to perform an order or create a customer, and so forth. So now let's make sure that our API gateway starts correctly, which is the case. Now we can go to Postman and perform the first request, and let's try to fetch, for example, the list of products. So here we have products, and if I click on send, we see that we have 41 unauthorized. So now in order to do this, or in order to authorize our user, we can go to authorization, and then we have OAuth 2. And then in here, what we need to do is to configure a new token. So here we can, for example, specify token name, and here we have the grant type. So the grant type is not an authorization code, but client credentials. So for these client credentials, we need to specify few information. So first we need the access token URL, which is the endpoint for the authorization server. This is used to get the access token. And then we need the client ID, the one that we created, which is, I guess, Microservices API. And then we need to copy the client secrets. All right. So then, and then like we can leave the rest as it is, and we can test or like try to get the access token. So now the question, where to get this access token URL. So let's go back to our UI, or like to our Keycloak UI, and here in the realm settings, if you scroll down, you can see the OpenID endpoint configuration. So in here, or among these this information, you have something, it's called token endpoint. So let's copy this one. So it's like localhost, and then the Keycloak port /realm /the realm name, and then protocol OpenID connect /token. So let's paste this one in Postman. So this will be our access token URL. So the client ID, we already have it. We need now to get our client secret from our client. So here we have Microservices API, and then credentials, and let's copy this client secret. So now we can paste this one in here, and for the scopes we can leave it empty, or like we can, I think we can specify the OpenID and offline access. So let's try without it. And now all we need to do is to click on get access. So here we have authentication complete. Let's click on proceed, and this is our token. So let's click on use token. And now when I send the request, I expect the list of products. So as you can see here, we have now the list of products from our API gateway. So in the same way, if I try to create a new customer, so let's click on send, or maybe let's change few information first. And if I click on send, I get a 41 unauthorized. So now in the same way, let's go back to authorization, and let's click OAuth 2. And here we will, Postman will conserve all the configurations, and also this token, which should be valid. And now if I click on send, I should get 200 with this customer ID. Alright, so that was it for today's video. I hope you enjoyed it, and I'm happy that you reached the end of this video. So before we end this video, I would like first to invite you to subscribe to my channel if you are not already subscribed. Give me a thumbs up and leave a comment what you want to see next. And let me give you a heads up about what's coming in the context of microservices. So in the coming videos, we will explore more and more about distributed patterns. Like we will see this, how to implement circuit breaker, how to implement the saga pattern, and more of the distributed patterns. Also, I will show you how to set up or implement the ELK stack, which is the Elasticsearch, Logstash, Kibana, and so forth. So now, thank you so much for watching, and don't forget to share this video, hit the thumbs up, and also subscribe to my channel. Thank you so much, and see you in the next one.